ปีนออกมาเล่นกันข้างนอก
เดี๋ยวตกตายเห็นแล้วหวาดเสียว
แล้วคนที่ถ่ายคลิปบอกว่าไม่ได้เห็นครั้งเดียวหลายครั้งนะคะ ก็ตะโกนเตือนทุกครั้งคือปีนออกมาเล่นกันอยู่ตรงระเบียงเนี่ยค่ะ
ดูภาพนี้น้องใบดอกต่อไปพ่อเด็กเป็นชาวกัมพูชาชื่อสุกรีใช่ไหม
เห็นคลิปแล้วพ่อบอกตกใจมากแล้วก็ขอโทษสังคมที่ดูแลลูกกับหลานไม่ดีนะคะคือคนหนึ่งลูกคนหนึ่งหลานตัวพ่อกับภรรยาไปทำงานในตลาดปกติยายเนี่ยดูแลอยู่แต่ช่วงเด็กแต่ช่วงที่เด็กออกไปเล่นที่ระเบียงเนี่ยยายน่าจะทำงานบ้านก็เลยไม่เห็นว่าเด็กซนแล้วปีนออกมาเล่นกันตรงระเบียงเนี่ยค่ะ
ปีนกันจากชั้น 3
ชั้น 3ค่ะแล้วตึก4 ชั้น
โอ้โห
ค่ะ
ที่ผมตอนโตก็พี่เลนเคยออกมาเดินยังหวาดเสียวเลยสารภาพนะแต่นี่เด็กเล็กมากไม่รู้ภาษาโอ้โหน่ากลัวจริงๆท่านผู้ชมฮะมาดูการบ้านการเมืองกันสักหน่อยเถอะเพราะร้อนแรงอยู่เหมือนกันเมื่อวานนี้ประชุมกันใหญ่โตทำงานกันเคร่งเครียดแต่ก่อนจะเริ่มประชุมกันใหญ่โตเนี่ยมีประเด็นว่าครม.อวยพรวันเกิดนายกรัฐมนตรีย้อนหลังใช่ไหม
ใช่ค่ะพลเอกประวิตรวงษ์สุวรรณเป็นตัวแทนค่ะเอาใจกันดอกไม้มอบให้ท่านนายกรัฐมนตรีแล้วก็อวยพรนะคะ
แล้วท่านผู้ชมดูงานวันเกิดแบบย้อนหลังแบบนี้ยืนกันห่างๆมีการกล่าวรายงานท่านนายกก็บอกคล้ายๆกับก่อนหน้านี้เนี่ยน้องไบร์ทก็คือเมื่อครม.ขอให้ตนมีความสุขทำงานให้สำเร็จผมก็ได้บอกว่าทุกอย่างที่อวยพรมาขอให้ถือกลับไปให้ครม.ทุกคนคือแนวคิดท่านนายกใครอวยพรอะไรปีนี้ขอให้พรนั้นส่งกลับไปด้วยใช่ไหม
ค่ะท่านนายกบอกอย่างนั้นนะคะ
แล้วก็บอกนะฮะได้อวยพรครม.ทุกคนก็เพราะว่าจิตใจเนี่ยมันต้องให้กัน
ทำงานร่วมกันมาตั้ง3 ปีแล้วไม่ได้เป็นศัตรูกับใครนะคะ
นี่ก็คือหลักภาษาชาวบ้านก็คือมันต้องใจแล้วมันต้องให้ใจกันแล้วทำการกันมา3 ปีขณะเดียวกันเมื่อวานนี้เป็นครั้งแรกหลังจากเกิดโควิดระบาดตั้ง2 ปีแล้วน้องไบร์ทท่านนายกฟื้นครม.เขาเรียกว่าครัวคณะรัฐมนตรี
คือทานข้าวร่วมกันนะคะกับบรรดาครม.ไม่ได้กินข้าวด้วยกันมานานแล้วนะคะตั้งแต่โควิดระบาดก็แยกชุดกันกินตามมาตรการ Social Distancing แต่นี่ค่ะนี่เดี๋ยวจะเอากลับมาใหม่แล้วนะคะก็คือครัวครม.
เอากลับมาแล้วเมื่อวานนี้
ด้วยกันเนี่ยค่ะ
นี่
แต่ท่านยืนยันนะคะว่าไม่ใช่การทานเลี้ยงย้อนหลังวันเกิดท่านนายกนะคะแล้วก็เป็นการทานแบบเป็นโต๊ะกลมลักษณะคล้ายๆกับโต๊ะจีนนะคะ
แต่เว้นระยะหน่อย
โต๊ะหนึ่งก็นั่งกัน 5-6 ท่านนะคะ
นักข่าวก็ถามประมาณว่าเดี๋ยวมันจะกลายเป็นว่าเป็นตัวอย่างไหมล่ะตอนนี้อย่าไปกินอาหารร่วมกันอ๋อนี่ตรวจ ATK ทุกวันเลย
ใช่ท่านนายกท่านบอกท่านตรวจ ATK ทุกวันค่ะบางวันท่านตรวจ2 ครั้งด้วยนะคะท่านนายกบอก
เมนูเมื่อวานมีก๋วยเตี๋ยวต้มยำตำลึงข้าวหน้าไก่ผัดไทยไร้เส้นข้าวไข่พะโล้แกงหมูพริกสด
ของหวานคือไอศครีมกะทิและเต้าถึง
นี่เขาถือเคล็ดอย่าไปกินไอ้ผัดไทยไร้เส้นเนี่ยมาดูเป็นเกาเหลานะหรือยังไง
ค่ะ
ท่านผู้ชมแหล่งข่าวบอกอันนี้สำคัญในคณะรัฐมนตรีอันนี้แหล่งข่าวนะผมไม่สามารถยืนยันแต่แหล่งข่าวบอกและลงกันตรงกันทุกฉบับเลยมีท่านนายกเปรยอารมณ์เสียบอกเลยทำไมเวลาทำอะไรไปคนหาว่าโง่มันเป็นยังไงต้องไป
คือท่านนายกรัฐมนตรีท่านกล่าวกับที่ประชุมอย่างอารมณ์เสียค่ะที่นักวิชาการออกมาเสนอแนะแล้วก็เขียนโจมตีรัฐบาลเกี่ยวกับการแก้ปัญหาเศรษฐกิจเนี่ยค่ะท่านก็เปรยประมาณว่าลองไปดูสิว่าเรื่องไหนที่เขาพูดแล้วเรายังไม่ได้ทำตรงไหนเราทำหมดแล้วทำไมสิ่งที่เราทำมันไม่ถึงประชาชนหรืออย่างไรทำไมประชาชนถึงไม่รับรู้เราทำอะไรไปคนก็หาว่าโง่และท่านก็ทิ้งท้ายบอกขอโทษที่อารมณ์เสียค่ะ
และท่านก็ถามถึงการแก้หนี้กองทุนกู้ยืมเพื่อการศึกษาไปถึงไหน
ค่ะ
รัฐมนตรีช่วยคลังสันติพร้อมพัฒน์ก็บอกกำลังดำเนินการได้พักหนี้ให้อยู่รัฐมนตรีมหาดไทยอนุพงศ์เผ่าจินดาท่านเสนอให้ตั้งกรรมการรับผิดชอบหนี้แต่ละส่วนเป็นกลุ่มก้อนๆแบ่งรัฐมนตรีหรือแบ่งรองนายกรับผิดชอบกันไปใช่ไหม
ค่ะ
และอยากให้ช่วยกันตอบประชาชนอันนี้ท่านนายกย้ำให้ตอบประชาชนให้ได้กำชับใครรับผิดชอบเรื่องอะไรแถลงเรื่องนั้น
ให้รู้
ประชาสัมพันธ์กันหน่อย
ใช่คือใครรับผิดชอบอะไรแถลงเรื่องนั้นไปเลยให้รู้ว่ารัฐบาลทำอะไรไปบ้างประชาชนไม่ค่อยรู้เรามีเวลาอีกปีกว่าๆอยากทำให้สำเร็จไปหารือกันมาอยากจะให้ประชาสัมพันธ์ผลงานที่ทำกันมาไหนๆเราก็จะอยู่กันอีกปีก็ต้องทำให้เข้มแข็งไม่เข้าใจว่ามีไหมที่พวกเราไม่ได้ทำเนี่ยหลายเรื่องที่ทำไปแล้วเขาก็ไม่รู้ อย่างการแก้ปัญหาสลากกินแบ่งรัฐบาลขายเกินราคาอย่างเงี้ยโควต้า VIP ตอนนี้มันไม่มีแล้ว
ก็จะทำพันหน่อยท่านตรีอนุชานาคาสายเมื่อวานนี้ออกมายืนยันปัญหาสลากเกินราคาท่านผู้ชมฟังดีๆแก้ได้แน่นอนภายในปีนี้แก้ได้แน่นอนมีความคืบหน้าเป็นระยะถึงแม้หลายท่านอาจจะบอกว่าแหมมันช้าเกินไปไหมแต่มันก็มีขั้นมีตอนนะท่านผู้ชมฮะขณะที่ก่อนจะประชุมครม.รัฐมนตรีสมศักดิ์เทพสุทินกับรัฐมนตรีอนุชานาคาสายนี่แหละก็เอาศิลปินดาราเป็นต้นว่าซุปเปอร์วาเลนไทน์เจนนุ่นโบเข้าพบนายกประชาสัมพันธ์เรื่องเกี่ยวกับ call center คือมีผู้อำนวยการกองของ DSI ท่านหนึ่งเนี่ยน้องไบรท์แต่งเพลงหนึ่งที่ชื่อว่าอย่าโอนเป็นสื่อมีการเอาซีดีมามอบนายกรัฐมนตรีด้วยนะถึงแม้หลายท่านบอกซีดีไม่ได้เห็นมานานแล้วนะเนี่ยนี่เอามามอบด้วยเพื่อจะเป็นสื่อประชาสัมพันธ์คุณสมศักดิ์เดียบอกนะครับว่ารัฐมนตรีหลายคนก็โดนแก๊ง call center แจ้งให้โอนเงินเช่นเดียวกันหวังว่าจะไม่มีรัฐมนตรีตกเป็นเหยื่อนะท่านสมศักดิ์ได้ยังไง
คือคุณสมศักดิ์บอกถ้ายังใช้วิธีปราบแบบเดิมเนี่ยมันแก้ปัญหาไม่ได้ทันแน่ๆก็เลยมอบหมายให้กองคดีเทคโนโลยีและสารสนเทศของ DSI เนี่ยจัดทำเพลงนี้ขึ้นมาชื่อเพลงว่าอย่าโอนเพื่อเป็นการสร้างการรับรู้นะคะ
ซึ่งนายรัฐมนตรีก็ชื่นชมนะฮะเพลงนี้แต่งได้ดีเพราะเรื่อง call center ระบาดมาต่อเนื่องสร้างความเสียหายในวงกว้างร้องเรียนกันหลายช่องทางนี่ขอให้ทุกหน่วยงานบูรณาการเร่งแก้ไขให้ประชาชนเป็นการด่วนป้องกันความเสียหายจะต้องประชาสัมพันธ์เชิงรุกให้เข้าใจง่ายรู้เท่าทันไม่ตกเป็นเหยื่อของอาชญากรกลุ่มนี้ขอบคุณและชื่นชมกระทรวงยุติธรรมรัฐมนตรีสมศักดิ์เอาเพลงนี้มาแล้วก็เลยถามต่อท่านรัศมีศรีตะละวรางค์ผู้อำนวยการกองเทคโนโลยีและสารสนเทศ DSI ไปแต่งสักเพลงได้ไหม
ท่านนายกถามเขาว่ามีแนวคิดจะแต่งเพลงอื่นอีกไหม
คือท่านนายกเนี่ยชอบเรื่องเพลง
ค่ะ
แล้วมันเป็นสื่อ
ค่ะ
อันนี้เนี่ยหลายท่านบอกแก้อย่างอื่นไม่ได้เหรอแต่ถ้ามองอีกมุมหนึ่งทำหลายๆทาง
ค่ะ
น้องใบผมมีความรู้สึกนะถ้าเราทำให้เพลงอย่างนี้มันติดหูเนี่ยคือเดินไปไหนให้มันหลอนเลยอย่าโอนอย่าโอนใครโทรมาก็เขาบอกว่าอย่าโอนอย่าโอนเราทิ้งท้ายพยายามอยากให้มันนี่เป็นสัญลักษณ์เลยเหรอ
นี่ค่ะทำท่าอย่างนี้อย่าโอน
อย่าโอนได้อีทปงลังสะออนแล้วก็ลำไยไหทองคำใช่ไหม
ค่ะ
ทิ้งท้ายเอาไว้หวังให้ติดหูแล้วก็เน้นย้ำอย่าโอน
ใครโทรกันมานักหนาใครโทรกันมานักหนาบอกเลย
แล้วมันเป็นสื่ออันนี้เนี่ยหลายท่านบอกแก้อย่างอื่นไม่ได้เหรอแต่ถ้ามองอีกมุมหนึ่งทำหลายๆทางผมมีความรู้สึกนะถ้าเราทำให้เพลงอย่างนี้มาติดหูเนี่ยคือเดินไปไหนให้มันหลอนเลยอย่าโอนอย่าโอนใครโทรมาก็เขาบอกว่าอย่าโอนอย่าโอนเราทิ้งท้ายพยายามอย่าให้มันเป็นสัญลักษณ์เลยได้อีก
ใครโทรกันมานักหนาใครโทรกันมานักหนาบอกเลย
แล้วมันเป็นสื่ออันนี้เนี่ยหลายท่านบอกแก้อย่างอื่นไม่ได้เหรอแต่ถ้ามองอีกมุมหนึ่งทำหลายๆทางผมมีความรู้สึกนะ
All right, a very good morning, everyone. Welcome back to our third and final day of architecting on AWS. It's wonderful to see all of you in early. Just about 10 of us, 10, 11 of us right now, just waiting for the rest to join in. But meanwhile, please do settle down and enjoy your cup of coffee. And again, those of you who are going to do the labs, if you've done the labs yesterday, you have any questions around that, please do highlight to me. Hopefully you had a chance to finish at least lab 3 or 4 of you in but please do kind of review if you can what we covered yesterday. I'll do a short recap later, but if you do have any immediate questions and areas for discussion and further clarification, I'll be more than happy to help answer that. But also do let me know how many extra days you'll be comfortable with if we extend the lab. I'll try to put in a request later this morning for the labs to be extended. If you have done the labs, you can repeat them if you want. I think there's a limit to how many times you can do it, but at least you can repeat them. That's not a problem if you want more hands-on. So do let me know how many days you'll be comfortable with to finish the labs and to do the capstone. The capstone is a little bit more lengthy lab, about an hour or so plus, maybe hour 15, hour 20, depending on whether you kind of do the steps quickly or not. But highly recommended if you do the capstone as well. So I think it'd be good that you invest some time over towards the end of this week or over the weekend to finish the capstone. But do let me know the number of days that you'll be comfortable with for me to ask the lab extension. All right. But meanwhile, I'll monitor the participants joining, and hopefully we'll be beginning in a short while. But meanwhile, please do settle back and make yourself comfortable, and I will be back with you shortly. All right, see you in a bit. Thank you. Oh, right. Right now it's about just coming 7 minutes past 9 a.m. in Singapore. Just check through. Attendance about 15 of us so far. 9 about 10 plus odd. Okay, I'll just get us started with a bit of a recap on the modules from yesterday and kind of lay out what we intend to do for this third and final day. Now, again, a word of thanks for all your patience and perseverance for the long 2 days, the previous 2 days. I thank you for staying with me and persevering through. And for those of you who stay back for the labs as well. And hopefully that although it's a bit of a rush, some of you at least have had the chance with some hands-on. With a bit of a recap, I will indeed request the labs to be extended. I'll just wait a few more inputs, 1 or 2 more inputs, and then towards the late morning period, I'll request for that extension. But nonetheless, let's do a brief recap on what we covered over in day 2. We actually started out with the compute module with the start of day 2 and talk about the compute layer. Of course, we talk about the full breadth of compute related services, but the main emphasis was on the EC2, where we went through the major configuration and design considerations in terms of the instance type, the AMI, the machine image, some of the configuration details like the block storage, etc. Very important. These are the fundamental components when you kind of design out and build out your virtual cloud server, the EC2. As solution architects, we need to be aware that the choice of our EC2 instance type and sizing has a great impact on performance and cost. And we just need to be familiar with how AWS has grouped these instance type families according to their use case. Now, again, you can Google EC2 instance type to get the online reference, and that's a very useful reference that kind of gives you the whole breadth of what is available in terms of, say, the general purpose instance type families, the compute optimized, the memory optimized, accelerated computing, storage optimized. So do kind of get a rough idea just to read through. Obviously, I don't expect you to memorize all the specs. I mean, there's no point to that. But a general understanding of why they are grouped together as general purpose types and compute optimized, what would be, very importantly, what would be the end use case. So for example, if you have a very graphic intensive kind of applications, graphics rendering, including game developments, etc., then you should be looking at accelerated computing, the G series, the P series. P series also a little bit more extra for machine learning. To get that GPU, for example, the graphics processing unit. Again, if you have machine learning kind of workloads, then you should be looking at P series or the inference service, the I and F, for example. So you should kind of understand what kind of workloads are you trying to support. If it's more typical web applications, the M series would be a good starting point to try to size up. If it's a small web application, you might even want to consider the T series. It's a smaller size, usually a little bit more economical, for example. So having a general understanding of your EC2 instance type and sizing, very important. And basically, we also talked about the fact that AWS has the compute optimizer to help us right-size our EC2 workload. So if your EC2 workloads have been running for, say, 2 weeks or so, the compute optimizer will kind of monitor that workload for over 2 weeks and be able to give you recommendations on, fine-tuning the instance type and sizing for your workloads. If you're planning for workloads, migrating workloads or bringing your applications or workloads to the cloud, you can also access the free online pricing calculator. You can just Google AWS pricing calculator to get a good feel or estimate on the likely services that you'll be used, how much they will likely cost you. according to the region that you'll be working on. Of course, in terms of compute, we also looked at Lambda, just to give you a flavor of serverless compute. We'll have a module on serverless coming up this morning. But Lambda, we kind of upfront talked about it in module number 4. They gave you that option instead of working with server-based type of approach. You can also consider service-based approach, microservices. We could talk about that in the coming module. But Lambda is one example of a serverless approach that can help you implement a microservice architecture or services-oriented architecture. So as solution architects, we just want to, be clear about which path to take. What gives you the competitive advantage in choosing one architecture over the next? Where does your competitive advantage lie? And increasingly, the competitive advantage is no longer in managing servers, but in innovating services. Because managing servers, doing the patching, configuration, etc., is a heavy responsibility. You have to take care of the networking, you have to take care of the firewalls, you have to take care of patching, you have to take care of host-based defense, etc. Whereas a service-based approach, a serverless approach, means that you trust the cloud service provider like AWS to provide you with a highly certified and secure compute environment that AWS will manage for you, and you focus on your service, you focus on your application, etc. So big choices to be made, but as solution architects, you must get a little bit more aware of the trade-offs and what decisions, the pros and cons. Now, I would say that if you have applications that you need to fine-tune at the EC2 level, that means you fine-tune the EC2 instance type, how much CPU, how much GPU, how much RAM, because that's your competitive edge. For example, if we are innovating on, say, a machine learning algorithm, and we really need to choose the right EC2 because that will give you the extra competitive edge in terms of being able to run those algorithms well. If you need that, or because of your security compliance and performance requirements, you find that you need to install the Oracle database on an EC2 and you manage it yourself because you need that level of control, because that's your competitive advantage. Then yes, you go for a EC2 based type of approach and you fine tune from there. You get that level of control for the performance, because that's where your competitive edge lies. But if your competitive edge is more on the innovativeness of your services, the mobile apps, the online gaming that you're pushing for, and you don't see a real competitive edge in managing those servers, then you should be thinking and planning ahead for a microservices type of architecture and a more serverless use a mixture of serverless and managed AWS services, because that would take a load off your administrative task, basically, right? So it's not to say that you always must go for serverless, but is to kind of balance out the options and understand the trade-offs. We next looked at the storage, and this is also a very key important topic. All in all, if you can recall, we talked about block storage, object storage, and file storage. And as a solution architect, we must be quite well versed to understand the pros and cons of each, the use case of each. Where does each option give you the most advantage? So, for example, the block storage, your EBS volumes, your instant store volumes, gives your server very fast access to these resources for performance, for real-time computation, etc. And then object storage for static content, files that don't change often, and you want a highly scalable, unlimited storage. Then object storage, is that choice for you, just to understand that also that the object storage obviously will not perform as fast as your block storage or file storage, but it is for social media apps, IoT, for data lake, for data analytics. It is a extremely cost-effective solution in terms of storing growing data sets. And then file storage, when you need a central file location, just like you have file servers on-prem, this file storage like EFS, FSx for Windows, etc., give you a cloud-based, highly scalable file storage solution where you need to share a common set of files, and you need the performance as well in terms of throughput, IOPS, as such. So use cases will be things like content management solutions where you kind of deal with a lot of files, content files, etc., or any kind of data analytics or any application that work with data sets in the form of files that you need to change, modify, save, access, etc. Among EC2, quite a fair bit of EC2 on-prem and on-cloud EC2 servers, then the file storage will be a good choice. But have that in mind, a big picture, and then you go for the detailed levels of what does S3 give you, for example, what EBS gives you, for example, in terms of the EBS volumes, which volume to choose, for example, S3, which S3 storage class, how to optimize your cost using S3 storage class, what does a version S3 bucket give you, what an advantage in just having the version objects, undelete, etc. And the file storage, if you're on Linux, NFS, Windows, SMB, etc. So have some level of understanding and comfort in trying to make these choices. And as in most cases, in your architecture, it will likely be a combination of storage services, block, object quite commonly, and also file storage for certain use case scenarios. For high performance computing, recall that we have FSx for Lustre as well. So this is extreme performance when your high performance computing nodes can refer to the same file storage and get an extremely high IOPS and throughput for those high performance requirements. And then we went to talk about the database layer, and the key fundamental understanding for us as solution architects, the relational SQL versus NoSQL, right? Have an understanding of how you choose between the both. When your application or your scope is small, I mean, not small, but a little bit bounded, well-defined, like a typical enterprise, you're talking about a few thousand users, etc. Your relational SQL has a lot of advantages. It is very consistent. It's a well-understood database technology, for what we call as online transactional processing, a lot of our database, fantastic, right? Whether they're talking about Oracle, MySQL, Postgres, they will give you fantastic performance, very consistent performance, etc. But in situations where you're talking about social media app, when you're talking about a very popular e-commerce site application, when the scale moves beyond your typical few thousand users kind of scope, then start to think about NoSQL, but know the limitation of NoSQL. Relational SQL can support very complex queries because of the relational setup and the strict schema of the database. NoSQL, very flexible schema, but can only support simple queries. Can't support very complex queries and processing. But for NoSQL, it's the throughput, it's the scale. You're talking about a few million users. Think of Grab, for example, Facebook, Instagram. When you're talking about that scale, there are front-end components that deal with the customers, the web front and the order processing, sales transactions, etc., shopping cart, etc. That typically will involve some form of a NoSQL. Whereas the back end, where you do sales analytics, you do maybe some business intelligence processing, that usually can be in your relational SQL, the traditional relational SQL, also data warehousing as well, the columnar SQL as well. So again, as solution architects, it's not a matter of either or, it's usually both end. That means when you take a broad view of your architecture, some can be well served by NoSQL type of databases. other parts of your architecture will be well served by your traditional SQL. Right? When we look at some of these other considerations as we go along today as well. In terms of monitoring and scaling, this is it's about leveraging the scalability of the cloud, where it will be very difficult, if not impossible, to have on an on-prem kind of situation where we're limited by the physical compute resources we have on-prem. On cloud, we can be able to dynamically scale on demand. Right? That's the key thing out of this module. But in order to scale well, in order to have this dynamic scaling, we need to understand what is happening in our environment. And this is something that is a must in the cloud environment. You must have 24/7 monitoring and automation in terms of monitoring your environment. And we talked about services like CloudWatch that can monitor metrics, standard default metrics from AWS resources, custom metrics that you can install the CloudWatch agent on your EC2 to get system level metrics and application level metrics, to collect log files, send it to CloudWatch logs, for example, and configure automated actions. For example, if you're monitoring CPU utilization, to have that alarm, define a threshold and define an alarm action if that threshold is exceeded over a period of time, and be able to get some automated notifications and actions. And that leads on to scaling, because we need to scale on real-time information, not on, guesswork basically, or manual action. And so you could have scheduled scaling if you have very predictable times where you need additional compute resources, and also dynamic scaling based on real-time information coming in. And if your servers are getting busy, you provision those scaling. So very important from an architecting point of view, that we must build in this resiliency and scalability, sometimes the term called elasticity. That means you're elastic to scale up, to expand your server resources, and elastic to shrink or terminate unnecessary resources. And that's what we mean by elasticity, on-demand scalability. Very important consideration for solution architects to have. We round up our discussion yesterday on automation and the need to basically use templates, infrastructure as code, use Terraforms. Some organizations use Terraform, but the native template tool or service in AWS is CloudFormation, and be able to use CloudFormation templates in order to define the design, the configuration of our architectures, using these templates and using templates to deploy our environment. So this is actually is a must if you're operating on cloud. Now, for our learning, like what you did in the labs and testing, it's fine to do, command line and the management console. But once you move to production scale on the cloud, you can't run away from automation. You can't run away actually from using things like CloudFormation templates, etc. It is a must, because you cannot afford guesswork. You must test the templates out. Once it's tested in a test environment, you use the templates to also deploy your resources in staging and production. And so, in fact, best practice for your infrastructure design is something very different from on-prem. For infrastructure support, and I know some of you are in infrastructure supporting roles. We have to treat our infrastructure as software, and we have to adopt software development lifecycle discipline in designing, provisioning, and managing our infrastructure. Right, so you practically have a CI/CD, continuous integration, continuous delivery type of pipeline, also for your not just for your software application projects, but also for your infrastructure lifecycle. And you implement changes, as I was saying yesterday. You implement changes through the templates as well. Right, so this is also a very important concept. Now, for today, we're going to just continue our modules here. We're going to first of all talk about containers, how a lot of organizations today are moving towards containers to achieve a level of portability and consistency on their application components. And we will talk about why that is the case, and talk about the container orchestration environment as far as AWS is concerned. And we're gonna, I'm probably gonna leave networking for the moment. I'm gonna cover serverless first to make sure I cover this topic. To talk about what are, apart from Lambda, what are other serverless services in AWS that helps us architect out a serverless compute environment. Look at some of the supporting services, and then we'll have a lab time, and hopefully we'll be able to schedule that as part of just after the lunch hour as well, to give you a little bit more time to manage. And then we'll cover the part 2 of networking, where we talk about a little bit more networking options in terms of external connectivity for your VPC, and some of the newer features in and around of your VPC. And then we'll cover the edge services, basically CloudFront, for example, how we deliver content, and other edge services that we've introduced to you, including Route 53, and another service called Global Accelerator. As the last topic in the afternoon, we'll talk about backup and recovery, how we can use the cloud as one of the key components of a backup and recovery strategy for our organization. In fact, a lot of organizations may still have extensive or substantial on-prem workloads, but they use the cloud as backup and recovery. And that I'll brief you on the capstone as we round up our time together. All right, with that, any questions or any areas that you want to bring up for discussion based on our last 2 days of discussion, please do let me know and put it on the chat. I'll be sure to take a look at it. All right, meanwhile, let me just monitor the attendance here. It's quite... about 8 or 9, but I'll keep on monitoring the attendance. Meanwhile, we will proceed with this topic on containers. All right, check-in poll question: what percentage of your workloads run on containers based on your current environment? Okay, so yeah, a number of you actually. Okay, from less than 10%, but I see a number. I see a number of you above 10% as well. So very good. You know, that's quite typical as well. Usually between about 10 to 50% from you know, most customers in our region here. But that's good to see at least some of you already on that. So let's look at containers. Some of you are already aware of that, and in fact, you are practicing it. But I'll try to give us a little bit of a background so that we are all on the same page in terms of understanding why of containers and why organizations are moving to it. Let's look at this input here from our compute operations manager. Currently, only 27% of our workloads are on containers. We expect this percentage to double, 50-odd%. Over 90% are Docker with the Kubernetes environment. At the core of our container expansion is the fact that we have 68 legacy applications ready to be re-architected. So, and we'll talk about some considerations around that. We need to refactor some of these applications. And so this will lead to further demand for container infrastructure. So although we won't be working with application code, everyone needs to understand the significance of microservices and containers for modern application development. So we have to be aware of this emerging need to re-architect around microservices, or sometimes we call it a services-oriented architecture, or SOA, and the use of containers as part of that strategy. So again, we're going to look at the individual end user perspective and take them one at a time. And if we look at the containers architecture, this so far we've been talking about server-based architecture, and we just want to introduce the difference. What is the difference between a virtual machine-based EC2-based type of architecture versus a container one? In a container architecture, you still need a compute. Obviously, you have a choice between maintaining your EC2 infrastructure to host the containers, or a serverless option in terms of Fargate to allow the Fargate service, the AWS, to manage the underlying server infrastructure for you while you focus on your container. So these are the two main options as solution architects to consider. But first of all, let's look at microservices. These are the three kind of sections or solutions we want to introduce to you. Let's start with microservices, where the application developer says that my manager told me we should use microservices, but I don't know quite why we should be using it. So let's look at this scenario where we want to, as a best practice, introduce loose coupling or decoupling in our architecture. Now, over on the left is a not so optimal situation where your web tier and the app tier, they are tightly integrated together. And what we mean by that is that each of the web servers here, they need to be configured to point to each of the application servers, basically. And that means that these web servers are tightly coupled. Now, every time you add in an application server, you have quite a fair bit of work to do. Each one of these web servers need to also be configured to point to the application server as well. Right? And every time you add a web server, again, that web server, you need to configure to point to all the application server. If there is a failure on one of the application server, that will be felt by all the web servers as well. If they happen to try to connect to that application server, they'll get a connection timeout or something of an error, perhaps, and that impacts the overall web server architecture there. Now, what we want to do in terms of decoupling, and sometimes in the white papers, they are called, you want to introduce air gapping, a bit of breathing space between these two tiers of your architecture. And we do that by, in this situation anyway, we do that by introducing this elastic load balancer. Now, with the elastic load balancer, the web servers only need to talk to the load balancer. They do not need to know anything about the application server, because the elastic load balancer is a common access point for your web servers to the app tier. All right, so they have a domain endpoint to the load balancer, and they don't have to worry about anything else. So every time you add in a web server, you just need to point them to this common, the domain endpoint of the load balancer. And meanwhile, the load balancer will receive the connection request, as we saw in a previous topic, and load balance across these application load balancers. When you add an application server here, all you need to do is to register this application server to the load balancer, and that's all you need to do. Now, if there is a failure on the application server here, it is not immediately, there's no immediate impact to the web server. They don't need to realize there's a failure, because they only work with this elastic load balancer. And the load balancer will do the health check. The load balancer will detect that failure, and they will stop sending requests to that failed application server, basically. Now, the only impact is that if the application server is processing a request when it crashed, then obviously there's going to be these web servers will receive an error message, and they need to retry again and get serviced by another application server. But at least there's a little bit more decoupling, a little bit more gap between that failure, the impact of that failure to the web tier instances. And of course, we kind of talked about yesterday that this can be auto-scaled. You can have an auto-scaling service to scale this accordingly, so that if there's any failure, then the auto-scaling service can replace that with a new app server to replace the one that failed. So with that, then your architecture become a little bit more resilient and decoupled, so that the impact, the blast radius of a failure is much more limited that way. So let's look at a concept of microservices. Traditionally, this is the legacy way we develop applications called monolithic applications because it is it's a big application footprint where one single application will do a lot of things, a lot of functionality, a lot of modules in that monolithic forum application. In this case, it's just user topics and message, but overall legacy applications tend to be huge with a lot of modules, with a lot of functionality. And it's not easy maintaining and updating this type of application because for one, every module here needs to be on the same programming platform, whether it's Java, C++, Ruby, etc. Whatever you're using, it all needs to be common because they're all tightly integrated together. And if, let's say, one team that manages the messaging service, for example, decides to say, look, we've done some research and, now we are on C#, but, we think that this can be better served by a Python type of platform, for example. That's not possible, right? Because everything needs to be on the same. It's the same tightly integrated whole. You can just kind of break away one piece and use a different language. Also, in terms of updating and innovating code, if you update any code logic, there's a lot of testing to be made, not just functional testing, but regressive testing. Regression testing is to make sure that the change you introduce doesn't cause errors or impact into the existing module. So very difficult to innovate, and you tendency is to try to keep all your changes because a lot of work and complexity, and the updates will come maybe once a year or twice a year. So that's the typical way we do it, and a lot of bugs and a lot of effort and time to make sure that all the changes, the new versions, are working well. Nowadays, we try to avoid this type of application development. We go for microservices where each component is relatively autonomous and independent of one another. And how we achieve that is to have a well-defined API, application programming interface, for each. So you wrap each service with API, well-documented API, and you make each component very focused. You don't want each component to do a lot of functionality, but the ideal anyway is to have one of these service components very focused just to do one thing well instead of trying to do 10 things. Do one thing well, well understood, having the well-defined API, so that as long as the APIs is well-defined, each service component here can communicate with one another over the APIs. And with that, they are they are independent of one another. One could be in Java, another could be in Ruby on Rails, another one could be on Python. Doesn't matter. As long as the API is there, and each team can independently innovate and update and upgrade their functionality as long as they keep to the APIs. Now, of course, if there's an API change, you need to account for that. You need to have a way in which to implement backward compatibility before you retire the APIs, etc. So yeah, there are things to manage as well. But by and large, it is much more flexible than a monolithic forum application. And although it's not shown here, we will also introduce you to the fact that in a microservices type of structure like that, you can also basically have decoupling measures like having a message bus in between the different components, as well as event bus. And we'll talk about some considerations, not in very detail, but we'll talk about some services that help us do that, so that we increase the decoupling from these microservices. So that if, let's say, there's a message queue somewhere between the topics and message, for example, here, then they are relatively independent of one another, right? So we'll talk about certain strategies like that, but the overall purpose is to keep them autonomous and independent. And so if, let's say, the message decides to change any logic, or even from, let's say, Python to Ruby on Rails, that should be transparent to the others as long as their API functionality or interface is consistent. One of the key things in terms of architecting for microservices is to have a common access point of your microservices architecture with a service like a load balancer, so that from the perspective of your end users, they only connect with the load balancer. That's quite important because, well, this is one strategy, right? From the end user perspective, they must have a way to understand what services you're offering and who can deliver that service. So if you have an application load balancer, that is actually solved in the sense that all the clients need to do is to connect to the load balancer. The load balancer is aware of which service components is delivering which service through the target groups of these application components, whether it's on EC2, etc. And once they are registered with these target groups are registered with the application load balancer, the load balancer is aware that when I see a request for user services, let's just say the path URL requested from the end client is example.com/users. I'm going to forward that request to the target group of these user components, as well as for topics, messages, etc. Right, so this makes it one example of how you can implement a microservices strategy by having the load balancer upfront as the connection point to your application. And so with this, you can have this service-oriented architectures, very focused on service components, API first design. So basically, the way your end users interact is through the API calls, and they do not need to understand what's behind the API that's in your microservices architecture implementation. And all of these can be updated, can be deployed using a CI/CD type of delivery, right? Continuous deployment, continuous integration. And the whole point of having a CI/CD is that instead of waiting for 1 year or a few months to introduce your version changes and code upgrades, is to have small incremental continuous change and updates, right? Maybe up to a few times a week or a few times a day instead of once every year or twice a year. Companies are moving towards that, to have code upgrades that small, incremental, easily reversible, but consistently, few times a week to few times a day, in fact. And so you could have all the separate CI/CD pipelines that can deliver this and support this type of software components. Now, one of the key things is to understand that you don't have to use EC2 all the time. A microservices architecture would mean that because the service components are very small, very well-defined, narrow scope, you could have some of them being implemented by Lambda. You don't have to use EC2s for that. Lambdas give you the advantage that you only pay per execution, and they can support quite a high number of invocations in parallel. When you have many requests for these user services, we just invoke the same Lambda function, and the Lambda service itself is able to take multiple high throughput of your functions being activated or being invoked. So your application load balancer, thankfully, is tightly integrated to Lambda, so you can just point it to a Lambda function, and as the requests come in, it just activates these Lambda functions. And Lambda functions are stateless, as I pointed out yesterday, and so we can have parallel, of the same Lambda functions running, right? And that's the beauty of how you can scale up using Lambda. Topics in this particular example are still in the EC2, not a problem. Maybe these are for legacy reasons, you might keep some of them in EC2. And some of them could be in clusters, in your container clusters as well. So basically, you don't have to keep to just one size fit all. You have multiple hybrid or broad spectrum strategy to have some in serverless, some in EC2, some in containers. And because these services, like the users, topics, messages, these services are independent of one another. And of course, that will overall increase resistance to failure. Resiliency increases the resiliency of your overall architecture. Once you have this type of microservices, it's very important to have tracing in your environment. So basically, what we mean by tracing is that now with the API call, this is fairly simple, but a single API call to, let's say, topics, for example, may trigger other API calls on the backend as well. So for example, let's say the user service, I trigger this Lambda. The Lambda itself may be working with the DynamoDB database. It may trigger some notification service. It may trigger another Lambda. And so one API call may have a chain of API calls to different service components on the back end. And it's important to have tracing to understand which component might be the performance bottleneck. Because as you have multiple chains of API calls, each call obviously to the backend components is going to introduce some delay. And sometimes you want to troubleshoot delays, latency, connection times out, etc. We need to have tracing information to understand where is the performance bottleneck, which component is causing us the most latency or the most errors or the failure point. And in AWS, that service is called X-Ray. And X-Ray is about having tracing information being sent to this service. So typically how you're going to do it is that you need to instrument your application. What we mean by instrument the application is that these applications running on the cluster, the EC2 or the Lambda, they must have a bit of code, a bit of logic to call the X-Ray service. You have to download and configure the X-Ray SDK for Java, for Python, whatever you're using, and to be able to allow the code itself, and I call this particular functionality, to call and report tracing information to the X-Ray. So it does impact your application development. Good news for Lambda, it is natively integrated with X-Ray. You don't have to do special coding in your Lambda code. The service will handle it for you. It will send X-ray information, tracing information to X-Ray. Now, the whole purpose then is then to send all this tracing information so that as you call the APIs and they kind of trigger the backend components, then you are getting what is known as a service map. For each API call, you have a service map. You can see, okay, this API call will impact this or will call or affect these three components. Maybe one Lambda function, DynamoDB, SNS service, notification service. And then you see the latency information, whether there might be any errors, etc., from this service map, basically. Okay, so this one example, you deploy your application into Lambda. Now, as I said, Lambda is natively integrated with X-Ray by default. So your Lambda service will send on behalf of your function tracing information to X-Ray, and then that will be used to create a service map that you can see visibility. X-Ray is also integrated with CloudWatch. In the CloudWatch console, look out for service lens. It's a combination of X-Ray tracing information and your CloudWatch metrics, alarms, error detection, etc. So that when you look at your service map, you've got a good view of what might be the service component that causing the most latency or delay, as well as errors. And so you can focus your troubleshooting, etc., for the development work on those components. All right, so that's microservices in a nutshell. Now we want to talk about containers, and this project manager is asking any questions, by the way, on microservices. Just a high-level introduction there, but any questions so far? Okay, we want to talk about containers now, and this project manager is asking what's the difference between a container and a virtual machine. All right, so let's look at containers in a nutshell. In the past, I mean, this is a real-life logistics case study. Up to, I think, 1950s or 1960s, we didn't have standard container sizes for shipping logistics. And so it was just up to the manufacturer and the transporter to arrange for the shipments, and the factory or the manufacturers, when they send their goods, there's no standard size. So it comes all in different shape and sizes. And so as you think about the logistics supply chain from the factory, maybe you have to truck it to the railway station, and then railway station to the port, and the port to the ship. Each leg of that have difficulties in optimizing how you kind of fit in all these odd shape size containers and it introduced a lot of delay and effort in trying to get the most optimal packing going on. So in the 1950s, I think, some of the pioneers think, why not just have standard container sizes, right? So, right from the factory, we fit all the goods into a standard container dimension. Just make sure that each good you want to send fits into this, containers, and it's up to the logistics, obviously, to optimize the space inside there. But from the outside is a standard size, so that I have these trucks that just pull this container, goes to the railway track. The railway track just load this container that fits into the railway track size, get shipped to the port, and as they load up the cargo ship, it's very easy to kind of maximize the packing when everything is standardized. So a container means that everything is self-contained, and we fit, as long as we fit our goods and delivery items under this container to the ship, to the train, to the trucks, it is all self-contained and standard approach. In terms of our application software development, we're trying to achieve something similar. What we're trying to achieve is, how do I pack in my application runtime environment and dependencies into a well-defined container, so that whether I'm running it in my workstation, my laptop, the staging area on cloud, and the production area on cloud is all consistent. It's all self-contained. All the application runtime and application dependencies are all self-contained. So basically, we want to pack into a standard container. You have obviously the application code, obviously that's needed, and you obviously define the runtime engine. So if you think about it, if I have a Python 3.8 code, my immediate dependency is I need a 3.8 Python runtime environment, right? The runtime engine, and other dependencies, because the runtime engine itself might need the Python might need to run on a Linux OS. That's another level of dependency. Perhaps this runtime engine needs to work on the Debian OS or iPine OS, the Linux OS. So I have to define that dependency as well. And then you can have other type of dependencies. You need to install certain packages, client libraries, and you have to define those dependencies. And the configuration, I need to open up port 80. I need to put the file into this particular file location, folder locations, etc. And so we want to pack all of these, build it up, package together as a container, and ship it as a container, whether you're moving from your developer workstation to a virtual server or EC2 on cloud, etc. Once we have defined this, we do not change anymore. We make it immutable. There's no further change. This is to guarantee that is portable, that is consistent results every time. Right? So the important thing here is that it's self-contained environment. Some of you may be developers from the 90s and the early 2000s. Or maybe perhaps you are still studying then. If you kind of recall Java when it came out in the 90s, I believe, I could be wrong on this, but it could be Java. Sun Microsystems came out with Java. And the tagline for Java is write once, run everywhere. Now, of course, whether it actually happened that way is another question, but the intent of Java at that time is you write once, it could run anywhere. As long as what you have, you give a Java runtime environment, the JRE, which is hosted by a Java virtual machine. If you have that, it doesn't matter whether you are in a Windows platform or Unix or Linux, in a fridge, in a car, as long as whatever appliance have this Java runtime environment running, your Java code will work the same. Of course, that's the intent of it. And we are trying to achieve something similar with containers. If we can wrap out and define all your dependencies and build out your dependencies, package them together, and then we shipped out as a consistent, self-contained runtime environment, then that would be ideal. Now, why do we want to actually do that in the first place? We have to understand why first. Well, when we do our application development, let's say you have a particular application that has maybe Node.js, one component in Node.js, maybe you have the Nginx type of a web server or load balancer and maybe MongoDB, let's just say. And typically you kind of install this, try to get them together in a Linux server and kind of run them together. I mean, you have to make sure that the client libraries, the binaries, etc., they are all compatible with one another. And so quite a fair bit of work to get these three major components, for example, working together. The challenge is then when you kind of upgrade, let's say the Node.js component, you upgraded that component to a new version. Now, this upgraded component may need different versions of the underlying client libraries, etc., tools, utilities, etc. And once you start to upgrade the underlying client libraries, etc., you find that, oh, now MongoDB doesn't work very well. There's an incompatibility now. And so you have a big of a challenge. You need to upgrade and try to figure out a MongoDB version that is compatible with the underlying, client libraries, binary kind of level. And so there's a lot of pain in trying to, make everything work together in terms of compatibility. And then even if you can get it right in your development workstation, when you move to your staging, your production environment, they could have different versions again of the underlying OS client libraries, etc., which you then need to do adjustment again. So it's a very painful process. It's not portable. Each step is, you have to do a lot of effort and time just trying to get the compatibility right. And it's a waste, it's a suboptimal use of your developer resources. But if now we can self-contain, the Node.js component has its own runtime environments and dependencies just for them, just for this Node.js component. And the MongoDB has one just for the MongoDB and the HA proxy or whatever Nginx you use, just right for that. Then as long, they are very portable now, as long as, from your laptop workstation to EC2 on AWS, as long as that container is self-defined, self-contained, and is immutable, it doesn't change, that's fine. You don't have to worry. You just package it once, and then they will kind of run and live together quite well, no matter whether it's your own laptop or EC2 on cloud. So that is, the reason why containers are becoming more popular. It saves so much of your developer time. And the only thing that you have to understand is what are your dependencies. You package them together, basically. I talked about the example of Python, but if you take a web application development or web application, then what is the dependency of the web application? Well, naturally, it's the web server. So if you have a web application, you must have a web server, Apache web server, for example, that kind of supports it. There's a dependency right there. And the web server itself, the Apache web server, also has a dependency. It needs, for example, Debian OS, right? The OS layer to support it. So in other words, the containers have a chain of dependencies. And the whole point of building your containers is that I define this dependency, my immediate dependency, like what you call it, the web application needs the Apache server, let's just say. The Apache server will come with its own dependency at a lower level. And that lower level will come with its own dependencies. So there's a chain of dependencies. But when we package and build your containers, all these dependencies will be accounted for when we build your containers and then packaged together as an image, immutable image, so that we can run this containerized application component consistently across different platforms. Okay. So let's look at containers and microservices now. In a monolithic order application, you could have three monolithic type of applications or modules working together, all very tightly integrated. And you have some repeats here, as you can see, in terms of the ordering. The order history is, kind of repeated here. And basically, scaling is also a challenge, because let's say if the ordering becomes very busy, and if it's all under one monolithic application, when you scale, you're scaling all components, even though maybe the ordering UI is busy. When you scale, everything scales together, right? So it's suboptimal as well. But when you break it up, we call it refactoring, right? You break up your components into these microservices, then every piece is a very self-contained, well-defined service. Inventory, order history, ordering UI, etc. And they can scale independently. So if the inventory component becomes busy, we can scale this independently of the rest. Okay, so if this becomes busy under this monolithic, everything needs to scale. For here, we are just very focused in the scaling. So very optimal use of resources. Now let's compare three scenarios here. We're calling different levels of abstraction and virtualization. We start with bare metal, let's say your physical server. We install the operating system. We get install the libraries and the three components here. Maybe as I said earlier, is a Node.js, HHProxy, and a MongoDB, let's just say. Now, as I said, it might be a pain just to make sure that they all are compatible with the underlying library, binary, utility, tools, versioning, etc. And every time you upgrade, let's say at B here, and some of the libraries need to be upgraded to a certain version, it might break A and C. And then you find that you have to go and upgrade A, hopefully find a right level of the version now that will be compatible with the new versions of the underlying libraries or dependencies. So very painful. So what do we want to do? We want to break this dependency. So one of the ways is, well, let's use the virtual machines then. If you use virtual machine, now you've got the operating system, you've got the hypervisor like VMware, let's just say. And then you have individual virtual machines. Each virtual machine will have its own guest OS, libraries, app A. Now, if you think about it, it does achieve our isolation. If you keep app A into one virtual machine, it is independent of B and C, and each one of them can have its own guest OS and client libraries. Okay, so this is possible. I mean, you kind of achieve some strict isolation, which is great actually. But then this is not so optimal because this is a full-blown guest OS. Each one has its own full-blown guest OS. It's basically a full-blown server. So even if this app just utilizes 5% of the server resources, you've got a whole server just for that. So it's possible, not so optimal. Whereas when you come to containers, this is a little bit more optimized now because yes, you need the underlying OS, but they share, each of these components, they share the same Linux kernel. Then you have the containerization engine, basically. And then you have either shared libraries if they are compatible with one another. So if let's say A and B and C has a common set of libraries at a certain version level, they can share it. A and B has a need of a common set of libraries at a certain version number, and so they can share it as well. And then C has its own unique library requirements, tools, or at a certain version. So we can also just have it for C. But now the difference is that in terms of the resources, it is sharing the operating system and common set of libraries at the right version level. Some are shared, some are unique. So when we deploy, let's say container A, let's say in this particular host, this is the first time we're going to deploy container A with the dependencies, all the chain of dependencies. This we make sure that it's installed. This we make sure that it's installed for app A because these are the dependencies. When app B comes along, we want to deploy that container. Good news, the underlying dependencies are already there. They don't have to be reloaded. They can go ahead to support app B as well. App C comes along, this dependency is there, this is not there. They will pull out another container image with all the dependent underlying libraries here and deploy it so to support C because it's part of the chain of dependency. So this will be installed, C can now live happily. Okay, so with that, this is beneath the hood how the container engine will make sure that all the dependencies are present for these containers. Another important concept to understand is that all these underlying dependencies, they are only read-only. App A cannot make any changes to the underlying library versions, etc. They can, if they make any files, etc., it's not written back to these libraries. These libraries or these, they do not change. They are immutable to preserve the consistency. Any changes are lost. Once container app A is stopped, all changes are lost. That means all the changes are only in memory, and when the container shuts down, it does not persist, right? If you need it to persist, then you need some form of external storage for that, right? So with all this approach, what it means then is that the performance and the application and application runtime environment for your individual apps, they are very consistent, which is what we want to achieve. So in comparing virtual machines and containers, a virtual machine is a full-blown server, which is own guest OS, right? So they are isolated, but they don't share the OS and binaries. So possible, yes, but a larger footprint. So as you know, when we start our EC2, we need 5 to 10 minutes. Containers, they share the underlying Linux kernel, but each one could have its own outer shell like Debian, Ubuntu, SUSE Linux, Red Hat Linux, which their own tools and utilities, but they essentially share the same Linux kernel. And so your application components, the containers here, they are small footprint, right? They can, they can start in a matter of seconds, right? Because they are all small footprints here. And where appropriate, if they have the same dependency on the libraries, they can also share, as in the previous slide, they can also share as well. And it doesn't matter if they share because it's only read-only. They can share out the files, they can read off the files, use it for their own purpose, but they can't make any changes, right? So that means they can live well together without causing incompatibility and inconsistency. The Docker engine is actually based on the Linux kernel, and those of you who are aware of Linux, the Linux kernel is actually quite well positioned for this type of containers because natively Linux has good resource isolation for different processes that are running. In Linux, a process is a running instance of a program, and Linux natively has quite good resource allocation and isolation. You have concepts like namespace that you can that Linux kernel would just have a namespace for the process that is a logical allocation of resources, CPU memory to this process. And you have things like C group that can group together processes, and you can set resource limits, CPU memory on this C group of processes, etc. So natively, Linux actually have quite good resource isolation, which is what we need for containers. But these are fairly low-level Linux programming. Not many developers, can work at that low level. And the one of the key value propositions of Docker is that they abstract out and simplify. They have your Docker commands that actually work with the lower-level Linux type of details to provide you with resource isolation and allocation. And this is much easier to work with the Docker domain, your Docker build, the Docker pool, etc. So, Docker. The main key value proposition of Docker is that they provide this higher level Docker commands for our developers to use. So basically, you can then deploy your containers on EC2. This is your DIY. You do it yourself. You launch your EC2s and you install Docker, and you can run the Docker environment, your Docker build, the Docker run, basically Docker pool commands, etc. So you can do that yourself, and that's great for test and development. But then when you talk about hundreds or thousands of containers, that's where it gets very complicated, because obviously you're not just dealing with 2 or 3 EC2s, you're dealing with a whole fleet of EC2 servers. And managing that environment is not easy. It takes a lot of time and effort, which brings us to containers orchestration services. These are services that help manage our container runtime environment. And so this is a end user feedback from the development manager here. Our developers want to start using Kubernetes, which AWS service will support the effort. Now, Kubernetes is an open source container orchestration environment. And it was first developed by Google, but they released it to the open source community. And it is the leading container orchestration service. So a lot of organizations, developers are using Kubernetes as an example of a service that helps us manage this container runtime environment. But let's look at some basic components first. Let's take a look at our monolithic forum application. We have refactored it into individual service components here. And basically, we run a Docker build command to basically build up an image. So some of you who have done this will know that, first of all, we have a Docker file that provides us with the stating our dependencies, the configuration, etc. That will pull together the code, the dependencies, the runtime, etc. To define that in a Docker file. And then when you do a Docker build, the Docker engine will pull together. You got the code, you got the underlying runtime, I say Python code, you got the Python 3.8 runtime, you got the underlying OS. You pull all the dependencies, that download and install all the packages, etc. So to build your environment for you, and then to capture it as an image, a Docker image. Think of it like our Amazon machine image for our EC2, but this is a Docker image for your application component, so that everything is baked into this image that has been built. And then you store this image into a image repository. Now you can have, those of you who already are working with Docker, you have the Docker repositories that you can use as well to store your images. The native repository, Docker or container repository in AWS is called ECR, Elastic Container Registry. Think of it as a repository. So once you build your images, you can send it over to the ECR as a repository of your images. Now, I use Docker as an example, but obviously there are different types of container engines, but Docker is quite well known. So I'm just, we're just using Docker as an example. So basically, you have your Docker builds and you're storing up your images on this repository. Now, the whole idea of having that repository is that this is the central location of your container images. And then the container runtime environment, if you're doing yourself, then you have a Docker pool. You pool the Docker images that you need, and they are deployed and run in the Docker runtime environment. But as I said, if you have thousands of containers, then managing this environment is going to be very painful. That is why we need container orchestration services. Now, there's EKS for Kubernetes, but we just want to focus now and bring up to you this native container orchestration service called Elastic Container Service, ECS. So ECS will help you then maintain your EC2s that host your containers. And basically, you have two choices here. You could host these containers on EC2s in your VPC. That means these are your EC2s that you have defined. You choose the EC2 type and sizing. You define the auto-scaling group. This will become your compute layer that will host. They become nodes that will host your containers. And basically, if you choose this, you have more control over sizing your EC2s appropriately, over creating the auto-scaling groups, etc. And then the ECS service will pull whatever you define. You define the containers you need to run. The ECS will pull your images from the ECR and launch it on your EC2 fleet. They will place it appropriately according to the resource demands, etc. And they'll place it on the containers. So that's one key way. The other key way is you want a serverless approach. You don't want to manage the EC2s. You want AWS to manage for you. So you go for Fargate. That's a serverless approach. The EC2s or the virtual machines are managed by Fargate. And you don't have to manage servers. You just focus on developing your containers, which you have placed in the ECR. And the container orchestration will pull the images and launch it on the Fargate servers, on the Fargate virtual machines. Okay. The main value proposition of the ECS here is that they will monitor the health of the containers. They will do placement strategies for you. They will, whenever you request a container to be run, they will locate the EC2 that has available resources to place it in, so that you don't have to manage all of these details yourself. All right, so that's the key value proposition. Any questions so far? All right, so basically, here's the full picture now. You have moved from monolithic to this container-based microservices. You have used load balancer. And load balancer, good news again, the application load balancer, it actually integrates into the ECS quite nicely for us. Now, I won't go to too much details, but the way you work with this ECS, for example, this container orchestration service, is that you now don't work directly with the containers and containers images per se, but you work with the ECS now. And one of the components of ECS is your task definition. A task definition allows you to define which containers do you want to run for a particular task. Let's just say you have an e-commerce application, and one of the tasks is maybe the product catalog. Another task would be the search functionality. Another task would be your recommendation engine to recommend products and services, etc. And so for each of these tasks, you can define one or more container to provide this functionality. So maybe your web front service consists of 2 containers. So in your task definition, you say, please run container A at this version, container B at this version. And in the task definition, you, would define the resources needed, CPU memory allocated for this container, for example. Another, the search functionality of your website, the product catalog of your website has other containers, all right? So for this, let's say search functionality, use this container at this version, and these are the resources. For the recommendation engine, use these other container images at this version level, etc. So you are basically running tasks. And the ECS task is the job of the ECS to go and pull the images and run it. And the task, you can run the task for short-lived functionality. Functions that you run, it does a hello world functionality and it shuts down. However, most in like our case of the e-commerce application, we want the task to be running all the time, long-running type of containers. For that, we have another component called service description. So we use a service description to tell the ECS to say, for this web front service, I want 2 tasks running at any one time. So that if one fails, they will immediately launch another one to replace it. I want 4 tasks of my checkout processing functionality of my e-commerce site to be running at any one time. So they will make sure that 4 tasks are running. Again, if one goes down, they will immediately launch a new one. A little bit like auto scaling. And indeed, you can have service auto scaling. So for example, your checkout process functionality of your e-commerce site, your service descriptions can say, keep a minimum of 2 tasks of my checkout process running to a maximum of 10. So this is called service auto scaling now. So that as if it's minimum low traffic, they'll keep 2 tasks running. But as your more users are coming to your e-commerce site, it's coming busy, they will slowly scale up until a maximum of 10 for you, right? So with this service type of description, you can have long-running tasks. And indeed, if I go back to the previous slide here, then the application load balancer is going to integrate with your service definition or service description for users. In that service description for users, you have defined, I want 2 copies of my user task running at any one time, for example, all right? For the messenger task service, in that service description, you have said that I want a minimum of 2 to a maximum of 4 tasks running. So they auto scale accordingly to your definition, to the capacity that you define for the task. And then the load balancer, depending on the service being requested for users, topic, or messages, they will forward those requests to the service, which then is load balanced between the 2 tasks running. And for messages, there are 4 tasks running, so it's load balanced across these 4 tasks. Right? So that's how it works overall. Now, so in this, you send your request, and the job of the ECS is to pull your container images from the ECR and then launch it, place it into the EC2 instances running in your cluster. Now, a cluster is a group of containers, tasks, EC2s, the compute environment that make up your container runtime environment. Right? So a task is a cluster is a logical grouping of the containers, the tasks, the underlying EC2 server compute that supports your application. All right, any questions that you want to bring up? Now, Kubernetes, as I say, is the open source and it is a container runtime environment or orchestration environment. So the purpose of this Kubernetes is the same thing as the ECS, but Kubernetes is open source and is widely adopted. So Amazon is supporting Kubernetes as well, in that you can host your Kubernetes environment, what you call it, on AWS, on Amazon as well. So this is EKS basically, and again, you have a choice. Do you want to run it on the EC2s in your VPC or a serverless option, Fargate, to run everything in the Fargate VPC environment? So you don't touch the EC2, you don't have access to the VPC and the EC2, you're quite happy for Fargate to do it for you. So similarly, you have a choice here, right? Now, in terms of the high-level Kubernetes architecture, basically, you have something similar. A pod is like a task definition. A pod, you can define one or more containers to run per pod. And then the Kubernetes will place these pods into the underlying EC2s or worker nodes, right? So you have a container runtime engine as part of your worker node. You have a kubelet, which is an agent service that receives command and management, command and control instructions from your control plane. You have the kube proxy that does the networking communications for your worker nodes, etc. And then overall, at the high level, in terms of architecture, you have a control plane. This is the command and control, and the data plane. The data plane consists of the worker nodes that will host your pods, which contains your containers, basically. In terms of the control plane, you have things like API server. This is the main communications hub because it's all the commands and interactions, all API. Everything goes through your API server. You have the scheduler that makes placement decisions. So if you want to launch a pod, they have to find a worker node that has enough resources, etc., to be able to host the pods containing your containers. You have the control manager. It's a series of services that help maintain your environment, the health of your worker nodes, the tasks that are running, whether some have failed or not. You have the etcd, basically is a key value database that contains configuration information, etc., that makes up your control plane. So in a nutshell, this is overall the architecture. We obviously won't go into deep dive here. But we do want to call out and highlight the Fargate, the serverless option here. And again, this Fargate serverless option is available for both ECS or EKS. But once you choose the Fargate, then Fargate service will handle everything in terms of the server info. So you don't have to touch, you don't have to worry, you don't have to patch, you don't have to do auto scaling group, all handled by the Fargate service. And the it's quite interesting. The Fargate is actually quite optimized for containers because they not just use the EC2, they actually have their own type of virtual machines. They call it a micro VM that is highly optimized for containers. It's very small, micro. It doesn't take a lot of resources. So what actually Fargate does is that for each container, they host in a single micro virtual machine for strict isolation. So in that sense, if you run, let's say, 3 containers, each of these containers will be on its own micro VM. And because the micro VM is small form factor, that means very, ideal, optimized memory CPU. It is resource optimized that way, and it provides you with very good security isolation from one container to the next. So Fargate actually gives us quite a fair bit of good security isolation if you think about it. But one of the key benefits is that you don't have to worry about the managing those EC2 servers. So basically, if you choose your orchestration through the main decision point is whether you want to use the native ECS or EKS. The advantage of Kubernetes is that is most organizations have Kubernetes on-prem, so it kind of makes sense for them to continue using Kubernetes, and it's widely known. ECS is a native AWS, so of course you have the nice integration with a whole suite of AWS supporting services. But whatever you choose, then the launch type, you choose whether you want to have your own EC2s or the Fargate serverless option. Now again, we have seen this yesterday in terms of which level you want to work at, individual EC2, server-based traditional way, more control, configuration, and visibility, but more responsibility. And you start to go up, containerization. You still have to, if you choose the EC2 launch type option, you still have servers to manage. But in terms of orchestrating your containers, that's managed by AWS. You go to Fargate, is a lot more is off your shoulders now because Fargate will handle the container compute layer. And then finally, you go for Lambda, which you don't have to manage and configure anything but your application code. So that's in the nutshell, the value proposition here. So as a solution architect, again, when you want to deploy your applications, you help your team decide where you want to work. Your traditional legacy application type, containerized environment, or total serverless, right? And understand the trade-offs between them. It's always a trade-off between the level of control and visibility you have and the ability to focus very narrowly on your application. If you focus narrowly on the application code, you don't have to worry about the underlying infrastructure, but neither do you have control or visibility. So you trust your cloud service platform. Okay. Lower down you go, you have more control and visibility, but more responsibility on your side to manage that underlying environment well. All right, let's look at the knowledge check. Which of the following are characteristics of microservices? Select two. Oh, sorry, Tara, you had a question. How's the difference between ECS and EKS? So I very briefly described to you. Hopefully I answered your question. ECS is native to AWS. Kubernetes, EKS is based on Kubernetes. That's open source container orchestration. A lot of organizations are using Kubernetes, so it makes sense. If you're already using Kubernetes, EKS is a natural choice. The tools are the same, commands are the same. ECS is native to AWS, different commands, same purpose, container orchestration, but different commands. So, some AWS customers, they have been AWS customers a long time. They don't mind just starting, with the ECS. It's native, AWS, and they get their engineers trained on that. But for organizations coming on board with Kubernetes already, it makes sense to kind of keep to EKS because it's something that your developers will know, and the commands, the tools are all the same. So hopefully that helps answer your question. But please let me know if you need more clarifications on that. Yeah, Tara. Okay, meanwhile, there's some answers coming in here. A and C, B and C, A and D. Okay. Yeah, you're welcome, Tara. Thank you. A and C. Okay. Okay, good. Let's take it one at a time. Microservice. Just think back what we talked about microservice. Independent, right? Autonomous, independent. So C is definitely correct. A, loosely coupled, that is actually correct, right? Because tightly coupled means what? Tightly integrated and independent means A tightly dependent on B. If B fails, A also will fail. We want to avoid that. We want it to have a little bit more breathing space through, let's just say, through application load balancer, right? So that they are not, directly dependent on one another. And we'll learn later on about messaging queues. That's another way to loosely couple your environment because A put a message to message queue, B read from the message queue. If B fails, A does not realize because I'm just working with the message queue. So for microservices, we want to achieve this loosely coupled. So A is one of the key factors as well. And so the other answer, which is quite obvious, is we want it to be autonomous and independent. So A could be in Python, B component could be on Ruby or Rails, another component C could be on Java, right? So they are autonomous and independent. Just make sure that we have the APIs well defined. Okay. Right. Any questions? So A and C. Okay. Which of the following are characteristics of containers? Select two. Okay, fantastic. Very good. A and D are correct. Very good. Containers in ECS are logically organized in all right, very good. Very, very good. It is a cluster indeed. All right, well done. Which of the following are components of Kubernetes architecture? Okay, excellent. Well, very well done. Data plane and the control plane. Excellent. Data plane is where you have the worker nodes, your pods are there. In the control plane, you have the API server, the scheduler, etc. Very nice. Very good. Why would you select to deploy your containers to AWS Fargate over EC2? Some of the reasons, one key reason why you want to do that. All right. Okay. Yes. Yes. Yeah. Well, the key reason is obviously to you want to avoid manual infrastructure updates. You don't want to worry about OS patching, etc. Now, the one thing, Emilio, once you do a serverless, right? Then you have less control already. You have no control actually over the Fargate. You don't know, you don't see any of the EC2. So in that sense, it's a trade-off, right? If you want serverless, you have less control and visibility over the underlying infrastructure. You focus on your application rather than the infrastructure. You trust the cloud service provider to manage that infrastructure for you. You have no control and visibility over that. It's not like you can SSH into the underlying server if you can't. But if you have your own EC2, then obviously you can go and SSH in there. You can configure the OS patching, etc. So you do have control, but a lot more for you to do and to be responsible for. Rather, if you go for serverless, then it's hands-off approach. All right. Okay. Time for our mid-morning break here. So I'll give you 15 minutes on the clock, and enjoy your break, and I'll see you after that. All right. Enjoy. Thank you. All right, welcome back to the class session. As we move off to the next module, as I said, I'm gonna cover our serverless module so that we can ensure that I can allocate the lab time just together continuously with the lunch hour break so that you have a little bit more time to manage yourself. And so please allow me to just move off now. Let me just close this out and get us into the next module, which is the serverless module. Okay. All right, as I've gotten also some feedback on the lab extension. So again, those of you who have joined in a little bit later, if you do need more lab time, extension of lab time, please do feedback to me on your comfortable date and I'll take it into consideration as well, all right, to make that request for the labs to be extended. Please do let me know. All right, as usual, just a quick check as well that my audio is clear and that you can hear me well. If you can, and if you're back, please give me a virtual thumbs up or a chat message so that I know that we're good to go. All right, thank you. All right, thanks for that. How about the rest? Okay. All right. All right, very nice. Okay, Kesham, in terms of the ebooks, they will keep it on the online, your online account for about 2 years or so. But do recommend that you download the offline desktop app version and synchronize your books. And once you synchronize it to the online, to your desktop app, then that's yours permanently, right? That will be yours permanently. Yeah. But so to ensure that, please do download and install the desktop app. Yeah. All right. Let me just bring up the next module here. All right, let's talk about serverless. Again, this is a nice continuation of our previous topic about containers and microservices, because serverless is a important part of your microservices approach and consideration and strategy as well. So let's talk about these check-in questions. What are you responsible for if you run your code on Lambda? What are you responsible for when you're writing your code for Lambda? Right, excellent. Yep, so you're just focusing on your code, basically. All right, so that is the main concept about serverless. Let's look at this application developer manager. We have a growing list of new applications designed, but we need to optimize our spend. Basically, we need to keep costs under control, and we don't want to have to deal with servers at all, right? Because once you run servers, as long as they are running, if you're running 24/7, the meter is running, basically. Right? For these workloads, we'd rather pay for usage rather than resources. So what are possible from AWS perspective? And just as important is how can we duplicate our existing components such as message queues and data ingestion, right? So we'll look at some of the message services, SQS, simple queue service from AWS, as well as the Kinesis streaming services, right? Again, the number of end user perspectives here that we'll take it one by one. And this is our serverless architecture. This is one example of what is known as an event-driven architecture, EDA. And as you can see, EventBridge is the communications hub of this serverless architecture. EventBridge, which I mentioned previously yesterday, is it's an event bus service. Basically, you create an event bus, and services can write or create events on the event bus. You can create event rules to say that if this event happens, I want to trigger this Lambda. I want to send this notification to the notification service. So this is one key consideration in your microservices architecture, to have Event Bridge as the key messaging component. And you realize that once you use services or constructs like Event Bridge, you have decoupling as well, because these service components, they are not communicating directly with one another. They're communicating through this Event Bridge, right? That gives you that decoupling that we talked about in the previous module. Now, let's look at this e-commerce platform. And again, this is a nice example because it shows you that if you want to architect and implement, let's say, a simple, can we record video? Oh, apply? You mean this class? You can't record the video, not authorized to do that. So, we're not allowed to record the video. If you mean recording our session here together, right? Or you can have a ask. But nonetheless, I'm going to talk about the online course supplementary at the end of the day. That is a nice revision and recourse. Whatever we cover here, you have lots more in-depth details on the online course supplement. So that will be a good resource for you. Right? We'll talk about that later. All right, nonetheless, back to this architecture. It shows you that even for a fairly sophisticated e-commerce platform, sorry, you don't have to use EC2. You can actually have a serverless approach or microservice approach by breaking up the functionality and having each functionality implemented by a Lambda function. And again, as I mentioned, the Event Bridge is the one that is the key communications hub, if you will. And so if the customers, orders from customers are coming in and they place the orders on a customer order queue, that queue can trigger a Lambda function that detects that, okay, the message queue actually has a new message, a new order. I go and create an event, place it in the event bridge, all right? And basically the event bridge will then have a rule to say that, okay, an order has been submitted, right? So I kind of trigger this checkout functionality. And then let's just say that once this function is done, I create another event, place it back to the event bridge, which in turn triggers that as an order complete event, which I can then go ahead to trigger this other Lambda function to process the order. And up to a certain stage, I can return back another event to say, now we are ready for e-payment verification, which then triggers a rule that says, okay, let's go and authorize the payment, for example, to check whether it's credit card or whatever, validity or whatever, and then go ahead to authorize the payment. And then you go for shipping, right? Once the payment has been confirmed, authorized, you create another event, which then triggers another rule to say, okay, let's go for shipping, for example, right? So with this, then you can have a fair bit of functionality from customer login to customer profiles, etc. And all this can generate events, which in turn triggers other microservices components. And you can see the use of queues here in terms of the order shipping, etc. as well. So just a good reference to keep in mind because it kind of shows you that you can have a microservices architecture and that means you don't have to have EC2s. And secondly, you can use a combination of Event Bridge and the message queue as a means of communications between your microservice components. So essentially, what do we mean by serverless? Well, as we already said a few times already, you don't want to manage the underlying compute infrastructure. You want to scale automatically. As your usage increase, the serverless service is invoked or is used, and you pay per consumption. So you pay for value in a sense that you pay whenever the service is utilized, not for running a server. If you run a server, it's like a 24/7 thing, as long as the server is running. It's just like this. Let's say um, I go to, I have a tap at home for water, and so I on the water, I on the tap. Running an EC2 is like owning the tap, so the water is flowing. Whether I take the mug there or not, the water is flowing. So when I'm thirsty, I take the mug there, I fill up the water, maybe 5 times a day, I fill up this mug. I move away, but the water is still running. What does it mean? It means that the water company is still metering me. The water is running, and I only use 5 to 6 times a day. I fill it up, I go away, but the water is running. That is equivalent to running a function on a EC2 that is only invoked 5 or 6 times a day. It could be more, but in between the function invocation, your server is still running. If you run a Lambda, let's just say, that same function, you use a Lambda. That's equivalent to the tap is closed most of the time. But whenever I need water, I take my mug, I switch on the tap, I fill it up, I switch off the tap, and I move away. I'm only metered for the time when the tap is on. That is like the Lambda function execution. They would charge you per function execution. If your function is not invoked, you are not charged. So that's what we mean by pay for value. What other comparisons is like you pay for per transaction instead of owning the resource. When you have an EC2 running, it's like you own that server, basically. It's yours. You have to own it and you have to maintain it. It's like a cost of ownership is there. Whereas if you use a Lambda, it's like per transaction. So think of it this way. Early on, I said that when we were talking about EC2, EBS and all that, earlier I said don't use a Ferrari to go to the supermarket to buy fruits and vegetables. It's a misallocation, of course. I said that maybe use the Kia small car from Kia to do that. Okay, that's great, but then the Kia is still yours. The Kia motor car is still yours. You have to maintain it. There's a total cost of ownership. You have to put engine oil. You have to make sure that the tire is good. You have to wash it, clean it, maintain it. Another option is instead of owning the car, if you don't use the car that often or occasionally only, use Uber or Grab, the car hailing service. For that, you pay for the transaction for the Grab car or the Uber car to bring you to the supermarket. You pay for that transaction only, but you don't have to worry about maintaining the car, putting engine oil, making sure that the tire pressure is good. Of course, you assume that the owner must be responsible to kind of maintain the car well. I mean, obviously, that's one of the key assumptions here, that people trust the Uber service or the Grab service, right? But once that trust is established and there are standards that they maintain, then basically you don't pay for ownership of the car, you pay for the transactional value of on-demand service to bring you to the supermarket and then back again. And if you kind of don't need to travel or don't need to car ride, because again in today's environment we work mostly from home, for example. So the need for owning the car is less now, and we're paying for the transactional value of that. Okay, so that is somewhere equivalent and something to consider. And basically, when you use this services like Lambda, API Gateway, Queue service, the service itself is secure. I mean, AWS is having audits, third-party auditors that will check that all their security guarantees and what they promise to you or guarantee to you, if they tell you is HIPAA compliant, my service here is HIPAA compliant, PCI DSS compliant, they are actually independently audited to make sure they are. But what it does mean is that you don't have to worry about setting up a VPC, statutory good rules, etc., right? Because that is on the part of the service provider. So again, you understand this value proposition of serverless to help your teams understand if we choose serverless, these are our main drivers, and you want to make sure that these are advantages that you value. As I said, in another scenario where because of your competitive advantage that you need EC2 servers, then these are not so compelling anymore, because your compelling value is that you need to have low-level control over the EC2 instance type, over the amounts of virtual CPUs and memory that you have, graphic processing, etc. You want that, you need that. So this may not be so compelling under different scenarios, right? So as a solution architect, understand this trade-offs so that you can advise your team, your management, or your clients. In terms of the serverless portfolio on the whole, we have already seen compute, but you have API proxies that instead of having your API servers like in on-prem, use a serverless managed service like API Gateway. AWS AppSync is for GraphQL, where instead of an API, a generic API call, you actually call the underlying database through this proxy of AppSync. We have seen storage S3 serverless. Don't have to worry about OS, storage file systems, none of that, right? You just use and consume the storage from S3. The database we have seen DynamoDB Aurora. Interprocessors messaging we're going to cover. SQS queues and notification service here. Orchestration, we're going to look at it later. Step functions, a workflow type of logic. Analytics, we're going to take a look at Kinesis very briefly, but you have another one called Athena. Athena is a very useful service. It is SQL query as a service. It allows you to run SQL type of queries to data or files that is stored on your S3 bucket. So, for example, if you have your point of sales transactions that you uploaded to your S3 bucket in a CSV file, then you can actually use Athena to run SQL queries on your sales as CSV files on your S3, for example. And it's completely serverless as well. And then, of course, your developer tools, etc., they're all serverless. Serverless architectures. This is something that you will quite a nice example actually, where perhaps you are running retail outlets and each of the retail outlets, they are uploading inventory files to the S3 bucket, right? So as a means of the daily reporting or whatever, 2 times a day. And again, the S3 bucket has event notification to trigger a Lambda function to extract out the CSV files in terms of the inventory levels of your products. They update the DynamoDB table with these inventory levels. And then there's a dashboard app that reads off the inventory levels of the DynamoDB table and basically displays the inventory levels for the managers, the inventory managers. You use Cognito to help you with the authentication of the users coming into the desktop app. Cognito itself is a serverless service that helps your mobile apps and web applications to implement authentication and authorization type of logic. Meanwhile, the database here, DynamoDB, has this feature called DynamoDB Streams, which captures new or modified app items from the database, and that DynamoDB Streams will in turn trigger, if there's any change, it will trigger the second Lambda function here to extract out the inventory levels. And let's just say some inventory levels have gone below a certain level, a certain threshold. It will trigger a notification service, let's say SMS or email, to trigger your inventory team to procure more inventory, the more stock and supply to send to your retail outlets. So the key takeaway is you can see it's 100% serverless. There's no single EC2 server in mind here. You can run this fairly nice function here without worrying about a single EC2 server. There's no patching, there's no updates, you don't have to SSH anything. It's all, the main value of this function is very clear without you spending a lot of time and effort in managing any server. And also, you notice that there are 2 Lambda functions here in state. And some may be asking, why have 2 separate ones? Why not keep into a big Lambda function that can fulfill both of these type of stages? You can, but again, in a microservices strategy, we want each service functionality to be self-contained and independent, right? So we break it up into 2 separate components. And in that sense, the DynamoDB table is the decoupling type of service between them, for example. Okay. All right, these are the areas that we want to cover. Of course, quite a fair bit of things, but again, we're not going to deep dive, but we want to highlight these type of services to you so that you have a nice idea over the possibilities that you might want to consider for your own environment. So we start with the API gateway, and the development manager is saying, how do we lock API version for production code? So dealing with APIs can be tricky in the sense that you have a version of the application that is already in production that your end users are using, but you have also in development newer updated APIs, and you want to make sure that the one that is in production is locked in, there's no confusion, so that you don't have unexpected errors. Let's say one is still not ready, is in development, and you kind of expose that, and there's confusion over which one is the production version, and some of your clients may run into problems using the API that is not ready. So the service that helps us with this managing our APIs is called the API gateway. So think of your API gateway as the entry point to your application, to your microservices architecture, for example, where you have tight integration with Lambda. So again, let me back out and say that you create your APIs, you approach your solution architecture by creating APIs for each service that is required. And on your mobile apps and your web apps, third-party integration, these will be calling specific APIs. And the whole point about the API gateway is to allow you to define those APIs and define what those APIs will do once it is triggered. So there are a lot of possibilities here. There is tight integration with Lambda. So your API calls can actually activate a Lambda or invoke a Lambda function that will run some customized logic for you. And that Lambda function is, again, free to work with any of the AWS services or external third-party services. So you're quite free to kind of implement the logic here. It could be calling a EC2, some web applications running on EC2, or some of the services directly. For example, today your API calls is possible to kind of work directly with the DynamoDB table to put in an item on the DynamoDB table, or to get an item from the DynamoDB table directly. You can also put in, for example, through an API call, you can directly put in a message to a SQS queue, for example. So a nice integration with some of these AWS services, and you can actually work with endpoints in your VPC as well. Now, it's possible to have this API gateway call, let's say, a network load balancer in your VPC, and from that network load balancer, it goes to an on-prem kind of service or server through a direct connect that we'll talk about direct connect later, through a network, a dedicated network between your VPC and your on-prem, for example. Also, it's quite flexible in the sense that I could have endpoints for VPCs, endpoint VPC for my API gateway to allow applications running on my EC2s the ability to call a private API. That means this you have a public APIs and private APIs. Public APIs that are exposed to your end users, but you may have some private APIs as well that you want to only be accessible from EC2s running in your VPC. That's possible through the endpoint. So we'll talk about endpoints later as well. But basically, when your application's running on EC2, they call the endpoint. They will be directed to the private API, which then triggers other logic. That's possible as well. With Direct Connect, which we'll talk about later as well, your on-prem servers can go through, the API call from your on-prem servers can go through Direct Connect through this endpoint and to the private API, and then access other functionality. That's also possible. So very flexible, quite a fair bit of possibilities here with the API gateway. Also, just want to note that the API gateway has the ability to customize your security authorization for your API backends. You can integrate custom logic through a Lambda function to do authorization, security functionality. But the good news as well is that the API gateway integrates with Cognito. I mentioned that service earlier. The Cognito service helps you to implement authorization and authentication functionality for your mobile apps and your web apps. So if you have your mobile app, for example, and you want users to authenticate themselves before using the app, they can call the Authenticate API, for example, and through the API gateway, and it brings them to the Cognito service to perform their authorization and authentication. Okay. So again, it can be public APIs or internal APIs. So key value proposition, a single API front. It improves the security. Why? Because API gateway is also protected by AWS Shield, which is a DDoS mitigation service, as well as WAF, Web Application Firewall, which we'll touch on later as well. So basically, these security services from AWS protect your API entry points, basically. And then, as I said, you can authenticate authorized requests to a backend. And it has other features like throttling. That means you want to protect your backends. You can, define the maximum rate that the API request is going to the backends. And so if they reach the throttle limit, you can start to aggressively decline API calls. You can also monetize your APIs in the sense that, let's say you have a machine learning, image recognition, service on your backend here. You can expose your APIs and sell your APIs for other developers to call those APIs because they don't want to reinvent the wheel. They see that, you have done quite a very good job in creating this voice recognition service or image recognition service through machine learning. And they treat it as a black box. They say that the performance is fantastic. They treat it as a black box. They just access your service through the API. And so you can then actually offer your partner developers or whatever to subscribe to your APIs through the AWS marketplace. And then you charge them, right? Per 10,000 APIs, they charge them a certain rate or whatever. So you can actually monetize your, if you want to offer your development commercially to others, you can do that through the API gateway as well. Let's look at this sample architecture here. I do want to mention that one way the API gateway kind of optimizes the API calls from your clients is to use CloudFront. So there's native integration actually, where your API gateway is a regional service. So you may have an API gateway in Singapore. But what if your end users are in London? They want to call your APIs. Well, to optimize the route of the API calls, they actually use CloudFront. So the client is calling from London. The API call is directed to the nearest edge location in London. And from the edge location in London to an API gateway is all CloudFront network. That means private global AWS network. You don't have to go over in the public internet way. Also, the API gateway does generate API metrics, basically that you can use to monitor from CloudWatch. So you get metrics like how many API calls for this particular API, for example. In this particular example as well, when your end users are trying to access, let's say, product catalog or inventory levels or in-stock levels of a particular product, for example, it goes through the API gateway, which in turn triggers a Lambda function, and the Lambda function will extract out, let's just say, the item from the database, DynamoDB. Now, one of the features of API gateway is to cache that response as well in an API gateway response cache, so that if another client or subsequent clients that is asking for the same thing now is fetched from the cache, you don't have to go all the way back to trigger the Lambda function and the DynamoDB anymore. It will respond directly from the cache for a faster turnaround. Okay, some of the nice features here. Okay, that's as much as API is concerned. Let's take a look at SQS, the queue service, quite important here. The development engineer is saying, how can I get a reliable message queue that I don't need to maintain or worry about? So some of you have managed queue systems on-prem, like RabbitMQ or Apache MQ queues, and you have your queue servers, etc. But now that you want to move to the cloud and you want to have a highly scalable queue system, then what is available for you, basically? And we're going to talk about this service called Simple Queue Service, or SQS. It is serverless and fully managed. That means there is zero server administration and configuration for you. You don't have to worry about your queue servers. It's all 100% managed by the SQS service. And it is a persistent store of messages until they are processed or deleted or expired. You can put in a maximum expiry period. After that, they'll be purged away. But the fact is that your message are persistent on queue until you expire it or until it's successfully processed. And because of that, it can effectively act as a buffer between your sender and receivers. This is about, again, decoupling, right? This whole thing is about decoupling as well. Let's look at this particular architecture. Let's just assume that this is our hotelbooking.com, right? We offer hotel rooms and various hotel rooms, partner hotels, etc. And we want our customers, our subscribers to come in, look at the location, the city, look at the hotels they want to book in and place their orders. Now, in this initial architecture, you see that there is, let's say, the web front where our end users come on to hotelbooking.com, they make their orders, and the orders are sent to this back-end order processing where they process the orders, they kind of have the e-payment gateway or credit card processing or whatever, and then they update the back-end databases. Right. Now, the challenge here is that under high load, let's say, holiday weekend, now it's a bit safer to travel. Let's just say we open up the borders, a lot more travels coming in. For a vacation or holiday weekend, for example, our site could be very heavy. And the web front, they receive the orders. When they pass to this back-end order processing tier, they may run into trouble. Why? Because there are too many orders coming in. These two order processing tiers, they actually get overwhelmed. Too many orders, they can't keep up. Yes, you can have some form of auto scaling, but what other means can we control the flow of orders to the back-end order processing units here? Because here is what we call not just tight integration, but what we call synchronous processing. What we mean by synchronous is I receive an order, hotel booking from the customer. I put it to the order processing node here. It's synchronous because I'm waiting for your reply here. Let's say this is the order processing unit. I'm waiting for the order processing unit to successfully process the order booking. I'm waiting for a successful message from the order processing and tell our customers, yes, we've got the order for you. It's confirmed. And it's synchronous because I'm waiting and I'm waiting and I'm waiting. And if this is overwhelmed, the wait is going to be long. Your customers are going to be unhappy. And worse still, if it fails, it collapses, it hangs, then we have connection timeout. And your users are confronted with, connection timeout message. That's not a good customer experience. So a lot of challenges here. So what do? Well, we introduce a queue. The queue then acts as a buffer. It acts as a buffer between your web front and your back-end order processing worker nodes, let's just call them. So that now your web front receives the order, your customers have viewed the hotels, they provide the schedule, the booking, and they send the orders. Instead of going to the back end straight away, they place it on queue. It's queued in. Now the advantage is here. When I put it on queue, I'm not waiting. This web front component is not waiting for the back end to process successfully. As long as I put it on queue, I receive a successful acknowledgement from the queue, I'm free to go. And this turnaround is fast. I put it on queue, the queue confirms that I received, I get the acknowledgement, it's done. So this is called asynchronous processing. Asynchronous because I put on a queue, I'm not waiting on the back-end worker node to pick it up. Whereas the back-end worker node has time to process whatever it's doing. Once it's successfully processed an order, update the database, it can pull the queue to take the next order. So it's a bit of breathing space for the back-end processor nodes here to process the order when they're ready to do so. Meanwhile, the customer experience is enhanced. Why? Because I said, once you put it on queue and you get a successful acknowledgement, you can tell the customer, this web front can provide a message to the customer to say, thank you for your orders. We will send you an email confirmation. So to the end customer, it's a nice experience, right? They will say that, this site is very good. It's very responsive. Under holiday period, I put in my orders, the confirmation or the reply came back quite fast to say that, they've received my orders and they'll send me an email. So to the customer, this site is fantastic, very good level of service. and then you free up the customer to view other services from your hotel booking site, maybe car rentals, etc. Right? You can have value-added services instead of letting your customers wait for the successful order to be processed. So it kind of improves overall. And meanwhile, as I said, your back-end processor nodes have time to go and finish your orders and pull the queue for the next order. Also, you can configure auto scaling based on the length of the queue, so that the metric to trigger the auto scaling now looks at how many messages on queue, and if it goes past a certain threshold, that will tell you that your back-end nodes maybe not enough. They're processing too slow. Yes, then you can trigger auto scaling to add in. But then because of the queue, you have breathing space. You don't have to scale aggressively. You don't have to scale too aggressively because, right, you have breathing space. You allow messages to accumulate in the queue for a little bit of time, a breathing space. And then only if it exceeds a certain threshold, you can then provision additional resources on the back end here to process the queue. Okay, so very important consideration here. And then the important here is asynchronous processing. Why? Messages are processed separately from the application, right? So there's a breathing space, asynchronous processing here. We'll talk about date letter queue, but date letter queue is like a normal queue, but it's only for orders that are not successfully processed by the back end that you put it in a date letter queue for more troubleshooting later. We'll take a look at that as well. A question from Chick Hong. Do you need SQS in serverless environment, like say in Lambda? Yes, you can use queues for serverless environments as well. So that, for example, in this setup here, you can place the queues in the SQS, and the SQS you can trigger and integrate with your Lambda function. So this could be implemented by Lambda, and the Lambda service will pull the queue. There'll be an extra Lambda feature here, but the Lambda service to pull the queue for your function and collect the orders and let your Lambda process those orders. And if necessary for other functionality, the Lambdas can also always place orders to the queue for you as well. Again, why do we want to do that? It's for asynchronous processing, giving buffer space between service components. Right? So in a service architecture, definitely you can use Lambdas with SQS queues as well. All right, Chikong, is that good for you? Also, in terms of, I kind of mentioned asynchronous processing. And another advantage of that is it creates tolerance for fail steps. So let's just say that in the previous module, if I said there was a failure, then you have a problem. There's an error or it hangs, fails, you have to give an error message back to your customer. Here, let's say this fails. If it fails, the message, the order booking is still on queue. Another worker node can pull and try to process the order. Even though this has crashed, the other one is still there. It can pull the queue and process the order. So there's tolerance for failure because the message remains on queue. Then, as I mentioned, you can have auto scaling based on the, let's say the length of the queue. You can auto scale additional back-end resources or servers or Lambdas Lambda is scaling is built in. So good news, you don't have to configure auto scaling for your Lambda. It's built in into the Lambda. If you have EC2s, you can have auto scaling based on the length of the queue. All right, Kesham has a good question here. If the bottleneck is at RDS, how to scale up RDS? How much time to upgrade RDS? So, yeah, it's something that you need to monitor to see whether there's a bottleneck here. But the good news in this setup, since we have asynchronous, even you have high traffic load from your hotelbooking.com, because of the presence of this queue, there's breathing space for both the back-end order node and the RDS, because they're not processing it real time anymore. They're processing it with a buffer time. So this works at a pace that it is able to work at, and this also work as a pace accordingly. Now, yes, it can a performance bottleneck if you have not sized your RDS well. It could be a bottleneck, right? So there are two ways to kind of address this. The bottlenecks for your RDS. If it's read heavy traffic that is causing the bottleneck for RDS, then you can add read replicas that we mentioned yesterday to offload the read operation. If it's because the SQS, the SQL transaction is very long running here, it may be that the RDS not enough compute power or not enough memory, so you have to upsize your DB instance to a bigger size to compute faster, to run those queries faster. So there is a service, if you're using RDS, you can look up RDS Insights. Basically, it'll give you performance insights to kind of help you to understand where is the bottleneck on your RDS. Is it because there are too many read traffic? So if you monitor that a lot of read traffic, then consider read replica. If it's long-running SQL threads, they're taking a long time to process SQL threads, then you can upsize your DB instance, or in combination with optimizing your SQS query to lighten them. Okay, so upgrading the RDS, if you upsize it to a to a higher DB instance, takes a few minutes to do that, typically like 10 minutes or so. But in this case, you can avoid downtime because there will be downtime. It's a single node. But in this case, as you can see, we have multi-AZ deployment. There's a standby. So if you choose to upsize your RDS, they will upsize your standby first. And once this is ready, they'll fill over for the standby to take over. And then they will upsize your old primary to be upsized, and it becomes the secondary. So the primary now is here with the upsize configuration. And so these are some of the things the RDS can help you with to minimize downtime. All right, Kisham, are you happy with that? Other considerations, which is, obviously they actually keep this simple, but here, if this is an e-commerce site, for example, they could actually, you have items like shopping cart, right? You could have another database to record the sales transactions, etc. So under high traffic volume, you may consider some of the NoSQL options or Redis, for example, or DynamoDB for the shopping cart, etc. Because they can take very high volume, very high throughput. And then you put a message queue like this to decouple your back-end, maybe sales analytics, your data warehousing. You can keep it to your combination of your RDS and your Redshift. But because it's decoupled by the queue, so that you are shielded from the high throughput. For high throughput, you want to put in things like DynamoDB or Redis or etc. because they are high performance and they can take the high throughput. So you can, depending on your scenario, you can further improve on this architecture. Basically, that's what I'm saying. Kesham, you have an application at normal time, only 300 concurrent users, but can pick to 9,000 users. This caused the thing to bog down. So, yeah. So that is challenging. Okay, like this. Consider then the Aurora serverless. Because Aurora serverless will help monitor what SQL engine are you using, because Aurora, is only for MySQL and Postgres. Hopefully you're on one of these two, because if you are, then Aurora serverless can help you because it will look at the load and then it will adjust the Aurora capacity for you automatically. MySQL, so good news. So you can check out Aurora serverless for MySQL and test it out. Use a sandbox environment Don't touch your production, but you set up Aurora serverless in your sandbox environment, then test load to mimic your kind of transactions and see. I'm pretty sure that the Aurora serverless will help you. Okay? Because one other way traditionally that we use to handle your situation is you upsize your RDS DB instance to take up that 900, right? But then, depending on how often the peak comes, some of the times when it's only 300 concurrent users, you have over provisioned your DB instance, so it's a little bit difficult to handle that. So Aurora serverless will help you with that. So yeah, you might want to test out. All right, Kisha, hopefully you can test that out. Huh? Use cases, work queues. We have seen work queues basically like our order processing or hotel booking work queues. You got your standard queues, we'll talk about that. You got a FIFO queues, we'll talk about that later. You've got a request offloading where you have a sequence of steps. So one task unfortunately takes a bit too long and it holds back. Upsizing takes 1 or 2 hours, especially when many users. Okay. Upsizing takes that long. Okay, yeah, because then you're probably under your. I'm obviously I need to know your RDS current configuration, but yeah, I can see the challenge there because it takes a long time to upsize depending on the yeah. If you want to, you can just let me know what is the method you take to upsize. Is it from a DB, maybe a M series to a R series, something like that, and then we'll maybe check it out. But under heavy usage, obviously, it's always a challenge to handle that. But yeah, as I said, the Aurora serverless may be a good option for you to consider. All right, but yeah, if you are facing bottlenecks like that, then try these other options and see whether that will help you or not. Okay. Okay, I was talking about request offloading. Yeah, please do. Yeah, very good. Let me know after class today, right? If you maybe during lunchtime you read about Aurora serverless, you want to talk further, then maybe after class session today you can further discuss. Okay. Now, request offloading, you have a sequence of tasks. Most of them are okay. They take quite short, but then you have one that takes long and it holds up the queue. You guys, I mean, all of you have experienced this before. You travel and then you come to a popular airport and the passport control, you have multiple lanes. And if we are in a lane where someone has a problem with the visa or the document check, then the whole lane is going to be delayed, right? Because one takes longer than usual. And usually this passport control, they have extra special lane for, travelers that need extra assistance or need extra checks, so that they are pulled out from the main queue to go to this extra lane where they have special services or assistance required. That frees up the passport lane so that the rest of us can go through the passport control faster. So request offloading is exactly like that, where instead of having only a single queue, there may be some requests coming in that takes a little bit more. You can actually send it to another queue that has a separate process to kind of process that queue or process that particular message. For example, let's take a situation where we are doing document transformation. Like say when users submit the PDF or JPEG or whatever, we kind of transform it into PDF. Let's just say this, just for the sake of discussion. But let's say some file formats take longer than usual to convert to PDF. Some maybe take very fast, maybe a Word document fairly fast or consistent, but other file formats may maybe take a longer transformation to happen. If that's the case, then we have some form of application logic to kind of maybe detect the format, and if we detect certain formats we know will take longer, then they go for a separate queue that will be able to basically handle those type of things. It will take longer, but at least you free up the rest of the orders from the slower task. Okay. Buffering, we just also talk about that. Buffering means that if you have a surge of orders because of a high traffic, they are buffered in the queue so that the back end is not overwhelmed. And it's also very good for batch operations. Let's just say we have a very popular high transactions e-commerce site, and we're taking orders, and every day at maybe a cut-off period of 9 p.m. we basically receive the orders, and we want to do a batch sales processing analytics to kind of calculate the e-commerce transactions for the day. And so at 9 p.m., there's going to be quite a lot of batch where we collect all the sales transactions. We're going to put it to our back-end sales analytics. But again, we don't want to overwhelm them with a tidal wave of a sudden increased request. We use a queue so that the batch orders that are coming in, they're absorbed by the queue. And then it gives breathing space for our back-end sales transaction or analytics to kind of read off the various orders or the messages from the queue and do the batch operation. And then auto-scaling, I mentioned this also earlier, that we can configure auto-scaling based on the length of the queue. Now, there are two types of, there are two types of queues. One is the standard queue and FIFO queue. Standard queue is high throughput, almost unlimited number of API calls you can take per second. You're talking about millions of API calls, to work with the queue. Downside is that the ordering is best effort only. So if you send in your message A, B, and C, it will be processed maybe C, A, and B, right? The order is not guaranteed. Also, it is at least once delivery. What does it mean? At least once? It means that it could be duplicate orders. At least once means it could be twice, it could be 3 times, right? So at least once delivered means that there's a chance for duplicate orders. If you think about a hotel booking example, there is a chance that each hotel booking order can be processed twice, right? So of course, we need to have some form of application logic to correct for that, right? To account for that. So if you want to use standard SQS, it's fantastic performance even under heavy load, but you need additional application logic to be able to, if you need it to be ordered, you need some application logic to kind of understand that it's coming out of order, and also a way in which you kind of make sure that you don't duplicate your order. So in a hotelbooking.com site, we need some application logic to make sure that we don't actually process a hotel booking twice, because our back-end order processing nodes, they may actually receive duplicate messages. After that, I'll explain why that is so, but maybe we need some tracking, right? Maybe through a external database or DynamoDB to kind of make sure that, I've processed this order already. So before any order is processed, we always check with the database and see whether the order has been done or something along those lines. Okay? Now, if you don't want to deal with this type of uncertainty, then you go for FIFO, first in, first out, and the order is guaranteed. If you send in the message in the order ABC, it will come out ABC. That's guaranteed. And it guarantees only once delivery. There's only once delivery. That means there'll be no duplicate of orders, guaranteed. So if you want less application logic to kind of handle this kind of uncertainty, then go for FIFO queues, but is limited API calls. It can't take large throughput. It can handle 300 transactions per second. If that's good enough for you, then that's fine. That's not a problem. With batching, if you use batch, you can batch up to 10 messages for each API call. So effective rate is about 3,000 messages per second. Now, you have to decide as a solution architect, what is the thing that you're looking for. So for some applications, 300 is not too bad. 300 to 3,000 messages per second, not too bad. I don't actually hit that kind of transaction rate, and I enjoy this type of FIFO thing, then go ahead for FIFO. But if you're having a super busy, high throughput situation where you want the unlimited API calls, yes, use the standard, but then be prepared to handle this inconsistency. Some of the features that we'll be looking through will be the life cycle of the message. We'll look at some of the life cycle here. Visibly timed out, that means when a back-end order processing node, they process a message or an hotel booking order, while it's being processed, the queue will impose a visibly timed out to hide this message. So another order processing worker node that posts the queue will not see this order to prevent duplication of orders. And then you have this concept of short and long polling. I'll explain that in the next slide or next few slides. And then date letter queues that basically helps offload messages or orders that have been failed to be processed. We put it in a date letter queue. So beneath the hood, your SQS is a distributed node system, horizontally scaled. As your messages grow, they kind of add in additional nodes, but completely serverless, so you never see this. But just to understand what's happening beneath the hood, you have this distributed node of SQS servers. And then whenever an order is placed on queue, it is also distributed redundantly so that there's no single node failure, right? Your message is duplicated. So if there's a node failure here, your message is still there, basically. All right. Now, because of this distributed nature, it's just like the DynamoDB node SQL is distributed node. One of the challenges of distributed node is the consistency. How do you get it synchronized and consistent? And we'll look at some of these issues as we discuss this distributed nature. One of it is short polling versus long polling. For short polling, the advantage is the speed. If I poll the queue, I want the reply to come out fast because I'm handling a lot of transactions, so I need the speed. So under short polling, we will not poll all of the queues. You will not poll all of the SQS server nodes. We will just take a sample through some statistical formula. We'll just take a sample of it. So for example, a short poll from the consumer, I poll this, we'll just take these 3 nodes as a sample and see whether there's any messages. And then we'll not wait for the rest. We'll just take these 3, see whether there's a message. If there's a message, we return this message. In this case, yes, there's a message because of the redundancy. We have found a message, it comes back to the consumer and it's processed fast. So the turnaround is very fast. However, what if the short poll sample takes this one, and this one, these 3? Basically, it's an empty result, right? You poll this, there's no message. So your consumer didn't get any message. Whereas there's actually messages in there. It's just that you missed it through the short poll. So you need a second time, a third time, a fourth time when you do that short sampling before you actually see a message. So you need multiple calls. You may need multiple calls before you see a message for this short poll. So the advantage of short poll is very fast turnaround, but the downside is that you may miss certain messages and you need more API calls to see a message. Now, this has some cost implications because they charge you per API call. So if you're taking 2 or 3 or 4 API calls before you get a message, you have speed, but then you pay more because you need multiple calls before you see something, all right? So long poll is you set a parameter to wait up to a maximum of maybe 20 seconds, I should say. So long poll means I poll and I wait. Wait for what? Well, I wait for the nodes to be synchronized. And if I find a message, then yes, of course, I return back to the consumer. But I'm prepared to wait until the maximum you set so that if it's the first time, if I wait, it's empty, no messages that come, I still wait until a message comes in and I get the synchronized result, I return. Of course, up to the maximum expiry, let's say 20 seconds, if I still don't get any, then it's an empty result. But it increased the chance that you will find the message result so that in under one long poll is likely higher probability that you come back with messages and results, right? So from a cost perspective, it's a more efficient use of your cost. Downside, you wait longer, right? It's not, the turnaround is obviously not as fast. Okay, so you have to have that trade-off consideration between these 2 types of polling. Also, I said that for the SQS, for the standard queue, you actually could have duplicate orders, duplicate message. Because one of the key things about this polling method is that if I'm the back-end processor node, let's say I process this order, I process this hotel booking order. If I successfully process the order, it's my responsibility as a consumer to send a delete message back to the SQS so that they'll purge the message from the queue. This is to prevent duplication of orders. However, let's just say when the delete message comes in and it goes out to the nodes, this particular node, for that instance, it had an outage. It didn't receive the message. So whereas the other nodes received the delete message, they will purge they'll cancel the message or delete the message. This node, because of a temporary network outage, it didn't receive that message. So you keep the message on queue, whereas the others are gone. Now, it means that it's not deleted, it's still there. So that other worker nodes, when they poll the queue, they will get to see this message and they will process that hotel booking in our scenario here. They will process the hotel booking twice. I mean, another time. So you already processed, you process again. So duplicate of messages. So your application logic must have a way to keep track of orders that has been processed already to correct for this type of possibility. So basically, let's go through the life cycle. The message is on queue, and now the consumer polls the queue and retrieve the message. We impose a visibility timeout so that at the same time, other consumers, when they poll the queue, they will not see this particular message or this particular hotel booking order to prevent duplication of orders, as I mentioned, right? So it's hidden. Now, let's just say this worker node, it tried to process the hotel booking and it fails, it hangs, it crashes, whatever, there's some error, it cannot process the message correctly or successfully. Well, even if it crashes, after the visibility timeout, let's say for X number of seconds is expired, then it becomes visible again. Another back-end processor node can poll and try to process the order again. So as I mentioned earlier, there is this fault tolerance built in so that if a message failed to be processed, is still on queue, the visibility timeout expires, another worker node can poll the queue and get the message and process the message, right? So that's one way to do it. However, if the hotel booking is successfully processed, then the consumer will send a delete message, call back to the queue, and the message is purged from the queue. All right, let's look at this short polling again. So you have this distributed node, and the short poll will poll quickly, short turnaround. Is there any messages? Is there any messages? So you have number of API calls. Now, because of that short polling, it's only going to take a sample of the server nodes here. The first API call will return A and B messages based on whatever node that has been polled. The second API may miss anything, comes back empty. The third one takes C, right? Next one also empty because maybe not shown here, there are nodes that are empty. And the fifth one takes D and E. So in this example, you need 5 API calls to retrieve all the messages, and each one costs you money. But advantage, fast. Each turnaround is fast. Long polling, you set a time up to 20 seconds, let's just say. So one API call, I wait for the nodes to be synchronized, and then I return the result. So through a single API call, you get all 5 messages for the back end to process. So much cheaper in that sense, but a longer wait. The date letter queue is, as I said, you can set a maximum retry to say that, okay, if the backend node tries to process the order, fail, one failure. Another worker node tries again, another failure. Another one tries, another failure. So you can set a failure threshold, max retries, maybe 3 times. So that if the message has been on the queue, is already 3 attempts to process it, it fails, we bring it to a date letter queue, which triggers a lambda. In this particular case, we send the Lambda function back to the original queue for another round of trying. So again, it goes to the same cycle. I try once, fail. Second time, fail. Third time, fail again. Well, this time, we put it into another date letter queue, and the operations team will manually pull the queue and try to troubleshoot why this hotel booking order failed. Right? So this is the way in which you can offload your main queue from problematic orders or messages that have some form of an error or corruption that cannot be processed successfully. Okay, when to use message queues, service-to-service communications, like what we see, the web front to the order processing, service-to-service is buffering the two, and to implement this asynchronous processing and state notification change, so that, for example, if we can have a S3 event notification again, if the new image uploaded to the S3 bucket, we can have event notification to place that notification on the queue so that you could have your Lambda pull the queue and see, oh, there's a new message, there's a new image uploaded, you can go ahead to download the image for processing, for example. Select specific, okay, so these are not good use cases. Let's say you have that queue and you want to select only specific messages to process. So if I go back to our hotelbooking.com, let's just say you've got a hotel booking queue here, and you say, oh, I want to give priority to my VIP customers for their hotel bookings to be processed first. So I have some application logic to try to pull the queue, but only I want to look to make sure that they are from my VIP customers, and then I will process them. If not, I'm not going to process them first. I want to prioritize my VIP customers. You can have application logic to do that, but we don't recommend you do that because you could miss out certain messages. Certain messages could be orphaned, that nobody picks them up, and they are stuck in the queue. If you want to have service differentiation, like for your VIP customers, your gold customers, and regular customers, then have 3 separate queues, each one with a service. So you have a VIP queue, you have your gold queue, you have your standard queue, right? And when your users log into your hotelbooking.com, their orders are directed to different queues for different service levels. For example, if you want to do that, then have separate queues. Don't try to differentiate messages within a single queue. That's what it is. Also, you have limitations on the message payload. Some of you coming in from Apache MQ or RabbitMQ, the payload can be sizable, but for SQS is limited to 256 kilobytes. That's the maximum payload. And so if you have a larger payload, you have a limitation there. One workaround is to have the actual payload stored in the S3 bucket. So if, let's say, you have image processing app, the users actually upload their images to the bucket, and the message is in the queue, the Lambda functions picks it up, and you don't need a large message for that. You will keep within the 256 kilobytes, and the Lambda will pick it up, the message, and then download the actual image from the S3 bucket. Something along those lines. You can have a sort of like a workaround, but the SQS has a size limitation of 256, right? All right, let's look at SNS, basically a simple notification service where basically you publish messages to topics, and then you have subscribers that will be notified. You will push those messages to your subscribers. So again, why reinvent the wheel if you need this kind of pub-sub model? Just use this serverless service from AWS, SNS. You create the topics, you can have many subscribers subscribing to the topics. Think of it as maybe your e-commerce site that some of your customers may be interested in certain products. They want to be notified whenever there's a new product offer or whatever new product is there. They subscribe to certain topics, and when you publish this sales promo or new product announcement, they will get the notification. So you can have different topics for different type of messages or notification, and they are pushed out to these subscribers. And the subscribers could be in the form of an email, mobile text, HTTP endpoint for integration with a third-party application. It could be a Lambda. The SNS can also be integrated with the queues, so that the subscriber could be queues. You put in a notification, and the subscribers get the queue message. It could be a Kinesis data firehose. We'll talk about that later. That is for large volume of streaming messages. You can use a Kinesis data firehose as well. So this simple notification service is quite useful and is used by a lot of AWS services. Yesterday Chik Hong was asking about the pricing for the CloudWatch alarm. So CloudWatch alarm also uses the simple notification service to send you the email when the alarm is triggered. So I've done a brief check. If you are under free tier, the 1,000 messages per month is free, I think. But beyond that, I think they charge you X number of cents per 10,000 messages, right? So you can Google AWS SNS pricing to see the pricing details. So because the CloudWatch alarm uses SNS for the email, you're subject to those pricing. Okay, just a bit of note here. But key message takeaway is that it kind of takes off the load of doing this pop-up type of messaging for you. And so you could have things like, that is just what I mentioned, the CloudWatch alarm notification, right, through email or SMS. You can configure that, but you'll be subject to SNS pricing. You can send an email, SMS as well, and integrate with your mobile application for push notifications to your mobile apps, right? For example, your Grab app or your Uber app, maybe they send you some notification through the app, or your Shopee or e-commerce app, they send you notification for your order updates or whatever it is. Push those notifications, and you have that kind of use case scenario as well. Simple notification is the correct answer for you. Some of the characteristics here is a single published message, and then that message will be pushed out to your thousands of subscribers. There's no recall option. Once it goes out, you can't recall it. And for your HTTPS endpoint, you can have retry options. You can have perhaps exponential back off, so that you don't overwhelm the endpoint if it's not able to take the load. So you post the message or you push the message to the endpoint. If there's no reply or cannot acknowledge, then you wait for 1 minute, push again, doesn't reply, wait for 3 minutes before you push again. So you back off exponentially without overwhelming the endpoint. And then you get a push to your queues, either the standard queues or FIFO queues. Now, when you integrate or use SNS together with SQS, something that you're doing in the labs later, you have this fan-out cloud pattern where a single topic can work with more than one queues, and you have different backends that work with the queue. Maybe one for order processing, one for analytics or analysis of the sales transactions, whatever it is. So single topic, more than one queue. That's called a fan-out. Kisham, SNS sending the email, does it include the SMTP service? Yeah, you have to set up the SMTP service. All right, I will give you the documentation for that. Right, so give me a moment during the lunch hour. I'll try to find the documentation on the setup, but there is setup to be sure. Right, using SNS and SQS, the comparison message persistence. Well, it doesn't keep your messages for the notification service. Once it goes out, it's deleted. Whereas you have message persistence on the SQS. Delivery mechanism is a push for the SNS. So your subscribers are passive. The service will push it to them. Whereas the SQS is a poll mechanism where the consumers, the receivers, have to proactively poll the queue to get the messages. In terms of the producer-consumer model, it's PubSub for your SNS and send and receive for your SQS. Distribution model one-to-many, that's obvious for your notification. And the SQS is one-to-one. One-to-one means that just imagine you have a message producer, hotel booking example. You have only one, ideally you have only one back-end to process that particular order. Kinesis and step functionalities basically, these are two other sub-modules that I'll cover, after the lunch hour. But I want to move forward so that we don't break off too late for lunch. I want to move, to give you a moment, I want to move to the lab just to talk about the labs here. Right, so that we can have you can have more time to manage the labs. Give me a moment just to make sure that the labs are ready. Okay, looks good. Give me a moment, yeah. And then after lunch, I will continue to other subtopics. Basically, set it up. Okay, let's look at this lab, build serverless architecture. Now, this is a very interesting lab, and I highly recommend that you kind of do it so that you get a feel of this serverless environment. So basically, you have this, it's an image processing kind of scenario. So it's quite interesting. You upload images to the S3 bucket. You configure the S3 bucket for event notification. And then basically what is going to happen is a fair bit of configuration here. You send the event notification to an SNS topic. And the SNS topic actually has 3 queues. So this is what I mentioned earlier, is a pan out kind of situation. You have 3 queues and you have 3 separate Lambda functions to work on the queue. So basically, you're going to do some form of image resizing or resolution here, and different resolution size is handled by different queues. And so you have separate Lambda functions that will actually work on the functionality on the queues. And then the result of the resizing, whether it's a thumbnail or for your web app or for your mobile app, is updated to or uploaded to a S3 bucket. And then you have a chance to see some logs in action as well. And so the key takeaways from this lab is, number one, this is what we mean, one example anyway, of a SNS serverless type of architecture. And you'll be using serverless type of services like S3, SNS, SQS, Lambda, and CloudWatch. They are all serverless. The only thing that you want to be careful about is that there are a fair bit of configuration in terms of getting it right. So there are 3 Lambda functions as well. So you want to be aware of the fact that you have 3 Lambda functions. Let me just draw out the lab instructions here so that I point out where you have to be careful in terms of looking at some of these instructions. Okay, let me see. Where is it? Sorry. Just give me a moment. Open the lab. Okay. So basically, you create the SQS queue. So there are 3 queues to create basically. And remember, because you have 3 queue levels here. And then there are some settings to subscribe to the SNS topic. So you have to repeat because there are 3 queues. And then you have a verification step to see whether the simple notification is sending out the message correctly. Okay, so there's a bit of verification here. And then you create a, this is where you have to be careful as well, 3.1. Basically, you have to do some form of testing to make sure that the S3 event notification can actually send the notification to the queue. And so there is some adjustments to be made in terms of the access policy so that the S3 bucket can send it to the queue. And then basically there's some adjustments here to create that event notification on uploads to the S3. So what it means is that when the images, you upload the image to the S3 bucket, the S3 bucket will generate the event notification and basically to the SNS, and the SNS in turn will actually trigger the queue. So there are certain settings here to be done, and certain parameters here to be put into. Just be mindful of that. And then in terms of the Lambda functions, there'll be 3 separate Lambda functions for you to use. Just be mindful of the names of those Lambda functions, the runtime as well. All right, make sure you choose the runtime as Python 3.7 basically, and then choose the right, how do I call it, execution role for your Lambda function. All right, all this you have to get it correct to be able to run the labs correctly. But all in all, a very nice lab to get used to this serverless type of infrastructure, and I'll give you the full 45 minutes to do that. All right. So I'll give you 1 hour of lunch break right now and 45 minutes of lab. So all in all, 1 hour, 45 minutes for you to manage your time. All right. I'll see you after that. Meanwhile, don't leave the WebEx section, because I just want to do a verification on the attendance to kind of do a head count. So you can go for lunch, but don't log out, because I want to take account to the session. Okay. Yeah. Kesham, do you mean we use our own SMTP? Well, there's a default setting in terms of the simple notification service to configure it for email, and it will work out of the box. You can do a test later in the lab as well. When you test out on notification service, you can actually create an email notification. But if you do that, then you accept the default settings. But if you want more control over the email templates, etc., you can actually do an integration with simple email service, and that will be some additional steps for you to set up your SMTP with this simple email service. So a little bit more configuration there. But if you are prepared to accept the defaults from SNS, then you can straight away use the inbuilt service from SNS. You can test it out in the labs later to try to create an email subscription as well. Right? Please do test it out and let me know. Right? Hopefully that answers your question. So you can default just to use it. But if you want more control over the email templates, etc., then you can set up with another service called Simple Email Subscription. I'll just put some of the reference points in the chat. All right. So meanwhile, everyone, enjoy your 1 hour lunch break plus 45 minutes of the lab. I'll put the lab timings or the class timings on the chat box. All right. Meanwhile, have a wonderful lunch break, and I'll see you later. Please remain on the WebEx session. Thank you. See you after the lunch and the lab. Right, welcome back from the lunch break and the lab session. Anybody still working on the labs? Just a quick check. Right, Tara, you still working? Anybody else working on the labs? Ah, right. So a number of you are still working on the labs, yeah? Okay. Configuring the email. Okay, right. Just do a quick check on that step here. Okay, just do a quick check here. Right. Yeah, your labs have a countdown, Anilio. So if you already started on labs, it will time out. But if you haven't started on labs, then that's fine. You can do it after office hours. Start the labs. That's fine. I just want to check. I think most of you guys are on the last bit in. Okay, yeah. So no worries. I'll give 10 minutes on the clock. Now extend another 10 minutes for our friends to just kind of finish off on the labs. And meanwhile, those of you who are back, please to take a short break, extended 10-minute break, and I'll put the countdown timer for 10 minutes. All right. Thank you very much. Thanks very much. See you in 10 minutes. All right, welcome back to the session. I hope you had a nice lunch break and lab experience. And just an update, I'm pleased to announce that our lab access have been extended for all of you to next Monday, 28th March at 11:45 p.m. Singapore time. So you have Thursday, Friday. Well, you have 5 days to kind of complete the labs, including the capstone. So hopefully there'll be enough time. So you're most welcome. And I trust that most of you have finished with the labs. But if you do have ongoing issues to that, please do let me know. I hope Charon Chai and Chicha Note has finished, and Kolun as well. Hopefully you're good, Tara. And the rest of you who are back, if you can hear me clearly, could you please give me a chat and chat message or virtual thumbs up so that I know that you're back and good to go. All right, thank you very much. All right, very nice, thank you. Thanks for that. Okay, any ongoing issues with the lab or all good with the labs? Anyone has still any pending lab issues that you want to highlight? Okay, if not, please put it on the chat if you, all right, you're not able to asking for account ID. So Anilio, please get back to me. Account ID, is this the quick lab, Anilio? Make sure that you sign in to Quick Labs using your email ID that you use to register for the class. But if you do have ongoing issues with that, during the break later or after the session, I'll sort it out with you to make sure that you do get the Quick Lab environment so that you can complete your labs, all right? But just make sure that you use the same email that you use to register for the class to make sure that you get the lab access, right? So basically, if you haven't done so, create the Quick Lab account, AWS Quick Lab account using the email ID that you use. But if not, I'll get back to you during the break later or after the session today, just to verify that you can get access to the labs, all right? Now, with that, let me come back. You're most welcome. Let me come back to the Kinesis section. We just have two fairly short sessions to just as a roundup. These are good services to know about. First of all is the Kinesis, our streaming services from AWS. And this is the business intelligence analyst that is talking about here. I work on trend analysis. My team is rethinking the way we process streaming data. And so what are the streaming, data streaming related services that we have in AWS? So basically, this is the Kinesis suite of services. You've got Kinesis Data Streams, and this is the service, the primary service that allows you to ingest and collect streaming data from a variety of sources. And then you've got Kinesis Data Firehost, which is to stream data to populate selected destination sources. For example, your S3 bucket, your Redshift, data warehouse, OpenSearch. It used to be called Elasticsearch, but OpenSearch analytic tool, for example. So these are possible destinations where you may want to channel your streaming data. And Kinesis Firehost helps you do that. It helps you to collect from a streaming source, and then it streams to your destination. You also have Kinesis Data Analytics. This is a service that helps us run SQL type of queries onto your streaming data, basically. Alternatively, you can use Apache Flink as well as the query language to query your the streaming data coming in. So for example, you may stream data into Kinesis data streams, and you use Kinesis Data Analytics to run those queries there, so that you have this stream analytics going on to filter out, aggregate, or whatever kind of analytics that you want to work on the data, the streaming data. Finally, you have the Amazon Kinesis video streams. These are specifically made for video streams that run your analytics. So just a bit of overview on the Kinesis data streams as well. Just to zoom in, this is one of the primary streaming services that I mentioned, where you can actually define your producers that actually produce your streaming data. We call it data records, and to write those data into Kinesis data streams. I should mention straight off that it is a serverless set up so that you don't have to run any servers. The Kinesis service will make your stream data records redundant across availability zones for you. But what you can do is to define the shards. How many shards do you need to ingest the data and to hold the data? So basically the idea is you want to stream in data, but you need this service to hold the streaming data for you until they can be processed, basically. And we do it through this concept of shards. Think of it like logical partitions where your data records are being kept. And how do you size your number of shards? Well, each shard is a logical, can think of it as a streaming storage service that can ingest data at 1 megabytes per second, as you can see on screen there. So you can write, in other words, you can write to the shard at 1 megabytes per second, and you can read of it at 2 megabytes per second. So that's the transmission throughput in and out. And so if you have a requirement to have an ingestion rate at 3 megabits per second, for example, then you need 3 shards. So because the shards, the combined throughput, you add up all the throughput per shard. So if you need 3 megabytes of ingestion rate, then you need 3 shards. If you need, for example, 4 megabytes of read rate, then you adjust it to at least 2 shards. That being said, in terms of the output, that means the read rate, you can also basically, for each shard, you can extend the read throughput by several factors. That means, for example, you have 3 clients reading from shard 1. You can expand the client read rate to assign them 2 megabytes worth of read rate per client. So on the read side, there's a feature to kind of extend the read rate. So with all these features, given a particular scenario requirement that you need a certain read or write throughput, then you can adjust and calculate the number of shards that you need. And so basically, once you get the shards here, your data producers will write to the shard, and you have a partition key like A, B, and C. And then when your producers write to the Kinesis data stream, they can say, okay, send it to partition A, B, and C, so that they kind of populate the shards. And then over on the numeral number 3 there, these are your consumers that will read off the stream data from these shards, do a level of processing, and then the results of the processing can be stored at these locations. As you can see, it could be a Redshift, it could be an S3 bucket, it could be a DynamoDB table, for example. Right? So Kinesis data streams allow us to process data at near real time or real time speeds, so that you have this real time processing of your stream data. The other service, just to highlight to you, is the Kinesis Data Firehose. Basically, the whole idea about Data Firehose is that you want to ingest data, stream data from selected data producers, and then you want to direct or host the data into several specific destinations. So the key value proposition of this Kinesis Data Firehose is that it's like a holding staging area to collect stream data, and then it buffers to a certain extent and push it out to your destination sources for further analytics. So we call this near real time because there's some buffering involved. Kinesis data streams that we saw earlier is considered real time because it happens within few hundred, tens to hundreds of milliseconds, that kind of time frame considered real time. Near real time is seconds. For example, the buffering can go to from 60 seconds onwards, for example. So near real time, quite fast, but not exactly in real time. And as I said, you can think of this as a staging area where they buffer the stream data and then push it on to your destination host. And so at the destination here, they will basically, for example, if you take S3, they will try to buffer and concatenate records together up to a certain size before they put it into an S3 bucket. And this helps avoid the situation where you have too many small objects, because each record comes in very fast. And if they didn't have this buffering, we just lump the whole thing into the S3 bucket. It generates a lot of small objects, a bit harder to manage and more costly because you need more S3 API calls to access those objects. So what they can do is they kind of concatenate into a compressed file and then send it across as a one big object to the S3 to compress and send it to S3. And then you can have things like Athena and whatever to kind of read off those to do your analytics. Alternatively, there are other destinations. As you can see, Redshift, your data warehouse, can hold your stream data as well. Underneath the hood, you kind of need to have an S3 bucket first and then Redshift. Then you have the OpenSearch. It used to be called Elasticsearch. It's an analytical tool. You could have a HTTP endpoint to stream it to a particular application endpoint if you want, and third-party service providers that can integrate with your Kinesis data firehost like Splunk, New Relic, Datadog. These are these third-party service providers that are integrated with this firehost service. So the whole idea is this is anytime you have identified a destination that wants to receive this stream data, then Kinesis Data Firehost is the service to connect the data producers to these destinations. All right, in terms of step function is one of the key services now in a microservices architecture strategy that allows you to implement a workflow type of logic to take it stage by stage or step by step in terms of the logic that you want to implement. So far, we've talked about, say, Lambda function as a serverless compute environment, where you can have Lambda functions defined and they're invoked accordingly. But a Lambda function by itself is a one-time invocation. So for simple services or functionality, that's fine. You trigger the Lambda function, it does something, and then that's it. The result is there. But what if as you know, the Lambda function has up to only 15 minutes, is not meant for long-running applications. But then what if you have a fairly sophisticated logic that you want to implement step by step? For example, if let's say you are managing or we are trying to create a solution for a call center, let's say a technical support call center where we're receiving call incident reports or technical issues or support tickets, and then it need to go through several stages of evaluation and assignment to level of severity and human intervention, etc. And so it's a step-by-step process until you find a resolution to the support ticket. And that could take extended time, depending on the SLAs, from hours to days, in fact. And you can't have one single Lambda function that can do it end to end, right? So you need that kind of workflow logic step by step. Well, this is where step functions comes in to allow you to define that workflow structure with well-defined states in the workflow structure, and have each state, logic, or task be implemented by a Lambda function. In other words, it could be a whole series of Lambda functions that is controlled by this step function, so that as you go through the workflow logic, it can trigger these individual Lambda functions appropriately. And so this could be one option to implement a fairly sophisticated workflow logic using a serverless way, because step functions is serverless and Lambda function is serverless. But step functions is not limited to Lambda functions. There's a whole breadth of services that it can integrate with. I'll show you, in the console later. But this is one of the main use cases of this step function. Another way of saying this workflow logic is to think of a concept of a state machine. a state machine is a situation where you have well-defined start state, intermediate states, and end state, and you have well-defined state transitions, triggering events that trigger the state's transition from one state to the next. And so the classic example is a vending machine that has well-defined states. So for example, it goes first of all into a waiting for transaction state, and it will remain here until the consumer places a coin in the vending machine, and the receipt, the sensor that detects the receipt of the coin is the state transition trigger. So it triggers the state transition from waiting to soda selection. And at this stage, or at this state, the lights, of course, will lit up for soda drinks that have in stock still for selection. And when the consumer clicks on a particular soda selection button, that triggers a state transition to the vent soda stage, where the robotic arm takes the drink and vents it out of the machine. After that, once the drink is picked up, the state would transition back into the wait stage. So a state machine is like that. It has well-defined states. It has lights, of course, conditions that trigger a state transition from one state to the next. And so to help capture this type of state definition and state transition, you have Amazon States Language ASL. It's in JSON format, as you see there, and it allows you to define your states. And then for each state, for example, if there's a task to perform, you can define the resource that will perform the task. In this particular example here, it is a Lambda function. For the start and final state, they are Lambda function. Of course, you can have all the intermediate functions as well that are implemented through these Lambda functions in a serverless way. So basically, we use this to build workflows. So for example, if we have a workflow to check application submission by, let's say, our end users or customers or clients for certain application or certain functionality. So we have a start state, and where they submit their application, and we have two parallel states here to check different things of the forms being submitted. First stage here is to verify the identity documents, maybe the identity card or whatever it is, and to check the address of the applicant. And then based on the results of these checks, there is a decision branch or logic branch here to decide whether human review is required. And the decision point is that if the identity documents are clearly defined, we can actually scan, it's clear, address is valid, whatever, then it goes into the approve application state, and then it ends. It means that in this case, no human review is required. However, if the outcome of these two states indicate that there's something that's incomplete or wrong or etc., then it's a yes for human review. It goes into wait for review state, where it waits for the human to enter or approve it going forward, and then it goes to the decision path here as well, whether the human has reviewed and approved or not. If it's approved, then it goes to the approved application state. Maybe with here, you trigger a notification to the client that their application is successful, and then you go to the end state. Now, if the human reject the application, then another notification is sent out through an email informing the user that their application has been rejected, and they have to contact their help desk or whatever it is there, right? And then you end the workflow logic. So this is one example of how we can do it. The other example, maybe something similar. You're submitting a form, for application or of a sort, but a little bit more complicated now in terms of, this could be a website and the users are interacting with the web service, and that our internal backend here is fronted by the API gateway, and then as the users submit the form, click submit, and all that is you can see it's a HTTP post which triggers an API call. The API gateway will take that API call and can directly, in fact, trigger a step functions workflow. So you look up the customer, let's say ID, for example, is done by a Lambda function that takes a lookup at the DynamoDB, generates a application reference number. Another Lambda function will do that, and then you record the transaction, you update the database, and step functions is able to directly work with DynamoDB to put in a record, for example, and then basically comes to another state that the applications is reviewed, success, failure. If it's a success, it's an end. If it's a failure, it notifies the admin through a notification service here for manual intervention. Okay, so this is another example of how you might do it. So this is quite a powerful tool. I mean, let me just show you how it looks like in the console. Maybe this is some of the ones that I have here. So this is like a tech support case over on the right here, where you open the case, you assign the case, you work on the case, and see whether the case is resolved or not. If it is, it's closed. If it not, you escalate the case. And over on the left here is the Amazon state language, where is the JSON, where you define your state. So open case, the task, where you do the initial case review, and is implemented by this Lambda function. Of course, the Lambda functions might exist. You must pre-create them. And then you assign the case that it looks for a support agent to assign the case to. So that logic is implemented by this assign case function, and so on and so forth. So in this particular example, most of my tasks are implemented through a Lambda function. All right, that must be already present in the Lambda function. What you can do is, if you want to create from scratch, you could, this is what I did, you can write your workflow in the code like this, right? So you have this, you can look up references to get some samples like what I did, and just paste it there, and it will update the diagram here, your visual canvas here. Or better yet, you look at some of the projects that are already there. So this is also a nice way to learn, to see what has been done, so that you don't have to reinvent the view. So you have various scenarios like managing a EKS cluster, basically call a microservice using the API gateway, and then you could have manage a batch job, for example, a container task, tune a machine learning model. So they have very nice projects pre-packaged here that you can kind of run them, select them, run them, and test them out. Or you want to have a Visual Studio to build your workflow visually. This is a very nice tool to have. And take a look at the studio here, where you can define your state. So I can define, okay, I want to invoke a Lambda function. Okay, obviously, then you have to choose the Lambda function to invoke or whatever, right? So you invoke the function, then maybe go to another Lambda function. And this time I choose another Lambda function to maybe assign the case, let's just say. So I kind of, it's a very nice visual description of, what I'm trying to do. I'm trying to build the workflow here. And then basically, as a result of the case assignment, maybe I want to update a database. See whether I can just do that and put in an item. See whether I can put an item here. So at this stage, it kind of updates the a database, and then maybe another evaluation. And then I can put in a choice, a branch logic, all right, based on certain evaluation, it updates, let's just say, a parameter, and then based on the parameter here, maybe I can run another action here, or it could be even a step function, that workflow, another step function calling another step function, that's possible. Or if it maybe fails, maybe I'll put in a SNS notification. notification maybe. So you can have this type of Visual Studio just kind of build up your workflow logic. So if you're thinking about a way in which to build up your microservices strategy, serverless strategy through this type of workflow, type of execution, then I highly recommend you take a look at Step Function. Okay. All right, that brings us to the end of this particular module. Let's look at the knowledge check here. Which type of SQS queue provides at least once delivery? Okay, very good. Yes. Is B, right? At least once means possibility of duplicates. So that is standard queue. FIFO queue is exactly once. That means they'll guarantee there's no duplicates, right? So at least once is B, standard queue. What is an advantage of long polling compared to short polling? All right, very good. Very, very good. Yes, the answer is C, right? That's the advantage of your long polling. Well done. What is the feature of, what is a feature of Amazon SNS? Okay, very good. Yes, the answer is C. Right? Okay, very good. Any questions on this module on serverless? All right. Okay. Now we will move on, and now it's coming up to pre. So if I give you the lab. Yeah, okay, then I'll do the the part 2 of the networking. And let me just bring out the my little whiteboard here. Okay, so this is where we left off previously in terms of our VPC environment. And now we want to talk about extended options for external connectivity. So up to this stage, pretty much we've got the VPC internal communication as well as through the internet gateway, we are able to have internet connectivity. Okay, so what of the options are there? So maybe we want to connect our network back to the on-prem corporate network here. So I have a number of on-prem servers here. That I want to connect with, and let's just say that the 68.10.0/24. Let's say that's my on-prem IP address range of this on-prem servers here. And so this is obviously a hybrid type of situation where I've got on-cloud workloads, but I also have these on-prem workloads here as well. And so how do we want to combine these networks together? Well, one option is through a site-to-site VPN. In the site-to-site VPN, we're joining two networks together, your cloud and your on-prem, and we're going to use IPsec VPN to establish the connectivity. So for that, we had to deploy another gateway called the Virtual Private Gateway or VGW. Virtual Private Gateway. And then on the customer side, on your on-prem data center, you have a customer gateway. A label here. Virtual Private Gateway and this customer gateway here. So there's a list of customer gateway models that have been tested with our AWS Virtual Private Gateway. So you have, for example, Cisco, ASA, and F5, and other modules that are supported. There's a whole list there. So if that's one of your models, then when you set up the site-to-site VPN, you can select that. Yeah, mine is a Cisco ASA, and you are able to download specific network configuration for your network team to set up your side of the connection here. But even if your customer gateway here is not listed, your model is not listed there, it should work because the IPsec VPN is basically an industry standard. So as long as your device can work with IPsec, then it should be fine. In which case you can just choose the selection called generic customer gateway. So you have a generic network configuration detail setup. And the whole idea is to set up this site-to-site VPN. So basically you have to establish just choose the right shape here. Right. So actually, what happens is when you establish the site-to-site, there will be two physical tunnels that we establish on the VGW for redundancy, right? Two physical tunnels, so that if one goes down, there's another one that's still working. But for convenience, I just use a single logical connection like that, right? But understand that it's actually two physical tunnels. And basically, they'll go through some VPN handshaking, phase 1, phase 2, they call it handshaking between your virtual private gateway and your customer gateway here. And at the end of the handshaking, this site-to-site VPN is established. What it means then is that now you can start to route traffic. Now there is two types of routing. One is called static routing and another one is dynamic routing. For static routing, it means that both of these devices here, they need to know what is the reachable address on the other side of the connection. So basically, we have to statically configure this address to the virtual private gateway so that it knows that if I see any packet destinations for this range, I know to send it to this VPN connection back to the on-prem corporate network, and vice versa. So your device here needs to understand that if there's traffic going to this particular address range, we're going to send it across to this site-to-site VPN. Okay, so basically let's click here, and basically I have to statically configure that this is for the destination address that falls within the VPC range. Now, then you decide which subnet needs to connect to the site-to-site VPN. So let's just take this as a VPN subnet, where perhaps you have some security scanning appliance here to scan all traffic, filter all traffic from the VPC before it goes to the site-to-site, and vice versa, from return traffic from the on-prem corporate network can be scanned by the security device that is in subnet number 4. So we call it a VPN subnet, for example, and then update the route table as usual. So for this, maybe a VPN route table, where as usual, you have the default route being the local VPN traffic, and then you want to point the destination. And point it to the virtual private gateway. So what it means is that your implicit router now knows that if, let's say, we want to send packets onwards to the your on-prem network address, if it falls within this range, the implicit router will direct the packet to the virtual private gateway, and the virtual private gateway already knows that this is the reachable address here. It will send it across to the VPN into the on-prem corporate network. And then the reply traffic, you have to configure the routing accordingly on-prem so that the reply for destination IP addresses that fall within the VPC address range is sent onwards to the site-to-site VPN connection to go back to your VPC. Now, one of the features here is that you can associate this route table directly to this virtual private gateway device or service, so that this last entry here, you don't have to propagate it. You don't have to hard code it. It can be propagated automatically from your virtual private gateway. So whatever reachable address here is automatically propagated into your route table for your convenience. If you can support dynamic routing, we would like to recommend that you do that. Dynamic routing is enabled by this industry protocol called Border Gateway Protocol. This is what enables the direct this dynamic routing. Under dynamic routing, you don't have to manually input or configure the destination IP addresses, because both these devices will mutually advertise their reachable routes to one another, right, through using the BGP protocol. So that's more convenient, that's more flexible, so that if there's any changes in the routes, the BGP protocol will be used to advertise and update routes. So instead of doing things manually, if you can have dynamic routing, that will be the best. Once the VPN, site-to-site VPN is established, you can send traffic, and the maximum bandwidth there is 1.25 gigs per second. However, please realize that your traffic is traveling over the internet, the public internet. And obviously there's security, because it is an encrypted pipe, so that even though it's the public internet is encrypted, And that's why your VGW and the customer gateway here needs to do all those handshaking to verify identity, etc., to exchange encryption keys so that the encrypted VPN pipe can be established. But nonetheless, it's still over the public internet, and the maximum bandwidth is 1.25 gigs per second. Now, what if you want a higher bandwidth? Or what if you want dedicated bandwidth? You don't want your traffic to go over the public internet. You want a more dedicated connection between your on-prem and your VPC. Then this is the job for Direct Connect. Direct Connect allows us to up here, establish a dedicated link, and it kind of works by having this facility called the DX location. DX location stands for Direct Connect location. Up here, the label here. A DX location is a data center. For most part, for most cases, this DX location is a data center facility that is owned and managed by a Direct Connect partner. So it's not AWS who owns these data center facilities, but AWS partner, a DX Direct Connect partner. And in this facility, basically, AWS will have its own. AWS will have its physical routers here. And what you can do as a customer is to bring your own routers here, or if the partner offers you, you can make use of their router. And so basically you have in this DX location, customer router. And then you have also the AWS router here. So basically what happens then is that you establish a last mile connection, dark fiber, between your on-prem customer gateway to your router, customer router on the DX location. So if you do not have this dark fiber, then you have to work with your service provider to pull this last mile dark fiber, optic fiber connection from the DX location that is nearest to your data center to your data center location to establish this. And then in the DX location, basically, they will have this cross cable connect to connect one of your ports to the AWS router ports through a cross connect cable, basically linking them together. And then from the AWS router, it goes through private AWS network and connects up to your virtual private gateway. So in other words, this is dedicated. It doesn't go over to the public internet. It's a direct, dedicated physical connection between your on-prem corporate network and the VPC. And based on this common physical connection, you can create virtual networks, virtual slices of the bandwidth. This direct connect bandwidth can be 1 gig, 10 gigs, and 100 gigs. So if you have high bandwidth requirements, you can choose it accordingly. And from this, let's say 10 gig physical connection, direct connect connection, you can make slices of that bandwidth, the form of a VLAN, basically, virtual slices of the bandwidth, so that you can have these multiple VLANs on that same physical connection, because from this direct connect, you may be connecting to maybe multiple VPCs, right? So you give them each slice, a VLAN, a type of slice of the bandwidth to connect up to your VPCs on AWS Cloud, for example, right? So this is a nutshell, another option for you to connect up your networks. And this is still, although dedicated and high performing, it is still a single point of failure, as you can notice, because if let's say the router, any of the routers go down or the whole facility goes down, you have lost your direct connection. So for critical workloads, if you need to have resiliency in your connection, then you might want to invest in a second direct connect line using a separate DX location, provider, so that you avoid site failure and device failure, for example. A less costly approach will be to have the primary link as the direct connect and have the failover as the site-to-site VPN. That will be less costly. But if you want to do that, then a few things. One is that make sure that your side of the connection, they always favor the direct connect as the link to choose. AWS side of the cloud, they will always prefer direct connect connections to send traffic. You do the same so that direct connect becomes the primary link and will only use the site-to-site VPN as a standby failover. The other thing to take note of is that the maximum bandwidth of this site-to-site is 1.25 gigs. If you have a direct connect of 10 gigs and suddenly, because of failover, you fail over to only 1.25, then you have to see whether that's feasible for you or not. But nonetheless, is an option as well. All right, so that is basically an overview of the connectivity and in terms of your hybrid cloud architectures, a site-to-site VPN and a direct connect. The other type of connections that we might have for this particular VPC is VPC to VPC connection, right? So this VPC is obviously isolated by default. And what you could have is, let's say this is another VPC. And what you can have is, let's say this is another VPC here. And you can establish a peering relationship between these two VPCs, right? You don't have to have any gateways. It's a logical construct. And you can have this VPC to VPC peering relationship between this VPC and the other VPC here, this VPC here. And this peering relationship can be between VPCs within the same region or cross region as well. So this VPC could be in Singapore, this could be in Jakarta, or this could be in London, and you can have this cross-region VPC peering relationship as well, so that your workloads can communicate with one another. So this is another option that we're going to see. Okay. Now, so far so good. But the key reason why we need to work with all this external connectivity is that by nature, your VPC is isolated, right? So that's why we have to, as solution architect, we have to determine what kind of, external connectivity do we want, and then we go and design and enable that connectivity accordingly. The other consideration is when you have applications running on your EC2 and they need to connect up to services like S3, your DynamoDB table, etc., how do they actually connect to it? Well, but if we just take, let's say, an S3 bucket. S3 bucket is outside your VPC, and there's no direct link. There's no default direct link between your VPC and the S3 bucket. And so if you have an application running in your EC2 in the public subnet, then the API call to access the bucket goes out through the internet gateway to the bucket, and the bucket back through the internet gateway to your application. If your application is running on EC2 in the private subnet, then you have to set up your NAT gateway and the internet gateway so that the API call will go out through the NAT internet gateway to the S3 bucket and then back again, right? So it's a bit of a roundabout way of accessing your S3 bucket resources. And it also applies to, let me just get rid of this. It also applies to external, public AWS services like CloudWatch. We have learned about this before, and Systems Manager, let's just say. So all of these are public APIs that you access the service to. So if you have, let's say, a agent software or client custom software that is, let's say, on this EC2, is running on this EC2. So we have to ask ourselves again, how are they going to connect up to this external service? So if, let's say, I have an agent software running and I need to communicate with the AWS Systems Manager, then again, my API calls need to go out to the NAT gateway, Internet gateway, and then the service systems manager, for example, and then back again, right? Non-ideal, not so ideal. So to help us overcome these challenges, we have this service called VPC Endpoint. VPC Endpoint helps connect my VPC to AWS services, basically. And there are two types of VPC endpoints. You have the gateway endpoint and the interface endpoint. The gateway endpoint is for, let me just, so I can cancel off this mix. The gateway endpoint is for only two services, S3 and DynamoDB table. Right? These are the only two services that uses a gateway endpoint. And a gateway endpoint is basically can become a target in your route table. And a gateway endpoint resides on your VPC. And let's call it the S3 gateway endpoint here so that we know it's for S3. So we deploy this S3 gateway endpoint to your VPC. And then as we are deploying this, they will ask us which route table do you want to connect this endpoint to? Because we need to create a route entry to point your traffic to the public endpoints of this S3 bucket. So let's just say we want to enable this, let's say, software to connect up to this S3 bucket. So when we're creating an endpoint, you say, okay, I want to update my private route table with this entry for this S3 gateway endpoint. So what we'll do is we'll have a S3 prefix. A prefix is a logical container of the public IP address of your S3 service, right? It's kind of captured into a prefix. Now, what it means is that S3, when we call S3, the API S3, it will eventually resolve to a public IP address for the S3 service. And so this public IP address is captured by this prefix. And now we point, usually for public IP address, we know that we need to point to the NAT gateway and then out into the internet gateway. But this time we want to point them specifically to the VPC endpoint. VPC endpoint, something like that. Basically this one, it comes with its own unique identifier. So that now this client software or agent software, let's say wants to connect to the S3 bucket, the API calls now will be resolved to the public IPs of the S3 service, which now is captured in this route table entry. And instead of going out through the NAT gateway now, we're going to direct this API call to this VPC endpoint here. Sorry. It's going to be, the API calls here will be directed to this one, to the gateway endpoint here. And from the gateway endpoint, it goes out to the S3 bucket, right? And from here, the endpoint to the S3 bucket is private AWS network. It doesn't go out into the public internet. So in other words, when you use a VPC endpoint, you don't have to set up your NAT gateway and internet gateway for this type of access to AWS resources. The other type of endpoint is called an interface endpoint. And most of the other AWS services support this interface endpoint. In fact, S3 also recently announced support for interface endpoint. And in the interface endpoint, basically, you're going to choose subnets, and it's going to deploy this interface endpoint. It's a special virtual NIC card, basically. So let me just put them together so that, so that you know that it's an endpoint. So this is your interface endpoint. So you choose a particular subnet. And when they deploy this NIC card into it, it will be assigned an IP address of the subnet of your choice. In this case, it's private subnet 2, and it will also have its its own domain endpoint as well. And so the whole idea here is that the API calls, instead of being directed outwards to the public APIs of the systems manager, now they are redirected directly to this interface endpoint. And from this interface endpoint, it goes through AWS private network to access your AWS systems manager. And same thing for CloudWatch, API gateway, Kinesis, things like that as well. In this case, there is no updates to the route table required because of this special NIC card. Is going to take a subnet IP address. And we know that internal VPC address is all locally routed automatically. So for interface VPC interface endpoints, there's no need to update route tables. Your API calls can be directed to this endpoint specifically, right? So all you need to do if you're running a custom application is to repoint the API endpoint to this domain endpoint of this interface endpoint, right? So that the API calls will go out. If you're using, for example, SSM agent is a systems manager agent that runs in the EC2. There's a additional feature that you can enable when you deploy your interface endpoint. It's called private DNS. With the private DNS option selected, what it is when your agent software calls the default regional domain endpoint for your systems manager service by default, that is automatically routed or redirected to the interface endpoint. In normal situations, when your SSM agent tries to connect with your systems manager, they will use this regional domain endpoint of your systems manager service. That endpoint, that API call again has to be routed out into the internet. But this time, when you're deploying the interface endpoint, when you check the private DNS checkmark, it means that we will automatically redirect the API calls to this interface endpoint. And then from this interface endpoint goes through private network to your systems manager. So the whole idea here is we want to keep our API calls and traffic within the AWS private network and not let it go out into the public internet. Okay. Let me just show you a quick demo on this just to have a bit of feel on how it actually looks like. Just switch over to the Ohio region. Where I have this demo VPC here, and in the demo VPC, I have these two subnets, public subnet demo and private subnet demo. Okay, so I'll make use of this. So basically, to deploy the endpoints, first let's try to deploy a S3 gateway endpoint. Create an endpoint, my S3 gateway endpoint. And basically select AWS services here. Look for the service S3. You notice that S3 now accepts, you can deploy it as a VPC interface endpoint, but just to show you how the gateway endpoints look like, I'm going to select the gateway option. I select the VPC, my demo VPC, and then I choose the route tables to update. So in this case, I want the subnets that are supported by both the public route table and the private route table to be able to direct traffic to this S3 gateway endpoint. So let's select those two options. And then there is this resource-based policy that protects the access to the endpoint. So we talked about resource-based policies in the first day. Well, this is the one. You can actually, determine who, which roles, for example, can access this particular endpoint, right? But for convenience, I'm just going to allow full access, right, to this particular S3 endpoint. And basically, we create the endpoint. And it's going to basically update these route tables. Let's take a look at one of them. Now, so the routes is ready. So this is the S3 prefix that I was talking to you about. And this is the target, is the VPC endpoint. This is the gateway endpoint that we just created. Right? If you take a look at this S3 prefix, it contains all the public IP address of your S3 service, right, of the particular region. Right? So these are all public IP address. So as I said, when you call the S3 API, the public API, it will be resolved to the public IPs. So all the possible public IPs is captured in this entry. So what it means then is, back. Whenever any application on your EC2 is trying to call the S3, this route table entry will ensure that is directed to the S3 gateway endpoint. Okay. Let's try for interface endpoint. And the SSM is short for Systems Manager. So this is the one that I want to deploy. Let me choose my demo VPC again, and this time I'm gonna choose the private subnet to deploy this. And because it's a NIC card, it's a virtual NIC card, I can choose a security group firewall protection for this entry point. Again, I can choose a policy, provide a protection policy to protect who can access this interface endpoint. But for now, I'm just going to leave it to full access and create that endpoint. This time, there's no updates to any route table that's necessary, because if I deploy this NIC card into the private subnet, it's going to take one of the IP address of the subnet assigned to it. So as you know, the default local route will already cover it. So no further updates on the route table is necessary. Okay, so maybe it's taking a few minutes to kind of be ready. But if you go to just go to the EC2 and take a look at the interface, network interface. All right, so I select this network interface, and as you can see, the description is this is the endpoint. So this is the new NIC card that has been deployed, and is an interface endpoint for that SSM, the Systems Manager, interface endpoint for that. Right. So basically, it will come with its own private IP address that is taken from the subnet, as I was saying, and basically you can if it is a custom software, as I said, you can redirect your API calls to this particular NIC card. Back to the VPC should be ready. All right, so this is the interface endpoint that we have deployed. Okay, so that's a quick example of how you do it. And because I enabled the private DNS name, basically what will happen then is that when my SSM agent is trying to call this regional endpoint of a SSM service, it is rerouted to point to the interface endpoint domain endpoint so that I don't have to change anything. The APIs automatically get redirected to the interface endpoint, right? So just a little bit on the endpoints here. All right, that's the extent that we have some more details in the slide, which I'll quickly go through now in terms of this networking topic. All right, just a quick poll. How many VPCs does your organization use? Right, okay, so yeah, less than 20 to 20 to 100, okay? Okay, that's quite sizable as well. Those of you who are between 20 to 100, usually as a start, we usually have maybe 5 to 8 or something, but above 20 to about 100 is quite sizable. Nichachun, it looks like you have quite a matured rollout already. You have more than 100 VPC, so you have very substantial workloads already on AWS. All right, thank you for that. Okay, so the network engineering team is saying our security policy states that each application must have its own isolated infrastructure. So you need this type of logical network isolation, and the VPC is the correct answer for this. We will start out with a smaller number of networks, but this number will grow significantly over the next year. Many of these independent networks will need to communicate with one another. Although we want to keep them isolated, there may be a need to share certain services, share certain databases or directory services or security scanning services. So we kind of maybe consolidate the shared services into a shared services VPC, and then have these other VPCs, workload VPCs, where appropriate, you kind of want to connect them to one another. Okay. What are our options for connecting two networks together? So we'll probably look at VPC to VPC peering, right? So from one workload VPC to connect to the shared services VPC, but we are also asking, what if we need to connect hundreds of these networks? In addition, it is critical we understand our options for integrating our data center with AWS. So you want to have this hybrid network connection between on-prem and VPC on cloud. So what are these options? And how can we access services like S3 from inside a VPC or from on-premise? So this is going to involve the endpoints. Again, we have this end user perspective that we'll take it one at a time. But basically, we have seen quite a fair bit on the VPC. Now we want to look at external connectivity options like Direct Connect and Virtual Private Gateway to connect to your on-prem corporate network, and use the VPC endpoints to connect up to AWS services. In terms of connecting back to your on-prem corporate network, two main options here: site-to-site VPN and Direct Connect. Right? We'll also kind of cover this. Also, just a note that although we're not going to cover, but AWS will support client VPNs as well. So the site-to-site is connecting two networks. But what if you have your developers and remote AWS administrators or cloud administrators that are working from home? While they then will have to, somehow VPN back to their corporate network, and then from the corporate network site-to-site back to VPC. So it's a roundabout way. If you want a more direct way, we can implement AWS client VPN so that our remote administrators, developers, etc., who need to work from home, well, they can connect directly through this client VPN directly to resources in the VPC through this client VPN. But just to mention that so that you know it's there, but we're not going to cover it. All right, let's look at these sections that will help meet the requirements of this module. We start with VPC endpoint, and the network engineer is asking, how can my services talk to each other without routing through the public internet? So without a VPC endpoint, if you need to connect from, let's say, an application to DynamoDB, and the EC2 application is running in a private subnet, Then we have to set up the NAT gateway and internet gateway for the API calls to go out, right? So the API to return. So this is possible, but perhaps not so ideal. What we want to have is to deploy a VPC endpoint so that the API calls can go directly to the endpoint and then to DynamoDB through private AWS network without going through the public internet. The endpoint service itself is serverless and horizontally scaled. So this is not a single point of failure and it will not be a performance bottleneck. That's basically what it is. There are two types of endpoints that I went through: gateway endpoint, interface endpoint. Gateway endpoints is only for two services, S3 and DynamoDB, where the route tables will be updated to point, for example, here to point to the S3 prefix that directs it to the S3 gateway. And if you have a DynamoDB table as well, the endpoint, it will also have its own prefix that points to the public APIs or public IPs of the DynamoDB service, and is directed, those API calls now directed to the DynamoDB gateway endpoint. So the thing that you want to recall from the gateway endpoint is that they're deployed at the VPC level, and you choose the route tables that you want to update. They will update for you automatically. And so subnets that are associated with this route table now have a route entry that points to the gateway endpoint. The other one that we saw was the VPC endpoints. So this is a virtual NIC card of the VPC endpoint that is deployed in a subnet of your choice. In this case, we take the private subnet, and it will take a private IP from the subnet IP address range. You might want to enable the private DNS option so that your SSM agent software that is running, it will point automatically when you try to access the regional endpoint of SSM or Systems Manager, it will automatically be redirected to this interface endpoint. In this case, you might want to notice that we don't have to update the route table because the interface endpoint already, because it takes from the subnet, it already is contained within this default local route. Most of your other, there's a growing list of services that are supported by this type of interface VPCs, things like Kinesis, CloudWatch, API Gateway, etc. Right? So in most cases, it will be an interface endpoint. And you can actually use this type of facility for your own internal or external applications itself. Think of yourself as a service provider, and if you're providing some internal apps, you can also allow your internal apps from various VPCs to connect to your application through this interface endpoint concept. So this could be an external service provider, Trend Micro, for example, for security scanning, or your internal app that you deploy as an endpoint, right? So basically how it works is that you need to deploy a network load balancer that will sit in front of your application, either the internal application or your external Trend Micro security scanning, for example, right? So you have to deploy this network load balancer, and then you register your endpoint service by defining which is your network load balancer, right? So you say, okay, for my service, here is my network load balancer ID or endpoint. And so once you register that service, then your consumers, your internal customers or external customers, they will go to the endpoint service that I showed you earlier, and they will search for your service. Either they search for your service, or when you create your endpoint service, they'll give you a unique service ID you can pass along to your internal customers. For example, if they can search for your service using your service ID, once they locate your service, they go ahead to deploy that interface endpoint into a subnet of their choice. And once that is done, then they can connect to your service. And basically, it's a one-way access only, in a sense that the API calls or the connections must be initiated by the customer side. It will not allow the service provider type of applications to try to initiate the communication. No, it's only from one way to initiate, and then the reply comes back. Now, the other thing that we want to note from here that is that this is not like a peering relationship that we're trying to join networks. This is exposing an API of a service through this interface endpoint. So we're not interested in connecting the consumer network and the service provider network through a peering relationship. We just want to have a way to expose the APIs of the application so that through this network, through this interface endpoint, we can use them to direct our API calls to. All right, so this is in a nutshell how it works. And because we're not joining networks, we can have overlapping addresses, right? So the IP address or CIDR range address can overlap with the the service provider VPC or address. It doesn't matter, right? We are not joining the networks. We're just exposing the API. In fact, the instance here, as I said, the APIs are actually directed to the interface endpoint, not directly to the servers of the service provider. Now let's look at this example. You want to access S3 from on-prem, all right? So you either have a site-to-site VPN or direct connect, and when you deploy an interface endpoint, they are accessible from on-prem as well. Not the gateway endpoint, but the interface endpoint, the NIC card version. If you deploy an interface endpoint, S3 is one example, but it could be other services as well. Your applications running endpoint, they can actually access and call, or direct the APIs to this interface endpoint through Direct Connect and VPN. Okay, so it's again a little bit more secure because you're not directing the API calls through the public network. All right. Okay, I'm going to give us a 15-minute afternoon break right now at this point. I'll give you a countdown timer as usual. When we come back, we'll continue our coverage on the networking topics. All right, have a nice break, and I'll see you in 15 minutes. Thank you. All right, welcome back to the session. Just ask for your kind help. If you can go back to the class link, I just ask for your kind help to fill up the class evaluation for us, if you don't mind. Let me just get that up again. If you go back to the class link that you did to register for the class, I've put up the URL on screen here, as well as the in the chat box, I put out the URL there as well. And so if you can access this site again, and if you scroll down to number 4, course evaluation, to view the transcript, and then you have a option there to give us the classroom evaluation or course evaluation. I'll be most grateful. It's mandatory for me to request one from you. So I ask for your kind help and consideration to please take a few minutes now to do the course evaluation for us. So please do, if you can, browse through that URL. And then point number 4, item number 4, course evaluation, to view the transcript there, and you should see the evaluation link once you click on that. And will be most grateful if you can kindly complete the course evaluation. Right? Thank you. Many thanks in advance for your kind consideration and support in the evaluation. And do let me know once you are done with the evaluation. All right. Thank you so much. All right. For those of you who have finished the course evaluation, I'd like to also ask if you could try to create or sign in to the AWS Skill Builder. I put the URL links on the chat as well to access your Architecting on AWS online course supplement, or scan on the QR code you see on screen there. But avoid signing in as a AWS partner. Create a Amazon.com account to sign into this skill builder. This is where you will get all your self-paced digital e-learning modules. So there are a number of modules there that are very helpful and useful. But I'll draw your attention to the Architecting on AWS online course supplement, or OCS, because it does give you all the online links, collation of articles, videos, white papers, etc. And also, in case I don't want to do it in a rush at the end of the class later, but this is where you will find the capstone lab instructions, right? So please be mindful of that. So please do ensure that you can access that as well. Just to show you what the what it looks like. So all that we went through in this course, each of the subject, you can find it here. And as I said, it's a very nice collection of videos and also articles, blog articles, PDFs, technical white papers, etc. Right. So this is apart from your ebooks, this will be a fantastic resource to use for your revision and your reference, especially if you're preparing for your exams. This will be a nice collection of topics to kind of revise on and get further details. But I also want to draw your attention to the capstone project. And over on the left navigational plane here, you will find that one of the last sections is your capstone project. The capstone project is designed to be quite a long one. They give you general outline course scenarios, and by default, they don't give you a lot of instructions to kind of challenge you to kind of figure it out for yourself. However, if you want the full instructions, you can browse right up to the end using the left navigational plane, right up to the end. The last item on the left here, this is where these are the detailed lab instructions. All right. So if you want just to go through straight away to the detailed lab instructions, you can certainly go to the left navigation plane and get the detailed instructions over on the left here for your capstone project, right? So this is your take-home project, and I do encourage you to try to complete the capstone as well as your remaining labs. As I said, you have until Monday, March 28th, access to the labs. Chee Kong, the online supplement is yours, right? It's part of the e-learning collection. So it's yours as long as you have this skill builder account, right? So fantastic resource for your reference and your revision, okay? All right, so this is as much as the logistics I needed to cover with you. And I trust that you have been able to complete the course evaluation as well. So if you're done with the course evaluation and with quite happy with the skill builder as well, can you just give me a quick indication so that I can resume the class? Thanks so much. All right, just to check again, are you done with the course evaluation? All right, thanks so much, Jet Sada. Appreciate that update. All right, thank you, Tara and Kesham. Thanks for that. Thank you, Papai. Thank you. All right, Vivaldi, thank you very much for that update. All right, Jikong and Kolun, thanks so much for that. All right, let's thanks everyone. Really appreciate your kind help and support there. And we're going to move on to the next section now. We're going to talk about VPC peering. This is about connecting up to VPCs together. All right, Eric, thanks so much. The development manager is asking us, how can VPCs talk to each other even if they belong to different AWS accounts? So this is our scenario here. We'll have three VPCs, A, B, and C. Okay, and through VPC peering is a one-to-one peer. So A and B, they are paired together. B and C, they are paired together. So between A and B, they can send traffic. That means one EC2 can send traffic to another one and with a reply, and B and C can do that as well. These VPCs can be from within the same region, so same region peering, or cross-regional peering. Let's say B and C could be different regions, cross-regional peering. For intra region, same region peering, the traffic, I mean, this is all dedicated private connection and the traffic is not encrypted. But for cross-regional peering connection, the traffic is encrypted by default. Also, one thing to bear in mind, few other things to bear in mind, the address space, if you peer two VPCs together, the address space must not overlap, right? You're not allowed to overlap the IP address range. Okay, so they must be distinct. Also, transitive peering is not allowed, or transiting routing is not allowed. So, for example, A is connected to B, B is to C, but that doesn't mean that A is now connected to C. That means A cannot send a packet directly to C through B. That is called transitive routing. That's not allowed. That's not supported, basically. Okay, and also it applies to transitive edge routing as well. If B has a site-to-site VPN back to on-prem corporate network here, then A cannot send packets directly to the site-to-site VPN, to the virtual private gateway here directly, and access the site-to-site VPN back to on-prem corporate network. That's transitive edge routing. That's also not supported, right? If A needs to communicate with the VPN, then it needs to be proxied by a EC2 here of a sort. Similarly, if you want A to connect to B, you don't want to establish a direct peer-to-peer. If we want to go through B, then you have to proxy it through a NIC card or a EC2 or security device here, and then it goes off to B. It goes off to C, right? This is especially so if you have overlapping IP address, you can't directly connect. Then maybe you just come up B here as a proxy for that connection to happen. If not, if you want A and C to be connected, then they have to establish their own site-to-site peering relationship. Also, another note that cross-account support is enabled. So, like say B and C, they are from different AWS accounts is supported, right? That is also supported. All right, thank you, Malikus. Thanks so much for that kind update. So here's the key value proposition. In the past, without peering, if A needed to communicate with B, we needed to set up the internet gateway, net gateway, and all that thing, right? And goes over the public internet. Obviously, not that ideal. Right now, with the a peering relationship. We don't need to set up these gateways. They can have that one-to-one relationship. And the peering connection itself is highly available, redundant, and scalable. So it is not a performance bottleneck. You don't have to worry that that you need failover or it's a performance bottleneck. It is not a performance bottleneck. It will support to the level of the networking bandwidth that your EC2 can support. If your EC2 can go up to 10 gig, then it's quite happy to support that as well through this peering relationship. Also, once you set up this peering relationship, you have to also remember to update the route tables accordingly. First of all, obviously, let's say A wants to peer with B. A will put in a request for peering. The owner of VPCB must approve that peering request, and then the peering connection will be established. Also, the route tables on either side of that connection needs to be updated. So, for example, the route table in VPC A here, it needs to point to the CIDR IP address range as a destination range of B, and as the target, use the peering connection ID. And similarly, the route tables in B need to point back to the CIDR range of A and use the peering connection as the target. All right, Gato, thanks for that update as well. Thank you for your evaluation. And Tara has a question. What's the difference between VCP peering and transit gateway? Okay, yeah, we will deal with that. I'll come to that later. But a quick answer is that transit gateway is for connecting a lot of VPCs, up to thousands of VPCs together in a central hub and spoke model, whereas VPC peering here is a one-to-one peering relationship. Right? I'll talk about some considerations later. So one example of how we might want to use this is you have a shared services VPC. Maybe you have a database here. Maybe you have some security scanning services here or directory services here that are shared among all your workloads. So what we can do is to peer them together, one-to-one peer, app 1 VPC, app 2 VPC. Each one have a one-to-one with the shared services in the same region. And from a different region, region B, we can have that cross-regional peering as well. And then from the shared services VPC, you have the virtual private gateway, and it goes through a site-to-site back to your on-prem corporate network. And if these are security appliances, they can proxy the connection so that the connectivity from app, let's say EC2 in app 1 VPC here, can be proxied by this security appliance, and then it goes through the site-to-site back into your on-prem where needed. And other like directory services or security services or databases, they can actually be on the VPC and the workloads can connect to it. Also, if you're trying to connect to a database here, one of the things, instead of having the network connectivity travel a bit long over the site to site, you could perhaps have some form of a replication to replicate or clone the database to have another database here in a shared services VPC, have some form of synchronization, and have the workloads connect to this cloned database on the shared services VPC so that the turnaround will be faster. Okay. Now, if let's say your VPCs, let's say 5 of them here you see on screen, needs to have each of them have a one-to-one with one another. This is called a mesh type of connectivity. And if it's just 5, 6, 7, 8, still quite manageable. But if it goes beyond 10, it gets a bit complicated. The complexity of your network connection starts to exponentially grow, right? So if some of you have more than 20 VPCs, some maybe 50 and above, and if you try to just use peering and you have a lot of extensive connectivity requirements that you need to implement between these VPCs, it can get very complicated, right? And that is where we come to Transit Gateway. And the network manager is asking, how do we manage traffic flow and security across hundreds of VPC? Well, let's take a look at the connectivity challenge without a transit gateway. You have connectivity back to your on-prem through a site-to-site VPN and your direct connect. So each of these VPN, site-to-site VPN, one per logical connection, you have actually 2 physical tunnels. And then the direct connect is a one-to-one, but for redundancy, you might want to double that as well. Then you have on cloud 6 VPCs here. If they need to kind of communicate with one another, well, then you have 15 VPC peering connection. So quite a lot of connectivity to manage, to configure, to manage, and to monitor. With a transit gateway, you consolidate all your connectivity to a central hub, which is your transit gateway. And so each of the VPCs that you see establishes its connection is the spoke. So it connects up to this central hub of the transit gateway. From the transit gateway, you are able to create a VPN connection back to your corporate network, as well as a direct connect, right? If you want to use a direct connect, there's an additional service that you need to configure called the direct connect gateway. Okay, so, but it is possible for the transit gateway to also go through direct connect back to your on-prem corporate network. So the connectivity now is greatly simplified through this central hub and spoke. And you could have routing rules, we call it routing domains here, that can control whether each of the VPCs can communicate with one another or not. There are various real routing configurations that you can implement. You can have full connectivity. That means all of them can connect to one another. That's one particular option. Or you can differentiate between prod and dev environment. So the prods production VPCs can communicate with one another, but they are isolated from the dev environment. The dev VPCs can communicate with one another, but not to the prod VPC. So you could actually do it that way, or you could say, okay, I do it by application stack. For each application, I have a prod and dev. I pair them together, for example, if you want to. And so it will be kind of a connectivity by application stack if you want. So it's very versatile, and the transit gateway here is a virtual, massively scaled virtual routing and forwarding type of service. Virtual routing means that, because of this ability to implement multiple routing rules or routing domains, it is as though you have multiple routers there, right? But it's just one logical service. Let's look at some of the key features of this transit gateway. It can connect up to 5,000 VPC connections, including VPN connectivity back to your on-prem corporate network. Right? So it is a central hub configuration, and you could have basically multicasting. Multicasting is the feature that allows you to do broadcasting. You can create a broadcast domain and have a EC2 broadcast messages to other EC2s within the same broadcasting domain. So that's called multicasting, and that kind of behavior is supported on your transit gateway. And you can peer one transit gateway to another transit gateway as well. It used to be that we can only peer inter-regional peering. That means one transit gateway peer with another transit gateway from a different region. But today, they also support same region peering. That means per region here, let's say Singapore region, you could have 2 transit gateways because you have extremely large networks. So you need 2 transit gateway, and they can be peered together as well. Or it could be you have a transit gateway here in, let's say, the Jakarta region, and then another in the Sydney region, another transit gateway in the Sydney region, and you have this inter-region peering between the 2 gateways. That would be possible as well. So the key takeaway here is that with transit gateways in the picture, you can manage massive scale of these VPCs or these virtual networking requirements for your AWS environment. Some of the more detailed features of your transit gateway is, first of all, think of attachment. Attachment is a network connection between a VPC and the transit gateway. We call it an attachment. You attach the VPC to the transit gateway. That means you establish the network connectivity between the VPC and transit gateway. This also applies for VPN connections. You can create a VPN connection or attachment to connect up, this VPN connection to the transit gateway. You can have direct gateway attachment. Direct connect gateway links the transit gateway and your direct connect. And then you have this type of transit gateway peering between transit gateway, two transit gateways. You have this transit gateway connect. This is to connect a transit gateway to your own SD-WAN solution, right? This SD-WAN, some of your organizations have SD-WAN solution to connect up to the networks there, so you can connect it to your transit gateway as well. So in setting up the transit gateway, basically what you need to do then is to decide what networks you want to connect to the transit gateway in terms of VPC, VPN, direct connect gateway and peering relationships. And then you create attachments for those networks that you want to connect up to the transit gateway. Now, a note here that transit gateway is a regional service. So these VPCs must be from the same region. If this transit gateway is in the Singapore region, then these VPCs must be from the Singapore region as well, right? That generally applies to all your network attachments as well. This is a region scope service. And basically the only exception here is that the direct connect gateway is a global service, so it spans across all regions. And your transit gateway peering can be from a different region as well. Okay. Now, once you connect up, maybe I didn't cover this as well. I forgot to mention, on the transit gateway itself, you can have more than one route tables. Each route table controls a routing domain. So if you have multiple routing rules that you want to implement, each of your routing requirements can be represented or implemented through these transit gateway route tables, right? So it's like, as I said, having multiple virtual routers on your transit gateway through the use of these virtual routers, or these transit gateway route tables. So in this example, you have 4 VPCs, and each of them have the attachment to this transit gateway. Transit gateway also have a VPN connection back to the on-prem corporate network, including also another direct connect to the corporate network. Now, full connectivity means that each one of these attachments can communicate with one another freely. So it's a full mesh, but it's not a mesh now because your transit gateway acts as a hub. And basically, all of them are connected to one another. A, B, C, D, they can all freely send traffic to one another and also send traffic to the VPN connection. For full connectivity setup like that, you only have a single transit gateway route table. Everyone refers to it. Everyone, is associated with this common transit gateway route table. And each of these destinations, these routes, reachable routes, are also propagated to the same table. So I send packet to the same table can route it to any of these destinations. So we call it full connectivity. Partial connectivity can be if you want 2 separate domains, 2 separate routing domains, such that A and C are connected together in a red domain, B and D to the green domain. Now, to implement this, we can do it by 2 transit route tables, 2 different route tables on your transit gateway, one for red and one for green. So basically, A and C, they are associated with the red route table, let's just say, and they also propagate their routes, their reachable destinations to the red route table. So what it means is then A can send packets to the transit gateway, and the next hop is determined by the route table, and the next hop is the IP address of C, so the packets can be routed back to C. So A and C fully connected. For the green one, B and D, they attach themselves or associate themselves to this green route table. And at the same time, they also propagate their own routes to the green route table. So that now when B sends the packet to the green route table, you can see the next hop destination as the IP address of D. So you can go back and then you can go forth from B to D and then D back to B, right? So basically that's the basic concept. You have transit gateway route tables, and let's just take for simplicity the VPC perspective. The VPC perspective is I can associate this VPC attachment to a route table. When I do an association between the VPC and the rate route table, it means that VPC-A can send packets to the transit gateway, and the next hop is determined by the rate route table. Okay. When VPC-A propagates its route to the rate route table, it means that it can receive traffic from the transit gateway that is determined or controlled by the rate route table, right? So you associate with the route table that you want to send packets to, and you propagate your routes to a route table from which you want to receive packets from the transit gateway, right? That's in a nutshell. And then you want to have isolation, this third scenario, where they must not talk to one another. So A, B, C, D, they cannot talk to one another, but they can each talk to the VPN, and the VPN can send a reply message back to them. So in this case, there are also two route tables that are configured differently. There's one, I call it the VPC route table on your transit gateway, and another one VPN route table on the transit gateway. In this particular scenario, A, B, C, and D, they will associate themselves with the VPC route table. The VPN connection will, that is the reachable destinations here, basically will propagate its route to the VPC route table. In other words, the VPC route table has only one hop destination, which points to the VPN connection. In other words, the VPCs, when they send their packets to the transit gateway, there's only one hop available, which is the VPN. So there's no other path or hop to the other VPCs. So we achieve isolation. On the other hand, there is this second route table on your transit gateway, the VPN route table. Here, the A, B, C, and D, they propagate their routes to this second route table. And the VPN connection, they associate themselves to, associate itself to this VPN route table. That means when the return packet comes to the transit gateway and it hits this VPN route table, the next hop available is any of the VPC destinations. So in other words, traffic can go to the VPN and it can go back to the VPCs that initiated that connection request. So you can again use the transit gateway route table for this type of connectivity. Okay. So that's the transit gateway, and if you are working directly with networks and you want to a little bit more details on how this routing works, please do indicate to me. I can spend some time with you after the class. I'll give you a little bit more details, but I just want to keep it high level for now, unless you have you're working directly with this networking. If not, then just do a high level understanding of how the transit gateway works. Next, we move on to hybrid networking, and this will allow us to establish site-to-site VPN between our corporate data center and the VPC. And the first one is a site-to-site that I kind of mentioned in the whiteboard. And so we deploy a virtual private gateway, and you have your customer device on your own network here. And you establish this site-to-site, and there will be two physical tunnels, two endpoints. And it could be a static routing and dynamic routing. Dynamic routing is implemented or supported by your border gateway protocol. in terms of the site-to-site VPN connection options, one option is to, which we have been talking about, is to connect through the virtual private gateway. Okay, from your on-prem to the virtual private gateway. This is a managed option because AWS will manage this virtual private gateway and the site-to-site VPN connection. Or if you have your own VPN appliance that you want, solution appliance that you want to install on an EC2, that's another option. Maybe you have a VPN solution from Cisco, right? Like the Cisco Cloud Service Router, CSR. These solution appliance can be deployed on the EC2 so that you can get that customized VPN solution. Benefit here is that there may be advanced features from Cisco that you enjoy and that you want to use. So if that's the case, then you can have that third-party VPN appliance solution installed on the EC2. The only thing that you want to take care of is failover, right? Make sure that you have some high availability in 2 different availability zones and there's failover, etc. Here is not a problem because here is highly available and redundant by nature, by default. You don't have to do additional configuration. Third option is to use the transit gateway that we talked about. So with the transit gateway, all you need to do is to have the attachment from the VPC to the transit gateway. Transit gateway itself basically can establish the VPN back to your on-prem corporate network as well. Okay. Next, we have Direct Connect. Direct Connect is a dedicated bandwidth between your VPC and your on-prem, right? So it is going through a DX location, which is supported by a DX partner. Maybe I'll just show you AWS Direct Connect partners. So you can read some details here, but basically you find the location nearest to you and it's tied to a particular region. So let's look at Asia. So Singapore region, for example, supports the Singapore region, supports these DX locations. The Equinix and SG2 in Singapore, GPX Mumbai, India, Global Switch also in Singapore, another one here, iAdvantage in Hong Kong, and Menara Ames in Kuala Lumpur, Malaysia. So these are the direct connect locations. So if your data center is in and around KL, for example, then you can go for One Cloud Star or China Telecom or City, for example. And the actual physical location is this Menara Ames, for example. Okay. If you are in Singapore, then you can choose between Equinix and Global Switch and various partners in these DX locations, right? So you can basically see the full list that will be available, right? So the thing is to look at the region and see what specific locations this region supports and get visibility into which partners are present there. Indonesia, if you are in Indonesia, then there are 2 locations in Jakarta with the respective DX Connect partners. Right? So that's how you kind of locate the partners and know who to talk to. So basically, you will go through this DX location where they have a customer cage where you put in your device, a customer router. There's an AWS cage where the AWS router is there. And so this will be a cross-connect cable. And a last mile connection, dark fiber from your customer router to the gateway device. On the AWS side of things, from the AWS router, it goes to AWS private network into your virtual private gateway of your VPC. Okay, so you could choose from 1 gig, 10 gig, and 100 gig. But if you don't need 1 gig, you just, can make do with, maybe 500 gig or 500 meg or 100 meg. If you want sub 1 gigs, you can, but it's called hosted connection. That means the actual direct connection is owned by the direct connect partner, you lease a slice of that bandwidth from them, right? So basically you're leveraging on an existing direct connection between the DX partner and AWS, and then you're just having a slice of that. So with this, you get better network performance because it's dedicated bandwidth, and basically you avoid going through the public internet. Also, this direct connect is associated with a region, like what I showed you earlier. So there are direct DX locations that are associated with the Singapore region, right? So in Hong Kong, in Kuala Lumpur, in Singapore itself, they are all associated with the Singapore region. Now, Direct Connect gives you a private dedicated a dedicated physical connection between your DX location and the cloud, basically your VPC on cloud. And what you need to do is then create slices of that physical connection into VLANs, virtual networks, right? So one same physical connection can have multiple VLANs. So each of these slices is given a VLAN number. So we follow for those of you from the networking background, we follow this 802.1q standard, I believe it's called, protocol for your VLAN. So you assign the VLAN number, and they use dynamic routing, border gateway protocol, to enable the dynamic routing between your direct connect and your VPC as well. And to connect to your VPCs, you use what is known as a private virtual interface, a VIF, a private VIF. A virtual private interface is how you connect to this VLAN. So you create a private VIF so that you can connect this direct connect connection to individual VPCs. So you have 3 private VIFs because you're connecting to 3 VPCs. They can be from different AWS accounts, but they are in the same region as your direct connect here. Okay. To access public endpoints of AWS services like your S3, CloudWatch, Systems Manager, then you can create a public virtual interface, a public VIF to enable the connection between your on-prem workloads to these public endpoints like S3, DynamoDB, etc. So although they are public endpoints, these public APIs, the difference is instead of trying to access these public APIs through the public internet, you're going through this dedicated private connection enabled by this public VIF. Some other options from this direct connect, you can connect using a private VIF to individual virtual private gateways, right? So you can connect up to 10 of each direct location. You can connect up to 10. Basically, you can go this direct connect quotas to get the whole quota list or limit. So you have to have 10 private VIFs for that. And all of them must be from the same region. So if this is in Singapore, then all of these VPCs must be in Singapore. The other option is to use a direct connect gateway. It's an additional feature, it's an additional service here. And one interesting thing is that the direct connect gateway is a global service. The direct connect itself is regional service. The direct connect gateway is a global service, so it spans across region, which means that these VPCs can be from different regions. And they are connected to the direct connect gateway, and from the direct connect gateway, it goes to the direct connect. So although your main data centers, let's say, is in Singapore and you're using the direct connect, for the tied to the Singapore region, with direct connect gateway, these other VPCs that you might have outside of Singapore, could be Indonesia, could be London, they can all connect to this direct connect gateway and then to the direct connect and then to your on-prem corporate network. So this VPCs, the advantage here, they can be from different networks, from different regions. And all of them can just share the same private VIF. Here, each VPCs here, they can they have to have each one private VIF for each VPC. Over here, with a single private VIF, you can connect to many VPCs, right? So they all share the links. Third option is to have direct connect gateway again, but this time you have a transit VIF to connect to a transit gateway. So if you want to connect to transit gateway, you need to have a transit VIF and a direct connect gateway, right, to connect. So transit gateway cannot connect directly to direct connect. It needs to go through direct connect gateway. Now, once you use direct connect gateway that way, you cannot use the same direct connect gateway and mix transit gateway and VPC. No, they have to be separate. One direct connect gateway for your VPCs through private VIF, another one direct connect gateway for your transit gateways through the transit VIF. Also, take note that if you use the direct connect gateway like that and you have multiple VPCs, it doesn't mean that this is a hub. That means your VPCs cannot send traffic to the direct connect gateway and route it to the other VPC. It can't happen that way, right? It only allows from the VPC to the direct connect gateway and then to the direct connect. Right? Same thing for the transit gateway. If you have two transit gateways here, it doesn't mean that they can send traffic to one another through this direct connect gateway. It only allows from gateway to the transit gateway to direct connect gateway to the direct connect, but not to the other transit gateway, right? So it's only to facilitate the connection to direct connect. Also, once you use that, I did mention as well that you cannot mix VPCs and transit gateways with the same direct connect gateway. They need to be different. So here, again, because this is a direct connect gateway is a global service, you can connect up to 3 gateways and they can be from different regions as well. Okay, so these are some of the connection possibilities, right, using direct connect. Now, of course, if you have only a few VPCs and they are all in the same region, then option number 1 should be just fine for you. If you want to connect up VPCs from different regions, you can choose to have a direct connect gateway and they can be from different regions. If you have many networks, hundreds of VPCs, 50, 80 VPCs in a particular region, use direct connect, use transit gateway to consolidate them through this hub and spoke model here, and then establish from transit gateway to direct connect through your direct connect gateway. So depending on the end use case scenario, you can kind of choose between these available options. Any questions so far that you want to take? Okay. If you do have questions, please leave it on the chat and I will try to address them as we go along. The last section here is on Route 53. How do we make sure that network traffic is routed to healthy instances? So basically the scenario is, let's just say that your particular e-commerce site is supported by multiple regional endpoints. So you're not depending on only the Singapore region. Maybe you have another backup endpoint in Indonesia, and you have for your European customers, you have another regional endpoint in London, let's just say. So we need some form of a traffic distribution, as well as some form of a health check, so that we can determine whether a particular regional endpoint is healthy or not. And that is where our Route 53 can help us. The main purpose of Route 53 is, of course, the DNS, is a global DNS server service, and it is also a domain registrar. That means if you have your own example.com custom domain that you want to register, you can use Route 53, first of all, to check whether it's available. If it is, then you can register your domain with Route 53 and you'll be officially noted as the owner of that domain. You can also use Route 53 to host your DNS records, right? And this is where you have things like A records that resolve or translate your domain name into an IP address. You can have alias records that point to, let's say, example.com points to a domain endpoint of a load balancer. And then from there, internally, AWS will resolve to the actual IP addresses of your load balancer nodes. Then you can do this traffic shifting or traffic routing based on factors like latency, health check, and other criteria, which we will look at shortly. Now, Route 53 public and private zones. A public hosted zones is where you have a public domain like example.com and you want to host the DNS records on Route 53. So this is known as public hosted zone because we do the routing to internet facing resources like your load balancers, for example, and they are resolvable from the internet. So your end users from London, they want to access your site, they go through the DNS query lookup, and eventually it'll hit Route 53, which will then give the answer back in terms of the actual IP addresses of your load balancers, for example. So resolvable using the internet, and we'll look at some of the routing policies a bit later. In terms of private hosted zone, these are internal private domain names that we can use. Let me just quickly bring up the example of the EC2 that has been launched. Now, if you launch your EC2s in the public subnet, I did mention before on the first day that they will have at least two IP address. One is the private IP address taken from the subnet, and the other one will be the public IP address taken, that is assigned by AWS. And this is what you see actually here. You have the public IP address and also the private IP address. This is from the subnet. Now, you have default public domain name. There's assigned to it, and the private domain name as well, right? So using this domain name, you don't have to use the IP addresses. You kind of use the domain name, and it's resolvable to the public domain is resolvable to public IP. The private domain, domain is resolvable to the private IP. Now, so this is the default behavior. They generate these domain names, and your DNS service for your VPC is called the Route 53 resolver. It will do this resolution for you. For example, if you try to address your the public IP from outside through the public internet, then of course they resolve it to the public IP address if they use the public domain. However, even if let's say you have an EC2 in the same VPC and they're trying to use the public domain name to address the VPC, instead of resolving it to the public IP, is intelligent enough to kind of use the private IP to reply it through the private IP as well, so that it doesn't need to route out of the internet and come back in again. So that is one of the some of the features that are supported in the VPC. But what if you want to use your own domain name? Well, if for example, if this one, for example, if you don't want this default assigned public domain name, you can use Route 53 public hosted zone to use your own public domain name, right? If you can. That also actually applies to your private domain name as well. This one is obviously not so user friendly, and if you have your own private domain which you want to attach or assign to your EC2's on cloud, maybe you can use oncloud.com or something like that, right? So that instead of using this, we will have our own private domain names. And the service that will help us do that is the Route 53. Route 53. You go to hosted zone. This is the public domain. Officially registered. This is a public domain, and so you can have your public DNS records that will resolve to, let's say, a public IP address. You could also have a private domain, create a private domain here. Let's say you want to have your own private domain called oncloud.com. And you specify it as a private hosted zone. And you can share this private zone with more than one VPC from different regions so that they can address one another through this private domain name. So maybe we could have this shared, let's say, this is the, I think this is the, let's say I share it with this VPC. What's the other one? Okay, maybe the another VPC here. Virginia and the default VPC. Another VPC, another region, maybe the Ohio region, and the demo VPC. So basically, I'm sharing this private hosted zone among these three VPCs, right? So that they can mutually resolve these private domain addresses. So I create the hosted zone. Now, again, the reason why I'm doing this is that instead of using this, I want to use my own custom private domain name and make it resolvable to this individual private IP address. So I created my OnCloud private domain. That means it's only accessible through internal networks or peer networks, basically. And maybe I have this name called at1.oncloud.com, and I direct that to this IP address of this particular instance here. I create the record. Right, so now when other instances within the same VPC or VPCs that are sharing this private zone, when their applications try to access your app server using at1.oncloud.com, it will basically resolve to this private IP, which then will make it reachable, right, through its private IP. So that is what private zone is all about. Okay, so this is your private zone. All right, routing. Yeah, Chik Hong, yeah, you're right. The private the private domain hosted private zone is similar to on-premise private DNS. You're right. Yeah. Routing policies. That means, let's say you have two regional endpoints for your e-commerce site. Here, one is in US East 1, another is EU West 2. They are fronted by two load balancers here. So we could have various strategies how we want to distribute the traffic to these two regional endpoints. One is called a simple routing. Simple routing basically means that one DNS record, you have multiple IP addresses. So let's say you go for example.com, you apply with maybe 5 IP addresses, your client web browser will pick one and try to connect with it. You could have a failover type of routing where you designate a primary, let's say, okay, this is, let's say, the primary site and a standby site. And normally, under normal condition, the traffic is directed to the primary site, but if there's a failure, it becomes unhealthy, then it kind of fails over to the secondary site. Geolocation routing basically helps you to tie a particular location to a particular regional endpoint. So for example, you could say US East 1 supports location like New York, Chicago, Florida, things like that. You can you can kind of say these are the locations that this regional endpoint will support. And so when a user from US tries to access example.com, because of this geolocation routing, you are able to direct the US user to US East 1. Similarly, when you create your geolocation routing DNS records, you could specify, okay, London, I support this regional endpoint, supports London, Frankfurt, Paris, things like that. So that when the users come from these locations in Europe, they are directed to the this load balancer endpoint. So this is good for things like content localization, right? You can specify, okay, this is for US content, this is for European content, another one maybe in Singapore for Southeast Asia. You can name Singapore, Kuala Lumpur, Jakarta, Bangkok. You can say that all this location, if the end user is coming from there, direct them to this particular regional endpoint. Now, a similar concept here is called geo-proximity routing. It is also based on end user location, but this time, let's say you have on screen here, you have 5 regional endpoints. And instead of trying to name each location, each country location, etc., you will use this traffic biasing. The traffic biasing will determine the relative coverage area of these various endpoints. So for example, there's a region here in Tokyo, and I can use traffic biasing to increase or shrink this coverage area. Of course, whether I shrink or increase it will affect the other surrounding regions as well, the coverage area as well. So for example, if I expand the coverage area, then this one will shrink, right? And this one will also shrink to in proportion. But if I shrink this area, then the coverage area for this one and this one will start to expand as well. So these are relative type of controls. But the whole idea is once you kind of use traffic biasing to establish the area of coverage, then if the end user is coming from within that area of coverage, they'll be redirected to the particular endpoint. And similarly for Asia here, as long as coming within the coverage area, it will actually be directed to the endpoint. Another type of routing is called latency-based routing, and this will be based on actual latency records. And so basically what happens is that at this Route 53 edge locations, they will maintain certain latency tests. They'll check latency tests from like a particular edge location to a particular region. They will kind of, run some tests. Let's say from this particular Route 53 location, they run some tests. They kind of figure out that US East 1 in the US, it takes 137 milliseconds. E West 2 will take about 76 milliseconds. So depending on where the end user is coming from, they will check and say where is the fastest path. So for in this particular example, the fastest path is lower latency is to direct the user to EU West 2. Right? So these are actually based on latency records, and it will give the fastest path for the end user. Multi-value answer routing is you create multiple DNS records for your endpoints. And then Route 53, when your user types example.com, Route 53 will send up to 8 healthy records. Meanwhile, Route 53 will send DNS checkpoints. The Route 53 check health checks. And they'll take note which one is unhealthy, which one is healthy. And when the user asks for example.com, it will return up to 8 of these healthy records back to the user, and the user will use one of those to establish the connection. Weighted round robin or rated routing, where you have, let's say, 2 endpoints here. You can play with weights to bias the traffic. So you could have a 90%, 10% type of weightage, for example, or 80-20 or 60-40, depending on how you want to do it. So quite nice. Let's say you have 3 sites, Singapore, Hong Kong, and Sydney. You can have this weightage to say, okay, send 60% to Singapore, 20% to Hong Kong, 20% to Sydney. So we can have this weight biasing. And Route 53 health checks will be carried out as well, so that if one regional endpoint becomes unavailable, it will redistribute it to the other remaining healthy regional endpoints. So just maybe a quick mention here as well. Weighted round robin or weighted routing is quite useful for blue-green environments. When you're deploying new versions of your application, you can just put them into two separate load balancers, for example. And then you kind of have this weight balancing to have your blue-green. So maybe you can start with 90-10 and then 80-20, 70-30 until you're quite confident that your green new version can work. Then you can shift 100% to that new version environment. Now, there is this feature called ROB53 Resolver for hybrid clouds. And now, as Chik Kong was mentioning earlier, on-prem, you have a private DNS server. And then on cloud, you have your ROB53 Resolver service. So if I maybe do some whiteboarding here, let me just pull it out. Okay, so here is the situation where let's just say that we have an on-prem server here called app1 onprem.com. And then one of the EC2s here has another application called app2 oncloud. Now, by default, there's a challenge here because this server, let's say this on-prem server, has this app1.com. app1.onprem.com. Now, it's registered with this DNS resolver, this private DNS server. And so if you have clients that is within that same local corporate network that is trying to access this domain, is resolvable, right? The DNS server will know the IP address, return the IP address to this client, and you get connected. That's fine. But by default, let's say this client is trying to connect to app2oncloud.com and they ask the DNS resolver. This time, the DNS resolver here or the private DNS wouldn't know the answer, right? So, that's a bit of a challenge. Similarly, this app2oncloud.com, we can create our private zone, no problem. This one, we went through the demo earlier. So that if this is the one with app2.oncloud, another EC2 within the same VPC or VPCs that share the same private hosted zone and they have some form of a peering relationship or transit gateway, and they want to connect to use this app2oncloud.com, then not a problem, right? They can resolve to the subnet IP address and then they can get connected. However, if this EC2 would like to connect to app1.onprem.com, then your ROB53 resolver, the DNS service for your VPC, wouldn't know the answer, right? As it is, they wouldn't know the answer. So this is where this resolver inbound and outbound point comes in. It is a NIC card that is deployed into your subnets, and for redundancy, we recommend that you choose one subnet per available zone to deploy this resolver, this ROB53 resolver inbound point and outbound points. And the whole idea about this is to say, okay, with this connection, what I can say is this: I can have a forwarding rule in this private DNS server to say that if you see any queries for on-cloud domain, you can create a forwarding rule to forward this to the ROB53 resolver inbound endpoint, which is actually given by the private IP address. That means this one, it is a NIC card, so it comes with the private IP address of the subnet. So basically, you need to set up a forwarding rule in your private DNS to say that if you see any queries coming in for this on-clock domain, please forward this request to this regional, this Route 53 resolver inbound endpoint, the IP address given. And then basically this resolver endpoint connects back to your resolver service, the Route 53 resolver service that will have access to the private zone that will have an entry of this app2.oncloud.com and gives you back a private IP address of the server, and then it goes back to the resolver, and from the resolver it goes to the client that requested. Right, so now the client has the private IP address of app2.oncloud.com, and they will use Direct Connect to initiate the network connectivity. So in this time of the name resolution, remember there's always two steps, right? First step is resolve the DNS name. If I'm using a domain name to address the server, I need a domain name resolution to get the IP address, in this case, the private IP address. Once I get the private address, then stage 2, I do the actual network connectivity or network connection to that. Similarly, the outbound is for you to create a forwarding rule in your Route 53 resolver service. This time, I will give a forwarding rule, something along those lines as, if you see requests for any on-prem domain names, then you go for the outbound. But it actually points to the private DNS record, but through the interface, through the outbound endpoint interface, right? So you provide this address, and it's actually going to look out for this private DNS server, so that your request can go across the Direct Connect to the private DNS, and then the private DNS will give us back the private IP address of this app1.onprem.com, goes back in, and now the instance will have the private IP. It can go to Direct Connect to connect to it, right? So this is for hybrid hybrid DNS resolution. Okay. Any questions? Anything that you want me to elaborate on for this networking module? Okay, let's have a knowledge check. What is a network connection to a transit gateway call? What is a network connection to a transit gateway call? Okay, right. Now, the answer is actually B, attachment. These are possibilities. You can attach the VPN route. The VPC as well can be connected to the transit gateway, but each one is called an attachment, right? That's the term that is used, attachment. So you could have VPC, the VPN, direct connect, gateway, transit gateway peering. All of them can connect through the transit gateway, and we call this connection an attachment. What are the components of a AWS site-to-site VPN connection? The two components at either end of that connection. Okay, very good. Yes, it is the customer gateway device and the virtual private gateway. Well done. What is true of VPC peering connection? Select two answers. Okay, so let's take it one by one. Connections are one to many. That is not correct because peering is only one to one. The peering relationship cannot be. One VPC can have more than one peering relationship. All right, but the connection itself is only one to one. That's all, right? So it's a one to one peering. So this A is not right, B is correct. Connections require transit gateway? No, it's a direct one-to-one between VPC to VPC. Connections can span accounts, it's true, right? From different accounts, I can still peer as long as the owner, let's say I'm in account A, my VPC is account A, yours is in account B, and your VPC is there. I can initiate a peering request, and you as the owner of VPC B, you approve it. Once you approve it, we can establish. So this is true. E is not correct. Connections are transitive. Transitive connections are not supported, basically. Right? Transitive means that A connected to B, peer-to-peer, B and C, peer-to-peer. But A is not connected to C. That means A cannot send a packet, the EC2 in A cannot send a packet directly to another EC2 in C without being proxied. That means the packet cannot just flow through like that. That's called transitive. That is not supported. You need a proxy like a EC2 in B to terminate the session and then to read another one to C, the EC2 in C. But if you want A and C to connect together, then they must have their own one-to-one peering relationship for them. So transitive connections are not supported. So at the end of the day, your B and D would be correct. Okay. Any questions around this? Right. So this is your one-to-one peer. One-to-one peer. A is not connected to C. It cannot. The packet cannot just flow through B and then directly to C like that, that is transitive, that is not supported. Okay. How can an application running in a VPC access S3 without internet access? That means if I'm running on if I'm an application running on a EC2 in a VPC, how can I reach an S3 bucket without going through the internet? Okay, very good. Yes, the answer is interface endpoint and gateway endpoint. S3 supports both types of endpoints. Very good. All right, that's a wrap for our network topic. Hopefully that will set it up at least at at the basic level so that when you do the revision, it'll be easier on you. Meanwhile, we continue with our coverage of the remaining modules, starting with edge services. There's a lab with that, but I'll leave it to the end of the session. Now the edge, what is the edge? The edge is the boundary of the AWS network as close as possible to the end user so that we can optimize our delivery of our services. Okay. What percentage of your workloads require ultra low latency to devices and users? That means what aspects of your current architecture that requires this fast delivery of connections, very fast connections to your end users. Do you have such requirements? Okay, so, oh yes, you do have, yeah, at least a portion needs fast connected. Okay, very good. So that is where you will benefit. Oh yeah, of course, Chee Kong, yes, the comment is there, but yeah, there's a cost to it. And that is where you will have the need for these edge services in order to deliver the content as fast as possible or to make sure that the customers can connect to your backends as fast as possible. So this network engineering team is telling us, as of last week, they have 1,000 over customer care service technicians or pros across the globe. They use a mobile app to upload access project files on a daily basis. And so right now, all requests for project files are fulfilled in our primary data center in California. And this is, to support a worldwide group of resources of pro care engineers. However, the further these pros are from California, the more latency, it becomes a big pain point, and we're exploring content delivery networks. So how can we implement a CDN on AWS? It's also critical that we build a solid architecture to protect against DDoS attacks, so that they are wanting to have an increase in global network security and shorten latency. So basically, this is your edge architecture. You in terms of AWS cloud, you have at the edges here, you have the CloudFront content delivery network. You have the global accelerator. Content delivery network is more about pushing content to your end users. Global accelerator is about bringing them to as fast as possible to your application backends. And then you have these security services that protect against DDoS, injection attacks, etc. And then you have also options for on-premises, basically in the form of an outpost. It's like a rack of AWS hardware, cloud infrastructure that is actually physically placed into your data centers. So as usual, we have a number of these end user requirements and questions that we'll take it one by addressing these solution areas, starting with edge fundamentals. And the network engineering lead is saying our European headquarters are reporting high latency to the California data center. So let's define the edge. You've got your AWS regions. in 26 locations across the globe. And, depending on end user locations, they may or may not be near these regional locations. Your data centers may not be near to one of the regions. Your end users or customers may not be near. Okay. We've seen in the first day this concept of a local zone, where if my region is in Singapore, hopefully sometime in the future, we will have a local zone in Bangkok. But that would be great as well, because Bangkok is a little bit far from Singapore in terms of very strict latency type of environment. And so having a local zone in Bangkok would mean that now the end users will have very much faster turnaround. So we have already seen that. So that is, in a sense, expanding the boundaries of your region. But we want to talk about other possibilities. This one is called Outpost. Outpost is sending the actual AWS cloud infrastructure, the servers, the storage disks, etc., to your corporate data center, the on-prem data center. And it connects to your corporate LAN, so to be part of the network. And this will be very useful for legacy applications, databases, or situations where you need to be at the on-prem. The journey to the cloud is either not acceptable or takes too long. For example, if let's say you have a production line, a manufacturing line, and let's say printed circuit boards, and you're using intelligent vision technology to do QA on the placement of the components on the motherboard, for example. And so you over there at the live and the production site, you're taking video images or pictures of the board for the machine learning artificial intelligence to scan through and decide whether the components are correctly placed or not, let's just say. Now, if let's say I've got a plant in Bangkok doing this vision technology, and my back-end machine learning is in the Singapore region, if there's any outage or delay in the network, then I hold up the whole production line, right? It needs to be split second so that the production line can just move as fast as possible. But if there's an outage, it's slow, then I hold up the production line. So to meet that ultra latency requirement, we can ship the whole outpost to the manufacturing plant local corporate network and then hook it up so that now from the production line to my machine learning type of solution here, it's a very fast turnaround. Right? So Outpost is about bringing it to on-prem. And then a quick note on Wavelength. Wavelength is for 5G kind of applications. Let's say we have a 5G mobile app for medical type of applications where we have AI-assisted medical services, for example, or gaming type of solutions where we have online gamers and we use 5G to take care to improve the latency speeds, etc. Now, in the past, you could have the 5G telco provider provide that 5G, and our mobile apps, our 5G mobile apps can connect to the telco site. But then remember, from the telco site back to your back-end gaming infrastructure in the Singapore region, for example, it is going to be quite a distance. So let's just say this is our gamers from Manila, for example, using 5G, great locally, but then wait a minute, Manila to Singapore, well, it's not exactly near, it's still at a network distance away. So having this wavelength means that AWS will have a type of like collaboration with, let's say, a Manila telco service provider. It's not happening yet, but I'm just saying, for example, one of your 5G telco providers in Manila can have this collaboration with AWS, whereupon AWS will bring a part of their cloud infrastructure, just like in the Outpost case, but this is directly with the telco service provider, and place this AWS cloud infrastructure into their data center, where they are terminating their 5G mobile network. So from the 5G mobile network, it comes into the telco data center, it terminates there, and immediately there's the telco local area network with the AWS wavelength infrastructure there. So similar to Outpost, you can extend your VPC for your mobile backends, in this case, the gaming backend, and deploy part of that backend into the wavelength infrastructure there, so that the turnaround from that 5G network to your wavelength deployed resources is going to be very fast. So all of this is about pushing the cloud infrastructure to be as close as possible to your end users or to your on-prem or to your 5G telco service providers. And then you have other edge locations that will help delivery of content in terms of CloudFront and security services that protect these edge locations. So edge locations we saw on the first day is 300 points of presence and mainly used as a cache solution for content delivery network. So that if you have, let's say, content in this location here, in let's say Sao Paulo, the original content is here, and a user is trying to come in from a location in Asia, that user will be redirected automatically to the nearest edge location here, and they'll check the cache to see whether content is there. If not, they'll fetch from the original location, deliver to the customer, make a local copy available on cache, so that subsequent requests will be a faster turnaround, basically. So that is about CloudFront, and the application developer is saying, what service can provide us with the content delivery network we need? And of course, the answer is CloudFront, which is the one that we've seen here before. And basically, without the edge caching, the user request, each user request needs to go back to the origin. So if you take our Asian movie streaming example, which will be keeping, let's say we keep the MPV4 into a S3 bucket here in the Singapore region, London user will, this London user will have to make a get and goes all the way back to the S3. Another London user will have to do exactly the same thing to go to, all the way back to Singapore. So everybody will take a hit in terms of latency. But with edge caching now, we have a CloudFront edge location in London. So the first user tries to request CloudFront edge server here will check, do I have the cache copy locally available? If no, I will go back, fetch it from the S3 bucket, update my cache, and then deliver to the user. Now the second user tries again, request for the same content. Now the content is available on cache, is immediately returned to the user without going back to the origin in Singapore. Much faster turnaround. And using this edge location like CloudFront improves your general security posture, because you have DDoS protection, you can deploy web application firewall to protect against injection attacks, etc. So overall it does increase your security as well. So basically, CloudFront is a content delivery network, integrates with AWS web application firewall to protect against SQL injection attacks, cross-site site attacks, etc. And Shield for DDoS protection. Can be used for both static and dynamic. Static will of course benefit the most, like your static images, your static video files, etc. But for dynamic content, it does benefit in the sense that it tends to keep the TCP sessions longer, because it's expensive to create and hold these TCPs. But CloudFront has an optimized way of doing it, so they keep a few sessions alive, so that to connect from your edge location back to your original server or original S3, that setup is much faster. So it does benefit dynamic content as well. But of course, the most benefit comes from static content that can stay at the edge location cache area for as long as possible. And then you have built-in security features. We already mentioned these security features, but some of the built-in security features is to allow you to use your own custom SSL cert if you want to have your own custom domain to be used in conjunction with the CloudFront. And you can also create a special entity called a CloudFront or SS identity or origin identity that connects to your S3 bucket. And you can configure for the S3 bucket to only accept requests from this special CloudFront user to prevent users from trying to access your S3 bucket for content directly. So this is basically how it works in this particular age location, let's say in London, first user requests for this movie, Asian movie file. It checks whether it's present. If not, fetches from S3, populates the cache, delivers to the user. So a long turnaround for the first user. Second requester, however, request now is found on cache and is delivered directly. So that's how that caching works and it benefits them overall. First, what do? We choose our origin and define our region. So our region could be a S3 bucket, it could be a load balancer endpoint, it could be a custom origin, let's say from an EC2 or an on-prem server. As long as they are publicly accessible, they can be origins. Next, we create the distribution. We create the cache behavior in terms of the path pattern. So for example, you can establish a path pattern to say, okay, if /wildcard.jpg content is being requested, please go and fetch it from this S3 bucket. Or if HTML files is requested, please go and look for it in this load balancer. So you can create this pattern to tell CloudFront for certain content, please go and look at a particular origin. Right? You can have protocol policies, whether you want to accept HTTP or only HTTPS or both. Methods that you accept, get methods. Do you want to also support post or patch if it's a two-way type of interaction? Sign URL to kind of protect access to your reserved content. So for example, in our Asian movie streaming service, some content we provide for free, maybe previews to documentaries or short documentary, maybe we put it for free, but other movies and contents is a paid subscription. So we can have this feature called sign URL, where the user needs to get authenticated with authenticated server first, and that authenticated server will generate a signed URL pass back to the user browser, and that user browser will present the signed URL to CloudFront. And once that signed URL is verified, then access to the particular movie is granted, for example. Some cache policy, for example, setting the time to live TTL. How long do you want content to be at the edge? Can it be there 72 hours or 24 hours? Or maybe 200 hours, it's up to you. Kind of set some of these caching policies. And then optionally, you can associate maybe a Lambda function, a CloudFront edge location, to do some form of image resolution, so that if the user is trying to request for your content on a smartphone device form factor, it kind of chooses a particular resolution size. Or it's coming to smart TV, it's another resolution size. Or some form of a custom authentication authorization functionality. You can deploy what is called as Lambda at edge. You deploy a Lambda function at the edge location to do all this edge logic processing for you. You can associate web rules, and you can add in your custom domain name as well. You can upload your own custom SSL or SSL cert. So origins could be S3, load balancer, custom origin, your EC2 or your on-prem basically. And you kind of define the patterns which I kind of described to you earlier. And the example will be to say that, okay, for a pattern like example.com/wildcard.jpg, go and fetch from your S3 bucket. Or if it's for HTML, go and look for it for the load balancer, and I put the TTL as 0. That means don't cache it. Every time refresh and get the fresh HTML. For this one, TTL is 3,600 seconds, so that for that time period, they can remain on cache. Global Accelerator is to optimize the optimal path from your end user to your application backend. So this network engineer is saying, what can I do to optimize our network performance for my latency sensitive workloads? So you have a very critical and global database, and you have a widespread customer base for your application, like online gaming or whatever it is. And without Global Accelerator, your online gamers are coming through multiple hops to reach you. And obviously, each hop will introduce a delay. Now, Global Accelerator will be pushing out to the edge so that whenever your gamers try to connect to your online gaming site, they will always be redirected to the nearest edge location, which they access the Global Accelerator service, and the Global Accelerator service will optimally route that request or that path to in an optimal way to your regional backend. One of the key features of this Global Accelerator is Anycast IP, so that basically, when you create a global accelerator setup, they will give you two static public IP addresses that will be assigned to you, assigned to your backend. So whenever your users type example.com, it will always come back with this static consistent IP, one of two or two static IPs. And then you have, in this case, 3 regional endpoints here. And when your user comes in, when no matter where they are in the world, whether from Asia, from Europe, or from US, when they type example.com, they will be given, let's say, this static IP address, which they will use to try to connect to your application backend, and they will be redirected automatically to the nearest edge location of Global Accelerator, and then from the Global Accelerator, they will be directed to the nearest regional endpoint. There's a few possibilities in terms of criteria of directing the users, but the most common is proximity. That means the users in US will be directed or channeled to the endpoint in the US, and similar for Europe and Asia. The advantage here is that if, let's say now, the one in Europe went down, this regional endpoint went down, this would be transparent to the user. They don't have to worry about different IPs because they will connect to your service using the same IP. But the Global Accelerator is intelligent to kind of detect that, okay, the EU Central one is already down. I will redirect to the next best regional endpoint. So it goes into that regional endpoint automatically. Okay. So with static IPs, you also don't have to worry about DNS caching. Earlier on, if you can recall, we used Route 53 global DNS service to kind of route our users to various endpoints. And we say that, okay, one fails, then we reroute it to another endpoint, which is fine. But for DNS, be aware that your some of the intermediary DNS services and your client web browser, they may actually cache your DNS result. That means, for example.com, they are pointing to an IP that is no longer healthy, right? One of your load balancers have gone down, for example, or the region has gone down. So they may still cache the old IP address, even though you have redirected them to another regional endpoint. Because of DNS caching, they may be still trying to use the old IP to connect, and they will have the connection timeout and things like that. However, with Global Accelerator, that problem no longer exists because it is always the same static IP, no matter which region endpoint is in use. Okay, so that gives you the consistency. So here, in this example, the one in Southeast Asia goes down, and the users are directed to Europe automatically by Global Accelerator. So the key difference between CloudFront and Global Accelerator, I leave it to you to review that. But essentially, CloudFront is about, the main idea is about directing content, static images, streaming video, your website files, as fast as possible, optimally to your end users through use of caching at the edge. Global Accelerator is about bringing your end users as fast as possible to your application backend. For example, the online gaming site is about trying to bring our gamers' connection to our gaming infrastructure in various regional endpoints as fast as possible. Right? So one is more about delivering content. The other is about bringing user connections to connect to our application backends as fast as possible. And the other feature of this Global Accelerator is to have these two global static IP addresses, right, that will not change, basically. Next, we look at DDoS protection. There's a security engineer here is saying, I've seen outages caused by DDoS attack, and I want to protect our site with a strong firewall. So how do I go about doing that? Well, as you know, DDoS in general basically is about the attacker taking advantage of the bots, and each bot's taking over other bots as well, become slaves, and then you have a massive army of these zombie bots that will generate a lot of malicious nonsense traffic to overwhelm your target victim server. Right? That's the general idea in DDoS. And if you look at this, is the OSI model from layer 1 to layer 7. Our common attack vectors are in the infrastructure layer, the layer 3, layer 4. Layer 3 is your network layer, and you could have this UDP reflection attacks, basically where let's say they kind of connect to a NTP server, a network time protocol server, to kind of synchronize time, but the requester IP address is spoofed to direct it to the victim server IP address, so that you potentially millions of requests goes to a series of NTP servers, and they all generate this reply acknowledgement to the victim server. Transport layer, you have a three-way handshake in terms of the TCP, and a SYNFLET basically abuses that three-way handshake of your TCP of trying to initiate and in the process of acknowledging and all that. They abuse it by withholding some form of the handshake. They withhold the malicious servers, the bots will withhold the acknowledgement, so that your web server is waiting for that acknowledgement, and the threads are kept open. And if they're having a lot of these open connections, it consumes too much of your web server resources, your web server will crash, right? And then on the application layer or at the presentation layer, first you have the SSL abuse. Again, SSL handshaking, you need a lot of handshaking going on, and they purposely delay or slow down the reply so that your server is waiting on the reply. And usually they are prepared to wait because they know that under normal circumstances, there could be some network outage. But you multiply it by millions of these connections, then it takes up too much resources to wait and your server collapses. Or at the layer 7, where you have HTTP floods, for example, where you generate a lot of HTTP traffic, and it's difficult to distinguish between HTTP traffic that is valid from your actual customers and HTTP traffic that is from malicious hackers. So this is where protection needs to come in. For your standard infrastructure layer attacks, we have Shield Standard, and thankfully Shield Standard is the default protection for all AWS accounts. It's free, you don't have to pay extra, and it has good protection to mitigate against these well-known infrastructure attacks. Just to say as well, for more application layer attacks, there's another one called Shield Advanced that we'll take a look at later. But in any case, we want to jump to this web application firewall, which creates rules to protect against things like SQL injection attacks, cross-site script attacks, suspicious HTTP traffic that you can define. Maybe you're looking at certain keywords where you can define these rules, and they will either allow in legitimate traffic or block suspicious traffic. And you can use these web rules to kind of protect your CloudFront, your load balancer, application load balancer, API gateway, and AppSync. AppSync is, again, the GraphQL. And the WAF here generates CloudWatch metrics that you can track, all right? This particular rule, how many times have been activated. And it also supports logging through Kinesis Data Firehose, where you can stream the log information to Kinesis Data Firehose and then onwards to, let's say, the S3 bucket. Advantage here is the Kinesis Firehose can run custom Lambda functions to do some kind of pre-processing and pre-filtering of your log entries before it goes to the S3 bucket, for example. So basically, you could have multiple rules here to protect your endpoints. You could have more than one statements that can be logically AND together or logically OR together to kind of protect against what you call it, malicious attacks. So these are the kind of attack vectors that are protected: your SQL injection attacks, your cross-site script attacks. Traffic filtering, basically rate limiting, means that let's say you can have a rate limiting rule to say, okay, over the last 5 minutes, if I have 300 requests from this any IP address, please block it, for example, right? Or pattern matching, regular expression, string match. I'm looking for this status code. I'm looking for this error message, for example. And then you evaluate it. If it's evaluated to be true, you can take action to either block or allow. Or if there's a special unique ID that your valid customers have to use the service, you can have a pattern matching to look for that keyword. If it's found, then you allow in. If it can't be found, then you block the traffic. And then you can basically end your statements together, all the statements together, and have a negative not statement. So basically, the firewall basically is very useful when you have multiple AWS accounts. Let's say you have 10, 15 accounts. How do you ensure that you have consistent security policies across all accounts? Maybe a standard set of WAF rules that you want to apply across the board, VPC security group rule settings that you want to apply across the board, and etc. So basically, with this firewall manager, it gives you the ability to implement a baseline protection or baseline configuration for your multiple AWS account environment, so that each account that comes in, it kind of protected by a baseline number of WAF rules or VPC security rules, etc. So in a nutshell, basically, you have a DDoS resilient reference architecture, in the sense that you have Shield to protect your endpoints, entry points to your application. You have WAF to protect against injection attacks, DDoS attacks as well. And then you have your elastic load balancer in the public subnet and your workload in the private subnet. So this is, of course, well protected because there are multiple layers, right? Hopefully, most of the attacks can be mitigated at the edge with Shield and with WAF, Web Application Firewall. But if it does come through, then the first that gets the hit is the load balancer. And the load balancer does have DDoS protection as well from AWS Shield. And if necessary, they'll scale, they'll add more nodes to kind of absorb the traffic. And then at your side, the last line of defense is auto scaling, but you want to limit, because you don't want to scale into an infinite number. There must be a maximum capacity that you're willing to pay for. Charun Chai, no, the WAF only supports this endpoints, basically. So if you have on-prem and all that, you have to use third-party type of solutions, right? That may be able to span across other cloud platforms or to your on-prem. Okay. So basically, let me quickly show you. You're going to do this in the labs later as well, but not run. So in a CloudFront distribution, basically you define your origins. Just using some examples of the bucket. And when you define the origin for your S3, you can also choose this security feature, whether you want to use the origin access special identity, so that if users try to access your S3 bucket directly, it will not allow the access, right? So this will require a change of the bucket policy, right? So this is one additional step that you can take. And just try to enable this origin here. So you enable the origin, and then for kind of failover, for redundancy, you can actually add more than one origin to an origin group. okay, and name it as a origin group. Origin group, for example, and then you define the failover criteria. What failover message or error message from the primary bucket, what would actually trigger the failover, right? Maybe, your 400 error, or maybe a gateway timeout error, back gateway 500 error. You can create this type of rules to determine under what conditions it will go from primary to secondary, right? So you can set up these origin groups as well in terms of the more redundancy. And for each origin, you can define a behavior to say that, if the files being requested is along the lines of maybe documentaries that I have, MPV4, the documentaries, I choose a particular origin. You see this path being requested, go and look for this S3 bucket to draw these files on, and then you can determine whether you want to compress the object, whether you want to support HTTP, HTTPS, or only HTTPS only, or you want to support read-only methods, get and hit, or you want to support put as well. If you're expecting uploads from your end users, you can determine the allowable HTTP methods. Whether you want to restrict user access if it's for paid content. If you say yes, then basically you can create a CloudFront keys that are created. You pass these CloudFront keys to the authentication server. They'll use this CloudFront keys to generate signed URLs, so that when users try to access the content, they'll be redirected to the authentication server first, get authenticated, and then the authentication service will generate the signed URLs, given back to the end user web browser. End user web browser presents the signed URL to the CloudFront service. The CloudFront will check and validate that yes, it's a valid signed URL and run the content. So this is to restrict user access. Then you have caching policies. I won't go into details here, but caching policies to set the things like the time to live, etc. Right? So that we know how long to keep it on the edge for. So once you set up these behaviors, right, then you have this number of rules. It follows an order of precedence. So the one that comes first will be evaluated first until the default, the last rule to be evaluated. Okay, so if you, for example, have this type of rules and you put /image /wildcard.wildcard, that means all image formats, then this will be taken first. So when you have this one as a generic catch-all, and then you have a more specific one, the implication is we will never reach the second rule here, because this one will always be true first, and this bucket will be used rather than this. So if you have a more specific format that you're looking for, like JPEG, make sure it's evaluated first, move it up so that we're evaluating it first, and you will fetch it from this bucket, and then another comes in with .png, then it will go back, it will go to the second rule and evaluate and pick it up from another bucket, right? So just be mindful of the order of precedence here. Okay, so this is your CloudFront distribution. Maybe I just very quickly go to the WAF. I create a web ACL here. Let's name it like that. And I add a rule group. I can add manage rule groups. So these are rule groups that default out of the box. Again, the general principle here is that don't reinvent the wheel. If they've already given you good rule, like known bad inputs that can corrupt your or compromise your systems, vulnerabilities around Linux, SQL database vulnerabilities, WordPress application vulnerabilities, these are all preset. And good news is they are free. So add them to your WAF. Why reinvent the wheel? And then paid ones, they are more sophisticated, like account takeover prevention, you can add, but it's basically going to cost you some money, or bot control. that you can add a more sophisticated kind of protection. Or you can go for a third-party one that has their own rule set that you can subscribe to, like OWASP top 10 rule. OWASP is always used as a reference because it's a independent industry advisory that comes out each year with this top 10 vulnerabilities. So or sometimes your auditors will recommend that you kind of adopt this. So why reinvent the wheel? Just subscribe to their rules, and then you can see another one that they also have their own board protection, their OWASP rule protection, common vulnerabilities and exposure. So these are all industry best practice rules to add, and go ahead to look at this managed rules first because it may meet your requirements. But if you want to have your own custom rules, then you can customize your own rules. Maybe just to highlight your rate-based rules, for example, rate-based rules says this is a form of DDoS protection as well. If you detect maybe more than 300 requests from a single IP address over in a 5-minute period, then we block the source IP address, right? We can block it. Or you can have your regular rule here where you have a number of statements. Let's say you want to all the statements together. So maybe the first statement is I can inspect a particular HTTP header or the body if I'm looking for a keyword, or the path being requested, or let's say the query strings, the one that happens after the question mark, example.com/question mark, the query string. And I can match it with the SQL injection attacks, for example, and maybe add in a URL decode. Usually the URL is encoded, so we want to decode and do the match here. Or maybe query string and protect against cross-site script injection attacks, for example. Right? So I can have two statements and all the statements together and add the rule. And you can add multiple rules, number of statements per rule, and them, for example. And you can add a number of rules. And again, these rules will be evaluated in the order of appearance. Okay, so this is your WAF that you can consider. The other thing is the firewall manager. If you have a situation, especially when you have multiple AWS accounts, this will be a very useful rule to have to kind of deploy your security policies consistently across multiple accounts. And you could have standard WAF rules that you want your child accounts or AWS accounts to adopt, or Shield Advanced. I did mention Shield Advanced is a paid subscription, and it provides you with sophisticated layer 7 protection against DDoS. Or it could be a security group, a VPC security group, where I could say, okay, this is a common set of security groups that my child accounts can use to apply for their VPC. Or I want to be a little bit more proactive. I want to audit and enforce the use of certain best practice reference security group rules for your child accounts. So I can do that as a check. And then basically, as I could have managed rules to just audit overly permissive security rules, basically. Or I could predefine high-risk applications. There's another additional setting here where I can just evaluate whether they are, under some high-risk situation for these very critical applications. So you can study this and you kind of provide this managed audit policy rules, or I can consider my own custom policy rules in a sense of providing a positive example to say that use my reference security group and use those rules there. Or a negative example, don't use any rules that are contained in this security group, like you open up port SSH port 22 to any IP address, right? So a negative example. So if you have already, for example, have a good reference security groups, maybe let's say, just for the sake of discussion, this default maybe is, I've properly configured this default to be used as a reference. So I can use it as a common reference. And then I can choose to just flag out resources that don't comply to this reference, or I can auto remediate non-compliant. That means it override with my reference security group here. and then I can include all accounts under my AWS organization or only a specific OU. Maybe I go for the DevOps OU, right? So that all this, any accounts under this, or the DevOps one, any accounts under this OUs are included for this compliance check. Okay? Include this and all of these resources as well. And then I configure the tagging and all that, and I create a common policy, right? I'm not going to go through, but just to give you a feel of how you can, configure this firewall rules. Okay, what is the capacity for the rules? You mean for the WEF? The WEF, huh? Yeah, there are some charges. Some of the WEF rules, when they evaluate the rules, they associate with some capacity measure, and they will give you an idea because if you can try to Google WEF pricing, AWS WEF pricing. They do charge you. There's some cost associated with these WEF capacity units, right? Depending on the rules, right? So you can just verify that you Google AWS WEF pricing. Okay, so you can correlate that pricing with the capacity units. Okay, so Outpost basically, if without Outpost, basically, if your on-prem is quite far away from the AWS region, then sometimes applications need to remain on-prem because of latency requirements or maybe because of security compliance. For those situations, we can bring a part of the AWS cloud infrastructure into your on-prem corporate network and deploy these resources, this time locally. So think of this as an extension to your local situation, right? So you can deploy EC2s on that Outpost, RDS, your containers, etc. Okay. Yeah, Kesham, yes. Right, that's generally the practice because then more capacity is used. Right? Okay, let me just bring out last module. Thanks for your patience, everyone. This is our last module for backup and recovery. So which backup and recovery components do you work with? Oh, sorry. Currently. Which types of backup and recovery strategies do you use? Okay. Okay, so quite a fair bit of, yeah, very good. Yeah, quite a widespread of these strategies. Well done. Okay, let's look at what we have. Backup and recovery. Now, this, as I said, is something that is quite major because a lot of organizations naturally would look to the cloud as a backup and recovery, option. If even if they want to keep their primary workloads on-prem, it kind of makes sense to back up to the cloud because resources like S3, the storage cost is much lower, right, than your on-prem disk. So it does make sense to be able to use the cloud. So look at this CTO. I've been to enough horror stories, IT scenarios to know that disaster planning is absolutely critical. And so now we need to have a backup and recovery plan. And how do we make AWS Cloud part of this situation, part of our strategy in order to meet our backup and recovery RTO, RPO. So again, let's look at some aspects of this. So disaster planning, the chief operating officer is asking us what's our RPO basically. And the assumption here is that you must be prepared that things will fail, right? So, and things will fail. One of the key dangers is we think that if we have a disaster recovery plan, it's going to work. Well, may or may not, right? Because you have to be making sure that you have realistic testing, first of all. Doesn't mean that you have in paper, it will work. If you have too complex of recovery paths, there are too many points of failure or dependency, if one goes down or one part of your plan fails, then maybe you bring down the whole plan. Or the plans have not been updated, also very important, right? In the last 10 years, we have not been updated, not likely that it's going to run smoothly. So basically, we want to take in mind all this high availability, minimizing the downtime, fault tolerance, backup and disaster recovery. These are all related terms that we bring on board to avoid single point of failures, to be able to draw files that are backup in terms of data corruption or data loss, and to have a DR plan in mind so that if, let's say, one region goes down or on-prem infrastructure goes down, we can actually stand up resources on the cloud to take over and resume the services. So plan for instance failover, let's say within a VPC, and then, basically if you have a load balancer and several instances, then that is taken care of. Plan for availability zone failover. Make sure that your workloads, your EC2s, for example, are in more than one availability zone. And lastly, plan for regional failover. It is possible for the whole region to go offline for some time, and want to make sure that if you have very critical application, you need to plan for regional failover as well. Now, this as well, in terms of planning around your backup recovery and DR type of planning. Your RPO is basically how much data you can lose, right? So basically is if you have a particular RPO of 1 hour, 6 hours, or whatever it is, then that will determine your backup strategy as well to prevent that, to kind of keep within your RPO. But it's also be mindful of the rate of change of the data, right? If your data only changes once every 24 hours, there's no point to back up your data every 2 hours because it only changed once every 24 hours. So, you take into account the backup recovery point objective as well as the rate of change. In terms of the RTO, how fast do we need to bring back services? So for critical applications, maybe 1 hour. For less critical applications, maybe 24 hours. Now, we know that it's also a function of cost. If, let's say, everything is very stringent, right? RPO 1 hour, RTO 30 minutes, things like that, then the cost obviously will start to build, right? There's no doubt about it. So, just be mindful that, not necessarily everything go for the premium. Do your due diligence, see what are your tier 1 critical applications that will have the stringent SLAs. Other applications or services may not need that level of stringency. And so, be aware it's always going to be a trade-off, right? So make sure that you bring that into your due diligence. And in terms of essential services for DR, well, your fundamental services, storage, compute, networking, your VPC, subnets, etc., your database, and make sure that you have CloudFormation templates, for example, that help you deploy out your DR infrastructure by templates, not by hand. By hand is obviously going to be too slow and error-prone. So, basically, be mindful of that. Okay? Now, duplicate your storage. S3 has cross-region replication from one bucket to the other bucket. And then the S3 Glacier is in region. It doesn't have this cross-regional replication. If you want to replicate the region, you must retrieve it first and then migrate across and then put it in the Glacier in another region, right? But S3 does have that cross-region replication. EBS, you have point-in-time capture of snapshots. EBS snapshots is stored in an S3 bucket. and then you can copy this snapshot across regions as well. Snowball is where you have a large data sets from on-prem you want to bring to the cloud as part of your backup and DR strategy. Then you can use Snowball, Snowball, depending on the size of your data sets. And then DataSync helps you to do data migration as a one-time copy and ongoing synchronization so that your primary workloads or storage, perhaps on-prem, you're still able to bring it across to what you call it, the cloud as a backup. Use of your machine images and your Docker images, obviously very important because it's pre-bundled with all your dependencies, applications, etc. And so this must be one of your key features in your DR recovery strategy. Make sure that you have access to your machine images, and you can copy these machine images across the regions as well. But recall Image Builder. If you use that, then you can always distribute your custom images across accounts and across regions, right? I highly recommend you do that. And then for your ECS, your custom container images, make sure that they are in your repository. Maybe you have a mix of ECR and your Docker repositories as well as backup. So don't have a single point of failure, in other words. Excuse me. So failover network design, you have the Route 53 for weighted round robin or for primary failover. You have choices there. Load balancing within one region across two availability zones. You can load balance across there, and then VPC in terms of capturing that as a top formation template so that you can quickly roll out the VPC when needed in a DR type of situation. And then Direct Connect, basically the dedicated network link between your on-prem and your VPC cloud. Now, RDS, you have full daily backup, as I mentioned before, as well as your manual snapshots, so that you can, if there's a data corruption, you can roll back to a point in time. Also, in terms of multi-AZ deployment, gives you primary and standby, right, across two. So if one goes down, the other, the standby will be promoted, and the failover will, will occur automatically. Also, read replicas are useful in terms of backup and recovery because read replicas can be placed in another region. So your main RDS primary database is in Singapore region. Your read replica could be in the Sydney region, right? And it has asynchronous kind of copy replication. And if the primary goes down, you can promote that read replica to be a new primary. So that is again possible. Snapshots of your database can also be copied across to a separate region. So plenty of choices here. DynamoDB within a region, you've got redundancy across availability zones. You can back up your data, your DynamoDB table in seconds, basically, no matter how big the size is, and you can have that global table for cross-regional type of backup situation where you could have local DynamoDB tables in different regions who are synchronized together through this global table. So all these are functions that give you more depth and resiliency to your database, DynamoDB database. You can't run away from these templates. If you need a fast DR strategy, you have to use templates because that is the means by which you can roll out your DR infrastructure automatically and correctly instead of doing it by hand. And then you use scripts to do bootstrapping, etc., right, to update your servers, etc. So a combination then of your templates and bootstrap scripts to ready your DR environment. We want to highlight to you this particular service called AWS Backup. A centralized backup strategy is critical, right? We need to maintain backup failures all in one place. So you may be using EBS, you may be using, let's say, your RDS, DynamoDB. These are separate services. And sometimes, to go into each separate individual service to kind of figure out the backups, not very convenient. What you want is a central backup service that can back up across different AWS resources and services. And that service for us is called AWS Backup. where it can back up your EC2s, it can back up your DynamoDB, your Aurora databases, your RDS replicas, your file storage. So there's good news. You don't have to go to individual service to configure backup now. You can do it through AWS Backup. And if you take a look at this hybrid, where perhaps you have a storage gateway that will back up your data that you want to archive into the S3 bucket on cloud, then this AWS Backup can back up your storage gateway resources as well. In addition to that, these other resources, as I mentioned, is also available to be backed up by AWS Backup. So cloud native backup for all these services can be covered by AWS Backup. Your hybrid situation where you want to back up data from on-prem to the cloud, your storage gateway can help you do that. And then once they reach to the cloud, we can have this AWS Backup to back up those cloud-based resources. Okay. Now, of course, this is on-prem. Some of you are also doing this where you have your backup software and you have your tape backups, etc. But if you have hybrid, then you can start to use things like storage gateway to be able to back up to the cloud. So the common backup strategy or challenges is complexity. If it's different backup scripts for different resources and no centralized monitoring, then who knows, we may have missed out certain things, and you don't want to wait for a disaster to find out that you have missed out certain things, right? So have that central service like a AWS Backup to do this for us, and to have difficult to enforce compliance when it's all distributed. You have many services to back up. To enforce that compliance is a challenge, and then it is time, material cost as well when you're hunting high and low for different individual services to back up. Is not very optimal in terms of the use of resources. So AWS Backup gives us the ability to back up all our cloud native resources. And basically we identify our resources maybe through tags that we want to back up. And we have a backup schedule, a backup strategy towards that, maybe full daily backup or whatever schedule that we want. And then basically we can recover the data. We can make sure that we can restore the backup files. We can do testing, obviously, and we should do testing regularly to make sure that what we backup is basically restorable. And you can have this encryption. Basically, the AWS Backup has a backup vault where all your backup data is, and that is encrypted. It is actually supported by S3 bucket behind the scenes. So this is how it works. You have all these supported AWS services, and then you have AWS Backup here. You kind of define your backup plan, your backup strategy, your backup schedule, and it will run and it will back up across the board, all these resources. So a single backup strategy or backup policy and schedule can cut across these resources. Better news is through AWS organization, you can then deploy common backup policies to all your AWS accounts under your AWS organization or within a certain OU to have a common backup schedule and backup policy. And also, they can have this cross-account backup. So within your AWS organization, you can say that, okay, I want to back up the AWS backup vault so that it's present not just in one account, but it's also present as a also backup copy available in another account as well. So all these are very attractive so that you are assured at multiple levels, compliance-wise, policy-wise, it's common, and then you have this cross-account backup facility available as well. So creating a backup plan, you have the backup schedule, you kind of have that, a time where the backup window happens, and then you assign the resources, DynamoDB, EBS, etc. And then it will run and you manage to monitor the backups. You may have maybe some Lambda functions that run on a particular schedule to test the restoration of the backups as well. And then the recovery strategies. The chief financial officer is saying, I know that goal is zero downtime, but I'm worried about how much this is going to cost me over time. So recovery strategies, different approaches depending on the criticality of the application and the cost factor. You can have a number of these strategies. The easiest, the cheapest is a backup to the cloud. So you send your backup files to S3 bucket and you have some form of life cycle policy here. And then basically during recovery, you can actually stand up your EC2 and then you, let's say through a S3 bucket endpoint, you can access the backup files and restore the application. So simple, but needs to be tested out to make sure that it can actually restore from your backup files. So this one is cheapest, and of course the SLA is, you have the longest RPO, RPO and RPO basically. Next step up is a pilot light example where you have the main production site and the recovery site, and you have sized the server previously. You know the machine image to use, the sizing to use, etc. But it is not running. Only the standby database node is running. So the main site is still the production site here on-prem, let's just say, and the users are directed 100% to this production site, and you have some form of database replication. The chief financial from primary officer is saying, like, know that now this is zero down pilot light because only the standby DB server is running. The others are not running, so it is cheaper. That's what it means. It is cheaper basically. If the main site goes down, well, then you have to redirect your users, detect the failure, redirect the users, spin up your EC2s to take over and promote this secondary node to take over as the primary. All right. So obviously that's going to take minutes, right? It's not going to be immediate, so there will be downtime basically. But it is lower cost overall because during the main production time, your resources are not running. Fully working low cap standby, this time resources are running but at lower cap. Main site is the on-prem, for example, and you have this, let's say latency, weighted routing from Route 53 to maybe channel 90% of the traffic to the main production site and 10% to this recovery site, because it is running, but it takes only 10% of the load. And then just be aware that the writes need to go back to the primary database, which then is replicated to the secondary database. So this is low cap, so it's still fairly cost effective, and you are assured that it is working because it is actually taking 10% of the traffic. When the production site goes down, the main site goes down, you basically, well, if you have a weighted routing, they will detect the failure and they will reroute automatically 100% to this low cap site, and then you have auto scaling to basically scale up the additional resources. Again, it's going to take time, and you may have certain outages, connection timeouts, etc. But at least some of the capacity is handled in the meanwhile, right? And this 10% as it grows up to 100%. The gold standard is obviously multi-active. That means each site is prepared to take 100% of the traffic at any one time. It's basically a duplication of resources. But advantage is you have the best RPO and RTO. When the failure comes in, this is really at full cap already. It can take the bulk of the load, maybe with slight, auto scaling adjustment, etc. But it's more or less prepared to take the full load at any one time. And so it is a spectrum of choices from very low to very, low cost in that sense to very high cost. But in terms of RPO, you're talking about hours here in backup and recovery here. Pilot light, you're talking about tens of minutes, 10, 15 minutes, maybe a little bit more. Warm standby, maybe within 5 minutes. And then more or less real time, you're talking about, what you call it, the best, the highest level RPO. But, the most expensive, obviously. There is AWS solution called Elastic Disaster Recovery. It used to be called Cloud Endure, DR, but AWS has purchased this companies, and so it's rebranded as Elastic Disaster Recovery. And basically, it uses a block level copy of your on-prem. This is your main site, for example, to your DR staging area, so they can't replicate all the data across. They have low-cost EC2 and magnetic disks to kind of just stage the environment here, and they are ready to stand up additional DR EC2s here that are spec'd or sized correctly, so that if there is a disaster, they will automatically do the cut over and fill over. They stand up this environment and do the cut over within minutes, so that you have a DR type of fill over. Okay. All right, our last knowledge check together. Which DR model offers a RTO in minutes at lowest cost? Okay, yeah, it's backup and restore is actually longer than minutes. It could be in hours, right? Depending, I mean, you have to test it out. The one that offers in minutes is the rest, but we want lowest cost. Pilot Lite is the one that is not too bad. It's tens of minutes, but it's still considered in minutes. So between A and B, A is of course much faster, right? It's a matter of maybe 5-10 minutes, but this one is slightly longer or longer a little bit, but it is still at minutes and lower cost. Whereas backup and restore is in hours, right? So the best answer is B. Which metric define how often data must be backed up? Select two answers. Okay, right. Yeah, the correct answer is B and C. Well done. So recovery point objective, how much data can you afford to lose? Obviously, that is one of the key ones, but also the rate of change, right? If your RPO could be 12 hours, but your data rate of change you found out is 24 hours. Well, you even if you have every 6 hours, does it make a difference? Because if the rate of change is so slow, right? So you have to take both into account, right? Which of the following are highly available resources by default? Highly available. Recall, what do we mean by highly available? Okay, everybody is good with the answers. Yes, very good. A and B is the correct answer. Net gateway is not, I mean, within the availability zone is quite redundant, scalable, etc. But remember, our definition of high availability is that it must be in 2 availability zones, at least 2 availability zones. Which of the following are features of AWS backup? Select 3 answers. I'm sorry. Select 3 answers. Okay, let's try to do one at a time. A, encrypted backups, that's true. The backup vault is encrypted. B, works across every AWS service. That's not true. Not all services. Works across multiple services. That's true. DynamoDB, EBS, RDS. It kind of works across that. V, designed for cloud native workloads. Yeah, it's designed for cloud native workloads, basically, across these multiple services that we mentioned. So it cannot back up for your on-prem. Basically, that's what it means. Continuous data replication, it doesn't do that. It's based on your backup schedule and backup window. It's not continuous. Continuous data replication is something that what's that? Cloud. It used to be called Cloud Envio. Anyway, I'll go back to that slide again. This elastic disaster recovery. That one has continuous data replication and automated machine conversion. So that is the elastic disaster recovery solution. So the correct answer is A, C, and D. So basically, this one it has this continuous data replication and machine conversion to your production, and the cut over is fast. So this is more for disaster recovery, but backup doesn't do that. Which is the best way to make an existing RDS-DB instance highly available, and minimize your RTO? this is the question. Best way to make existing DB instance highly available. What's the best way and minimize the RT? Now, A, run a secondary copy of your DB instance in another region. This one, when we do this multi-AZ, you don't, the standby must be in the same region. You cannot do that kind of failover across the region. Okay, so the best answer is multi-AZ DB instance in the same region. So primary node, one AZ, secondary standby, another AZ, for multi-AZ deployment. Right, we have done that. Try to do that in the labs. Now, this two could be possible, in terms of a DR, but it doesn't give you the failover, the automated failover. Right? These are read replicas, so they take only read operations and they are asynchronously replicated. That's number one. Number two, if there's a failure, you have to have some form of script or action to promote this read replica to become its own master and do that fail to repoint all the traffic to this new master. That's not automatically done. You have to kind of handle it yourself. Now, the key difference in this multi-AZ deployment is primary, secondary. If the primary goes down, the failover is automatic. They promote the standby automatically, and the failover, the traffic will now point to the standby. That's automatically done. So you minimize the RTO. Another point to minimize the RTO is synchronous replication between your primary and standby in a multi-AZ deployment. Synchronous replication. So that is another plus factor. But the question is asking for RTO, and the RTO comes because it is an automated failover, right? This one you can, but it takes more time because the failover is not automated. So best answer is A, B. Okay. All right, that comes to the end of the lectures. I want to quickly try to go through this lab. Please go through this final lab, and although lab number 6, and also you will have the capstone lab. Okay, so lab number 6, basically you want to set this up, CloudFront distribution for static content as well as dynamic content. The static content S3 bucket, dynamic content will be the application load balancer, and so they are going to pre-build a CloudFront distribution for you. You go ahead to create the S3 bucket and you configure it for public access. You upload the bucket. You're going to add this bucket as an additional origin. You're going to use CloudFront origin access identity, and then you're going to test whether with the CloudFront origin access identity, whether you can actually access it directly or not. And then lastly, you're going to test the access to the object using the CloudFront distribution, right? So that's, in a nutshell, the lab is a nice lab to get for the CloudFront distribution. And so also just a reminder, the capstone project is lab number 7. So you kind of do that access, same thing, quick lab access capstone project number 7. However, the instructions is found on the online course supplement, the OCS, not on the quick lab. The quick lab instructions is not there for capstone. You access the lab in quick lab, but the instructions is in the online course supplementary that I showed you earlier. So be mindful of that. So basically, I'm going to hopefully stay back with most of you to do this last lab, but be reminded to take every opportunity to finish the labs. And in terms of the web pricing that KSM was asking about, you can just Google the web pricing here, and they charge you according to the number of rules per month and the requests per month as well. I have to correct myself. The web, the capacity units is not directly charged, but the capacity unit determines how many rules you can run, because each rule that the web firewall evaluates takes some form of a capacity, and so they allocate like 1,500 capacity units to your web. So that limits the number of rules, or that determines the number of rules that will be can be created. So very complex rules take more capacity. That's basically what it is. And if you need to request a higher capacity, you can ask AWS support to grant you the extra capacity and support your use case. But the more rules you create, the more you pay for it. Okay, that's basically what it is. All right, so please go ahead. So those of you can stay back to do the labs, but those of you who are leaving, just want to bid you a very all the best and a very big thank you for spending 3 days, three long days with me. I really appreciate your patience and your perseverance, and thank you for being a wonderful class. I really enjoyed your questions. If you do have additional clarifications, questions, please stay back and ask me now. But if not, if you're leaving, I just want to bid you a goodbye and all the best for your exam prep and your future projects and career development. I hope to see you in a future AWS course. And meanwhile, have a pleasant week ahead and over the weekend with your family and loved ones. And I hope to see you again. All right, goodbye and all the best to you. And those of you who are staying back for the labs, do take a short break and I will stand by to assess you. Or if you want me to address any questions, please do so as well. All right. But for now, at least officially, I bid you a big thank you and a goodbye and see you again. Thank you. Yes, Chik Hong, the lab expire next Monday, 28 March, 11:45 p.m. Singapore time at night. Right. So you have Thursday tonight from now until Monday night to finish your labs. All right. Hopefully all of you will be able to do that. Right. Remember the capstone as well. All right. Thank you, everyone. Thank you for your kind words. And again, really appreciate all of you and hope to see you in the next course. And also hope to see at least some of you stay back for the labs as well. But if not, a very nice evening and goodbye to you. Thank you so much.
Thank you. Bye.
Thank you. Goodbye.
Thank you.
Thank you very much.
Thank you.
Thank you, everyone.